guys, greetings from Bulgaria. I'm Anton, and this will be the next module out of our Advanced Test Automation Framework Development course. We're going to discuss how to build API core components. But before starting, please subscribe to the channel, hit the ring bell so that you get notified when new videos are published to the Lambda Test YouTube channel. Also check the awesome Lambda Test blog because there are many advanced articles that can help you to be a much better test automation engineer. And as always, in the links below you will find all the reference articles to the topic that we are going to discuss together with the GitHub repo. I suggest to clone the repo and work besides me. Here is the repo. For this particular course, I'm not going to create separate repos for each module, but everything is inside this OWASP test framework. And for each module, we have a separate branch. So you need to check out this API core components branch. And since there is a lot of code, I suggest to clone the repo and work together with me. Also in the links below, you will find jump links if you want to skip some parts and just listen the parts that you want to hear. Here you can see all of the groups part of this big course. This is not the specific module by module list, but rather all of the core groups. In the previous module we covered again and we discussed this operational excellence, right? When we discussed other topics. And now we are going to return to this group, building core components, talking about API. But why API? We're not going to focus actually on API testing itself. Of course, initially I'm going to give you a short overview. I'm sure that most of you are familiar with web API testing, but we are going to cover what is a web API, what is web API testing, what are the popular tools and libraries, and why you need to care. And of course, here my emphasis for integrating that into our framework will be more about using web APIs for test data preparation and verification and how we can integrate that together with our current solution for web and mobile. For example, creating BDD logging and toast messages in Lambda test, or also we'll include some retry logic into our API client adapters and so forth. So a big part of this module will be focused on this API project structure of the adapters, of the plugins, and so forth. Still, you'll be able to use this project for API testing as well too. This is really important. However, again, we're going to focus in the third part about this API project use cases. In our case, this will be the integration with test data preparation, verification, etc. We're going to use a lot some of the previous more advanced design patterns like factory, repositories, and builders. So I suggest to check the links below. You will find links to this design pattern series. So yeah, let's begin. First, let's discuss API testing. API testing is a critical aspect of software testing that focuses specifically on evaluating the APIs within the application. APIs serve as a middleman that allows different software components to communicate and interact effectively, ensuring that these interfaces function as intended and meet various criteria related to functionality, performance, reliability, and security. And API stands for Application Programming Interface. No matter where every instance you use, in every instance that you use an application, for example, to send, receive payments, to check live scores from your mobile, you're already using an API. Or even when you scroll your Facebook or TikTok or Instagram, they heavily use APIs. So API defines a set of rules and protocols that allows different software applications to communicate with each other. There are a bunch of technologies used, for example, GraphQL, gRPC, but mainly now we're going to focus on REST web APIs. And again, many apps nowadays, they use APIs which allow systems to interact with each other in real time without any user interventions. To demonstrate that, I'm going to use a previous application that I developed for our design pattern series. Is this music management application. It's basically just exposing this SQLite database that has some genres, tracks. It's a simple database that have many tables like tracks, albums, purchases, customers. That's it. You can download this application. It's called Music Shop Frontend. You will find it in the show notes below. It's Node.js application to get a front end and a backend written in Node.js. So this Node.js is this server that will provide endpoints to all of the CRUD operations. For example, for this particular table to be loaded, if we reload here the page, let's open again the DevTools. If we remove the filter now, and if we refresh, you will see that my front end is making a web request to this particular endpoint right here, localhost API artists, and this is returning a response in a type of a JSON. And then later, through JavaScript, we have a binding to this particular grid where we're just displaying the data, and similarly for all of the updates, delete, for example, for these show invoices, we're doing a similar web requests, right? As you can see here, we're doing another web request to another endpoint, API customers invoices. So yeah, this is how this works. We are doing web APIs to these endpoints, and again, if we return to the music shop that I suggest you to clone, right here, again, when you start the application, our front end through JavaScript will make requests, and then inside our endpoints in the backend, on the server, we're going just to make a SQL query to the database, and we're going to convert that to JSON again and return it. This is how this works. Again, I suggest you to watch the modules about design patterns, specifically about repository and builder. Right now, I'm not going to focus more on this particular application. The whole point was that I already I wrote some WebDriver tests and I used some popular C# libraries to code these APIs to insert some data via the API so that I can test that later, right? This is what I meant by this test data creation. But before we move to the actual implementation, again, I want to just give you a quick overview about API testing, right? So API testing, it's a crucial part of the software testing. And again, I don't suggest always just to have system tests. On the opposite, you need to have a lot of API tests. And you can use this module to do that. Again, this won't be our focus. So this API testing, it's a crucial part of the software testing as a whole. It focuses on ensuring APIs function correctly within an application. And these APIs, they serve as middlemen again. We have different types of API tests: functional testing, performance testing, load testing, stress testing, spike testing, scalability. And this API testing is essential because it ensures that APIs work as expected, delivering the correct data and supporting reliable software functionality. It's also crucial for security as APIs are often targeted by cyber attacks. By testing APIs truly, you can identify vulnerabilities and prevent potential security breaches. Again, this is separate. We're not going to focus on that. There are other modules on the Lambda Test YouTube channel and online that you can find about that. I would suggest and put into the resources this awesome article on the Lambda Test blog called "What is API Testing? Guide with Examples." Please check it out. There are many examples about everything as I said. And now let's return here and now explore our API project explanation. I want first to give you a glance of what we want to achieve. If you remember, we have integration now within our framework to execute tests in the cloud. And this is exactly what I did. As you can see, this is our current application here. We caught a bug because the names are not displayed. But the important part here that I want to show you is these toast messages. If you pay attention, you will see that we are making post requests and we are not printing like before where we're clicking or what we are typing or what we are verifying. But instead, now in the video, you can see what data we are creating. And this will be what we will try to achieve. Again, we're going to use these web APIs and all of the CRUD operations to insert or update the proper data, and later, after the test has been completed, to clean our test environment and delete the data that we created previously. There are some more advanced patterns that I'm not going to cover now. Again, the builder design pattern. Instead, just check the videos that I link below. But this will be something that we are going to try to achieve. In order to do so, I wrote a very big book about API testing. Again, some people use Postman for functional manual testing. It's excellent. Some people even write automated tests using it. Again, my preference is always to use C# or Java or JavaScript for that. And since our framework is built on C#, now I'm going to show you different possibilities, different libraries that we can use in our framework. The first popular choice is called 𝑨𝒏𝒕𝒐𝒏. And 𝑨𝒏𝒕𝒐𝒏 is distributed via a NuGet package, like others. It's a very popular framework, popular library, sorry, for API testing, maybe the most popular among all of them. So it's very simple how to use it. When we initialize our REST client, this is the class, the main class that we're going to do to perform all of the GET request, POST request, delete, etc. We need to initialize it via options. For example, right here, they use simple authentication because many often, this is a big part of using APIs, is that you need a way to authenticate, whether via tokens or username and a password. Then you create REST request. Usually it contains part of the endpoint. Usually we provide, when we initialize the client, we provide the base URL that we have one client per endpoint or per HTTP repo that we are going to use. This is the usual approach. This is why we usually have one base URL, and then we just provide the parts of the endpoints that are different. And after that, since this is a C# library, it's built asynchronously, meaning that you need to use await and async to use it. That's it. Another choice, this is the GitHub repo. As you can see, it has almost 10,000 stars. Another option is a new library, a new port by 𝑣𝒏𝒕𝒐𝒏. He ported the popular Java library called 𝑟EST_assured to .NET. To be honest, if I would always prefer to use REST compared to REST_assured. I'm not a huge fan of this fluent syntax that it's a BDD style. Nothing against REST_assured. We're using it heavily in Java projects, but still I prefer for C# to use REST#. Another alternative, very popular again, if you check the stars count, it has twice less stars. It's called Furrow. I have included that in my book as well. It has another type of syntax that it's using again, fluent interface, fluent syntax with these dots and chaining methods. It's a matter of choice. Again, I prefer the syntax of REST#. As you prefer, but again, in this module we're going to use REST#, but I give you options. You can pick one of them. All right, so if we go now to our solution, you will notice that right here I have added a few more tests that we are going to explore in a minute. But for now, we're going to focus on this new project, 𝒏𝒐𝒏 API. In this 𝒏𝒐𝒏 API, if we open the project, this is the MS build definition, I have added a few important NuGet packages. The most important one is the REST#, and it's a realizer for 𝒏𝒕𝒐𝒏 Since all of the REST web APIs, mostly 99% are working with JSON, I usually prefer to use this 𝒏𝒕𝒐𝒏 which is like a standard. Another popular library that is used together with REST# is called Poly. In this Poly library, is here, you can, it's right here, this GitHub, I will include that in the description below. This Poly library is a popular .NET library for retrying mechanism, and usually it's used together when you build microservice architecture, right? Because when you connect multiple API services, many of them sometimes are down because they are deploying, etc. And this is why you need such a library for retrying, circuit mechanism, etc. We're not going to use it in full, but rather just for retrying technique. Why we need a retry, and why we are going to create an adapter for and not just use directly REST#. We're going to create an adapter. If you remember from the web and mobile projects, we created adapters, and these adapters, they basically have a reference to the thing that we are adapting. In previous cases, these were Selenium WebDriver and APM. Right now we're going to create an adapter for the REST# client. And here with the adapter we are changing a little bit how we use the library itself. We are going to provide new signatures for the methods, and we are going to add new logic. In our current case, the new logic will be that we are going to integrate this Poly here in order to introduce possibility for retrying mechanism. Why you need that? Because in my experience with big enterprise projects, usually when you need to build system tests for your front end, you are part of one team, right? And you're building these system tests, and you're using the APIs most of the time built by other teams. And these APIs, they're out of your control. You don't know when these other teams will deploy them or whether these services will be down. Even if this is just for a moment or for 5 minutes, let's say, you don't want these downtimes of the test APIs, because you're not going to test the API itself, but you're going to use it to create test data or verify something. You don't want this to fail your tests. This is why in these cases it makes sense to have a retrying mechanism, and this works excellently. Another thing that we are going to improve is that if you look into the REST response, that is the class that comes with REST-sharp about responses, you will see that you don't have information about how much time the request and the response, how much time it cost, right? And how much was the time needed to do this particular request. And sometimes it makes sense to assert that. For example, you can, especially if you do API testing, it makes sense to, for example, throw an exception if a particular API is too slow, right? And you can assert that. So this is why one of the main things that we are going to look now is this API client adapter. Another thing that we are going to cover are, of course, all of the plugins and this plugin architecture. This is another thing that I added to our adapter. If you remember, we used events and delegates and also the observer design pattern to create this plugin architecture, and we are going to add another layer of plugins just for this API client adapter. And this is how we're going to implement the toast messages and the BDD logging that I told you that they're really powerful. Why? Because many often when you use this type of test data setup in your system tests, if you don't have such a mechanism to see what requests you did and what type of data you created, it's extremely hard to find the actual reason later just from the videos, right? Because like half of the test is about initializing this data and then deleting it. It will be great if you have a trace in the video or as a type of a log. What I mean by log, it's this type of BDD logging here. This is what I created right here, right? You can see that we're doing some kind of a post request against albums here, and the exact data that we created is written right here in the walk, and we can create files about that. And when you walk the bugs, you can include the walk or just provide the video, and in the video is visible what you created, right? And this type of walk can be visible in your continuous integration as well, in Azure or GitHub Actions, etc. So this is why we need to include this plugin architecture on top of everything. Okay, let's return now to our adapter and let's quickly review how this works. Again, I suggest to clone the repo, work with me. I'm not going to cover all of the details because there is a lot of code, and I want just to show you the most interesting parts of it. So again, I call this API client adapter. It's disposable, which means that, as you will see in the base class, we need in the end of our test to dispose it, otherwise there might be some leaks. So we are initializing again this wrapped client, the REST client, which is the native REST-sharp REST client. Also, we are initializing this policy class. As you can see, it comes from this poly library that we installed. And in a minute, we are going to cover this special class, API Client Plugin Execution Engine. If you remember it from previous modules, this is a special engine for executing all of the plugins. Basically, depending on the implementation, here we are triggering specific events, or we are just for eaching all of those methods for all of the plugins. If something happens, if there is a problem. Again, we have two special properties: how many times we want to retry if there is a failure, and whether we want a pause between the retry. I won't now go to all of the methods. Right here, I implemented all of the CRUD operations, post, get, put, options, etc. However, all of them are using this core private method called execute measured request async. As I said, one of the main things that we're doing here, extending the main logic, is that we're going to start a stopwatch, meaning that we are going to measure the time required to perform and complete the request. And we're going to save this information. And we are preserving it in this model class, which is our custom class. It's called measured response. It holds a reference to the REST response of 𝑨𝒏𝒕𝒐𝒏, and the only additional thing that we are adding here is the execution time needed for the request to be completed. So inside this execute measured request async, as you can see, the parameters that we require are again REST request, the type of the method, and a cancellation token, which is used for canceling the asynchronous operation. Again, this is out of the scope now to discuss await and async. I suggest to check the MSDN about that if you're not familiar with how to use async await in C#. But yeah, we are initializing this retry policy. Again, this is the core reason why we installed this library poly here. I just copied that from the documentation, and we are saying wait and retry async. This is going to configure our retry policy. We're basically initializing and providing our properties, the max retry attempts and the pause between failures. And after that, the retry policy has this execute async method. You can provide an action method, or like in my case, I'm implementing asynchronous anonymous lambda expression on anonymous methods. Basically, we're going to execute this particular piece of code every time, and we're going to retry it if this fails. So we are starting a stopwatch here, and right here in the middle, we are actually using the actual REST client to execute the actual request. However, as you can see, the other additions to what we are adapting is that we are executing our plugins here before the request and after the request. And if you recall here from what we did, this is the point where actually we are going to trigger this BDD record, BDD logging, and the toast messages. These are the places where we're going to create our plugins. And after this has been complete, and if everything is successful, we're going to stop the watch and create this measured response. And the only thing that we add here is the elapsed time in seconds. Yeah, that's it. Nothing more really special about this adapter. Now, how we use that? Again, we have two base classes, one for MSTest and one for NUnit, and one app class, similar to our architecture for web and mobile. In our NUnit base class, this will be the base class for all API tests classes. We have an instance and a property to our application class. After the class, on the class cleanup, we are disposing the API client. Again, this is really important. And during the configuration phase, we are adding all of the plugins. Please note that there are different types of plugins. Again, this plugin execution engine, it comes from our core project, and this is extending NUnit and MSTest basically on a larger level. While this API client execution plugin, it's responsible for extending only this particular adapter, similarly to what we did for our web and mobile components. In a minute, I'm going to cover how this API BDD plugin works. If we see our demo project, if we see our demo project, you will notice that we have now a special folder here, API, right here, API. And you will find the test that I showed you the video for is this data-heavy web tests. But before that, I want to show you one real web test. These utilities tests, again, it's not important what they actually verify, but it's important to know that we are deriving here from this API test. This way you will have access to our app class that has an access to our API adapter. Also through the API adapter you can add headers, as you can see here. Also you will note that we can use regular n-unit assertions to check whether something is successful or not, or we can use our framework's capabilities to do that. For example, I have added this type of library for example, verifying that a response has been successful, checking about particular status code, checking about response headers, or that the content contains something, or checking the encoding, and so on and so forth. Or we can verify that since we are working here with models, we are not working with JSON files. Please pay attention to that. We actually, 𝑨𝒏𝒕𝒐𝒏 is really powerful, and it can work directly here with these model classes. Again, you can watch the video about HTTP repositories in a minute. Really quickly, I'm going to give you a refresh, but I suggest to check this video about HTTP repos first. But we have these model classes. A model class here regarding the this type of API testing is just a normal class that contains a few properties that are basically the representation of our JSON that you saw in the JSON response or in the body when you want to create something. And 𝑨𝒏𝒕𝒐𝒏 through Newtonsoft JSON will serialize and deserialize these C# classes to JSON and vice versa, which is really powerful because you're not working with strings, but rather you're working with actual C# objects, which is really cool, right? So where I put all of those assertions? Well, I created another folder here called assertions, right? Similar to our validations for what we have for web and mobile. As you can see here, I'm trying for all of our core projects to have a similar design and architecture, and when someone is using our framework, then it will be much easier for them to orient and follow our design principles and architecture and implement the plugins in the same way. So the most important part of these assertions is right here in these API assertions extensions. I implemented all those assertions as extension methods to our measured response. As you can see here, we have assert content contains. This is a static method. We use the special keyword this. This means that we are extending this class, measured response. And from now on, when you include a using to this Polaris-wide API, all of those methods will be available for you as they were part of this measured response class. One thing to notice here, these are the actual checks here in these if statements. If the condition has been not met, then we're throwing a specific API assertion exception with specific exception message. And on top of that, I added events here. And through these events, we are going to implement the toast messages and the BDD logging. The way this works is very similar to what we did in the past. We have this abstract class, assertion extensions event handlers. We can subscribe to all of them. As you can see, we are calling these static event handlers. If you return here, as you can see, all of them are static, right? So this class will be the base class for the implementation of all of the plugins that need to subscribe to all of those events. As you can see here, we have these two methods, subscribe to all and unsubscribe. And as you can see, we have a bunch of virtual protected methods that are completely empty. This means that if you don't derive from this class, nothing will happen, nothing will be executed. However, why we do that? Because I don't want always to copy paste this particular code, and if I add new events or new methods, I'm just going to add them here without any breaking changes. And for example, the BDD logging for the assertions is implemented in this way. I'm deriving from this base class assert extension event handlers. I'm overriding this subscribe to all and unsubscribe to all. You will notice that I'm calling the base subscribe and unsubscribe, but only if my API settings is saying that we need to enable the BDD logging. Again, I suggest to check first the module about configuration. If you remember, we have two types of configuration, static ones and the ones with files. Right here, I implemented the static version. So inside this folder, settings, I am following the same architecture using these static settings classes, implementing these commands. So these API settings, as you can see, all these properties are static. We have configuration for the base URL, for the quant timeout settings, for the max retry, pause between failures, and whether the BDD logging and the toast messages are enabled. And we have a similar API configuration loader that, depending on your environmental variables, and if you remember, we can switch that from command line. We can load different set of settings. Right here, I have configured the default ones, but you can have different environments with different settings. That's it. As you see in our demo project, this is important. You need to call this loader inside our assembly setup, assembly initialize. This global setup, one-time setup, will be executed once for the project. This means that once for the project, you're going to load all of the settings depending on your specific environment. So, yeah, about the BDD, again, you can enable it or disable it. If it's enabled, then this will be executed. We will subscribe to all of the events, and these methods will be executed. And here I implemented the BDD logging in the similar way how we implemented that for web and for mobile. We're using our logger that we implemented in our core project. Again, depending on your global settings, this can be inserted into the console log right here and in your continuous integration system, or in the debug output, or in a file, or someone else if you have another implementation of the logger. So this is how this works. You will notice that I have one more folder that is called plugins, and this is regarding the actual plugins for the API client, as I said. So right here I implemented, in a minute I'm going to cover the authentication really short. Again, this won't be our main focus. However, I implemented such a plugin, and I suggest you to check this too. However, my focus will be on these three classes here. So I have this base class. It's very similar to the base class that I showed you before for the assertions. It's called API quant plugin, and we have methods enable and disable, or you can use the word subscribe to all and unsubscribe as you wish. You will notice here that we have similar event handlers that are static, that are part of this API client plugin execution engine. This execution engine is responsible for, we are using it in our API client adapter, if you remember. So in our client adapter right here, if please pay attention right here, we are executing and we are using this API client execution engine before executing the actual request and after it. So this API execution engine, it actually contains similar static events on quiet initialize, on request timeout, before making the request, after making the request, and if it failed. And again, here we're just invoking those events in all of those static methods, nothing more. Basically, in our API client, we're just invoking all of those events. And in this specific base class, we are subscribing to all of those events or unsubscribing. And as you can see, they are protected, virtual, empty, meaning that if you don't have an implementation for this client plugin, nothing will happen. However, I have an implementation for it. It's called API BDD plugin. As you can guess from the name, here again I have a very similar implementation. If the BDD logging is enabled, then we're going to subscribe to all those events or unsubscribe if we call the disable. And then after that, I'm just overriding all those protected methods to all our core project logger to create all of those logging events here. This more complex logic here using the string builder is responsible for generating this sort of these logs where let me expand it for you, where we're printing each property and each value for it. So we're using this syntax with the string builder, right? Again, you can check it. It's not the important part that I wanted to discuss now. But again, we're using this base class and we are going to use it again to implement our toast messages. The way the toast messages are integrated is very interesting. Actually, now in our web project here, right here, I added a dependency to our API project now. And why is that? Again, many often in your web test, you will want to have an access to be able to do web requests in order to initialize the data using HTTP repos, Oracle, other third-party libraries through APIs if they don't have an actual C# SDK. This is why here in our NUnit and MS test base classes in our base web test, I have added, as you can see here, another property that is called API app, meaning that we will have access now to our API client now. This API app, in a minute I'm going to show you what's inside, but basically we have a reference to our adapter, we have other methods through reflection to add plugins, that's it. And also here in our configure method, I'm loading all of the required configurations for the API and the web configuration so that you don't forget for them to be executed. And the last thing that I added to our web project, under the plugins namespace, I added this namespace called API now. And I created these two new plugins, API Toast Messages plugin and Toast Messages Logging Solutions. Why I did that and I haven't put that into our API project? Because in order to trigger, if you remember how the Toast Messages work, they use JavaScript and we don't have access to our WebDriver in our API project. But now our web project has access to our API project. And this is why here our API Toast Messages plugin, it implements this API client plugin. Again, don't confuse it with just the base plugin class, that it's a bigger plugin that is extending NUnit and MS test. This is just extending and giving us access to the events of our adapter before making the requests, after making the requests, on a timeout, That's it, and we can execute some logic there. So again, we can enable and disable that if this property about the toast messages is on and off. And after that, I'm creating a new instance of our driver adapter and calling our info toast messages. Basically, the whole logic here is the same, but instead of calling the logger, I'm calling our driver adapter and this info toast messages. That's it. Actually, when there is an error, actually you can call, instead of info, the error toast message. Maybe this will make sense because it will be in another color, which will make you easier for you when you watch the video to troubleshoot easier. And lastly, if we return to the API project now, I want to show you one more thing. If we return to this test class, you will notice that I have one setup here that it's commented, and I put this on purpose. This is the original syntax how we initialize the authentications for regular REST. We need to create this authenticator where in this case this OAuth2 authorization request header, we need to provide the token. We need to provide this special token and then provide it to the constructor of REST or to the options class. Again, as you can guess from our usage, this cannot happen, or you need to put that into your static settings, which is not the best practice. Instead, I implemented another approach using this type of attributes here. We just provide the type of authorization that we're going to do, whether this is a basic, OAuth2, or we support all of them. And we provide here this token as a parameter. Again, when we talk about security, we're not going to plan and paste that like that, but instead we're going to load that from environmental variables or key vaults, etc. But again, the point here is that we use attributes to implement that, and we have a plugin, special plugin in our API projects to support that. You will find that in our authentication folder. In our authentication folder, we have this API authentication workflow plugin right here that it's executed before test class initialize, when we initialize the API client adapter, which has a property to this authenticator, and each of those attributes that I implemented for all of the strategies, it implements an interface that gives us and initializes the proper authenticator here, get authenticator, and this is how we're going to initialize it right here. So for example, the OAuth2 authorization attribute right here, it implements this get authenticator. It returns, because all of the authenticators in REST, they implement this iAuthenticator interface. I'm returning always the interface, and here I'm implementing this OAuth2 authorization request header authenticator. That's it. Again, this is a little bit out of scope, but it's really important for how our APIs work. Now, lastly, I want to show you how actually we use that to create data, right? Again, please watch the videos about HTTP repos, about HTTP repositories. In short, the repository pattern is widely used design pattern that abstracts the way objects are stored, retrieved, and manipulated from databases and application. Right here, I call that HTTP repo because we are doing mainly CRUD operations like insert, update, delete, right? Get. Many people prefer to use another term called client, which is suitable if you have many other methods, not just working with the data. I was thinking that it will be useful to have this abstract HTTP repo here. As you can see, it accepts these model classes that I showed you before, like the album and the track and the invoice. Basically here, instead of using regular res-sharp like we did before in the videos about repository design pattern, right now we're using our API client adapter so that you have access to all of those plugins about toast messages, BDD logging, and retries. And right here we are implementing get by ID, get all, create, update, delete, etc. And usually we use together with the repos. We have another pattern. We use factories. These factories are right here. I have implemented the repos like here, the repositories. So I have implemented the repositories for all of the entities part of our music shop app. We have all of the models and all of the factories. And if we look inside one of the factories, I use one popular library for creating random test data. It's called Bogus, right here, this Bogus library. And it provides this faker class. In this faker class, it will create random integer, random text, random emails, etc. So this simple factories, this is called a simple factory, isn't formally a design pattern by the classic definition. Instead, it's more of a programming idiom or design technique. And the simple factory encapsulates this object creation process into a single method, often in a single class. But it helps us to initialize all of this test data here. So we have similar factories for generating artists, generating customers with random data. And later we have implementations of all of those repository classes. As you can see here, we are deriving, all of our repos are deriving from these base repositories here that are part of our Polaris-wide API project. And we need here to provide the base URL and just the endpoint. In our case, this is the endpoint, albums. For the artist, this is artist, that's it. And if we look in now, also you will find also links to our builders. Again, this is out of scope. You will find a link in the description about the builder design pattern. And here in this music shop tests, you will notice that this is not API, these are not API tests. Instead, this is web test. But now we have access to this API app, right? So that we can create the data. Right here in the test initialize, we are first navigating to our URL. And after that, you can see all of the toast messages. I'm initializing here all of the repos. And again, here is quite extensively, we are creating a lot of data. This was on purpose so that you can see all the messages connected. Usually we use patterns like our builder. All of the builders are connected here inside this test data director. But again, just for visibility purposes, I put all the repositories here, and we are creating artists with the factories. After that, we are providing the artists generated with the factory to the repo. We are making a post request to create the data. We're getting the result. Then we are initializing something else connected to the artist, and so on and so forth. But again, when you do all of those operations, all of those events for creating the data will be triggered. And this is how this BDD log was created, these toast messages were created, etc. Right? Which is excellent. And this is, again, why you need such a core project here. Because we may often, half of our test is actually about creating all of this test data beforehand and then deleting it. And this will help you to troubleshoot later all of the problems. Lastly, I want to show you something very interesting. This 𝒏𝒕𝒐𝒏 API. Again, we're going to use it in later modules. But what is this 𝒏𝒕𝒐𝒏 API? This is something, again, related to web APIs. This is why I included it into this module. But if you go to this website, 𝒏𝒕𝒐.com, support API doc, you will find that the Lambda test guys, they provided these excellent APIs. This is, by the way, Swagger, or called OpenAPI. So OpenAPI is a specification that describes what your API can do and how to work with it. And we use this standardized JSON or YAML format to do so. This documentation is vital for every project, enabling adoption and improving testability and quality, and basically it saves time and money. In July, like I think 200, I think it was like 5 years ago, version 3 was released, and it was previously known as Swagger specification. Yeah, so you have a bunch of tools for this Swagger. Many people use that for documenting their APIs. You can see here the type of the request that we want to do. You have versions, you can authorize, you can see the description of all of the parameters, some examples about the response. You can even try that here directly. You have APIs for 𝒏𝒕𝒐𝒏, for Selenium, for making automated screenshots, for Smart UI, for Cypress, and for many others. Why I'm showing you that? Because later it's very helpful, and in my company we're using this extensively in our enterprise projects. From time to time we need to build such plugins where we need something additional that isn't part of the WebDriver API, but we want to get something from Lambda test. For example, here you have you have some GET requests. When you know the session ID, and we know that, we can download the specific video for when the test was complete. Why we need that? Because, for example, in some cases for bigger clients, they have some security reasons, some certifications that they have audits for example, ISO certification. And we need to verify on a big release that everything was covered, right? But in Lambda test, all of the videos, most of the time it's preserved like for 1 month, right? And after that, all of the videos are deleted because they're taking a lot of space. And this is the time when you can just use this API, and make all of those requests and download all of the videos or all of the screenshots or all of the network walks, all of the console walks. Also, you can get, for example, when we talk about performance, we can fetch all of the White House reports, which is excellent. Again, there are tools that I wrote about in my book. There are certain tools like NSWAG Studio or this Swagger editor, that when you provide the YAML file, they can generate this documentation for you. But the best thing about it is if you look into the top here, they can generate the clients, all of the models based on this specification for you. Again, usually depending on the service, you will notice that here at the beginning you have access to this OpenAPI YAML file, or even here when you refresh the page in the network tab, you can find the right link and download the YAML file yourself, depending on the tab that you need. Just be careful. I prefer not to use the online editors. Just to show you quickly that I use the online editor. If your API is not a public one, I suggest you be very careful with pasting all those specifications online. Instead, they have there is another app called NSWAG Studio. As you can see, it's a desktop app. It has many more options when you generate all those clients for you. So I prefer always to use the desktop option, right? instead of copy pasting something that might be sensitive. There might be a security problem for that, so be careful. So what I did here, I generated actually all of those clients using these apps. They generated all of those interfaces for me together with all of the models that we used before that I showed you here for my models. But now I have them based on this Swagger definition. I generated all of those responses here and the requests, right? All of this is auto-generated. However, for the client, you will notice that right here, actually, I have API client adapter. Actually, I have right now, this is returning measured response. It's following my specific syntax. And in order to do that, I actually used the help of AI. I used ChatGPT right here. I provided the auto-generated code and I told him, please look into my adapter version and refactor it so that it's using my adapter now. And it's very awesome. It refactored everything. Like, I needed a few times to instruct it to fix some things, but like after 5 minutes, I needed only like maybe 10 minutes to refactor all of my classes, all of this auto-generated code now to use my API client adapter. And again, this is really awesome because this was auto-generated for me. And now, since I'm using my API client adapter, part of my API core project, I will be able to see when I use the 𝒏𝒕𝒐𝒏 API, when I download videos and everything else. I will have toast messages, I will have ∞ logging, which is really awesome, right? All right, so we covered many of the use cases again here. Every API, this was really important. This is why we built this API core project to our framework. You can use it for API testing, but also it's really important to use these APIs for test data preparation, test data management, and you know, when you create the data, you need to delete that. And we use together with a lot of design patterns like repository, factories, builders, and this core project, it follows the whole architecture and design that we had before for web and mobile. We use adapters, we use observer design pattern to build these plugins, and we combine that with the repositories. And we use Swagger and all of these Swagger UI and other tools to generate all of those models and later refactor them through ChatGPT to support our now BDD logging and toast messages. In the next module, it will be really interesting, we're going to build many third-party integrations into our framework, so stay tuned. Hi guys, greetings from Bulgaria, I'm Anton, and this will be our next module from the Advanced Test Automation Framework Development course. This time we're going to discuss how to add third-party services integrations into our framework. But before we begin, hit the ring bell so that you get notified when new videos are published to the 𝒏𝒕𝒐𝒏 YouTube channel. Also check the awesome 𝒏𝒕𝒐𝒏 book because there are so many advanced test automation articles that can help you to be a much better test automation engineer. As always, I suggest you, at least for this particular course, to download the source code. You will find it in the description below. And as you know, for this particular course, I suggest to watch all of the videos from the start. And for this particular module, when you clone the repo, you need to switch to this particular branch, third-party integrations. So yeah, in each particular branch here, we are upgrading little by little our framework, and this is why it's essential to watch it from start to the end. Of course, I'm trying always all of the modules to be like completely separate, but we are upgrading it. This is our GitHub repo, 𝑨𝒏𝒕𝒐𝒏 test framework. Also, there is one more app that probably you will need if you want to run all the examples. This is this TestWogin application. We have used it in other videos of mine on the Lambda Test channel. Here we're going to use it for passwordless login, single sign-on, etc. So clone both repos and let's begin. So I suggest to work beside me when you clone the repo and switch to the branch. And since there is a lot of code, it will be good to have it on your machine. In the description below, you will find also links to other helpful videos that I will mention through the discussions that probably will be helpful for you. For example, one of them are the videos about design patterns. There is a whole course, and we are using extensively design patterns in this framework design. And you will find other helpful articles as well. And you will find jump links if you don't want to watch the whole video. Here is a short overview of the course. These are just groups, are not the exact videos. This time we're going to talk about this advanced functionality and best practices, right? And this is the exact table of content or what we are going to discuss. First, we are going to cover how to integrate SMS and emails testing into the framework. We have covered that before, especially when we discussed passwordless login videos, at least in Java. Here is relatively similar. This is why I won't spend so much time on the exact implementation, but rather on how to integrate everything together into our framework and discuss all the best practices when we write such system tests. One new thing that we're going to cover is actually how to use Azure Blob Storage. This is like a cloud storage that we can basically upload files. And we're going to use together some other Lambda Test specific features, such as Lambda Test APIs that we developed in the previous module. And I'm going to tell you one more interesting thing there. We're going to cover the Lambda Test hooks that can, for example, you can instruct Lambda Test to take a screenshot, and we're going to use that later in a separate plugin that we're going to upload all of the screenshots or all of the videos for the whole recording. We're going to download it in a separate plugin and then upload it to Azure. And this might be beneficial in some cases where for big enterprise projects, sometimes for security reasons or when their requirement for certifications like ISO certification, we need to hold those videos much longer than, for example, usually these videos are stored for 2 weeks, but there we can store them indefinitely as a proof of what was tested. Then we're going to quickly cover some awesome Lambda Test features such as self-healing and smart wait and see how we can integrate them into the framework. And after that, through all of the discussions, we'll see a couple of integration plugins, such as a plugin for authenticating us into the application instead of repeating the whole code, another plugin for sending SMS on failure of very important tests. And yeah, so a lot to cover. Let's begin. First, let's discuss email testing. Again, please, if you're going to run all of the tests, you need this login application. It's a Node.js application that I have developed in the past. It's very simple. Basically, you can start it with a single command. I have already done that. It's right here. You can start it with the following command, node server.js in the clone folder, and after that you can navigate to localhost 3000. That's it. Also, later I'm going to explain how to use the Lambda Test tunnel, because this is a local resource, it's not a public website, and this is why we can use the tunnel for accessing such locally hosted resources. So this application, basically, it's Node.js application. All of the backend is present here in the server.js file. I'm not going to explain it now. And we have a few HTML files that are very long. They use popular libraries, frameworks, Bootstrap, etc. To create the UI. Again, if you want to learn more, you can check the detailed videos about single sign-on, master authentication testing, and passwordless login. So in this application, basically, we can log in with email and a password, their captchas, and two-factor authentication that we will cover in the module about security testing integration. But when you log in, you will be navigated to this profile here, where you can log out, you can update the profile, you can set up two-factor authentication, etc. Also, we have many other features, like, again, passwordless login that we are going to cover quickly. Basically, login through emails and the calls that we received later, through SMS, single sign-on, again, through Google, Facebook, and other service providers. We can register an account, activate one, request password reset, etc., and all of that. So, I have already created such tests and converted them to C# from our Java examples. One interesting thing is, again, let's quickly discuss what is passwordless login, right? So the passwordless login is it gives you the possibility to, passwordless login is authentication method where a user does not need to enter a traditional password to gain access to an account. Instead, other methods like OTPs or one-time passwords are used, biometric data, magic links, sent via email or SMS. For example, GitHub added support for passwordless login, Slack sends magic links, etc. And again, we're not going to cover the whole theory, but yeah, why does passwordless login exist? And the first common reason is security. Traditional passwords can be phished, guessed, or even brute forced. And while passwordless solutions, when implemented correctly, reduce this risk. And of course, usability. Remembering numerous complex passwords is challenging, and passwordless systems offer smoother user experience. And in order to support that, we can integrate services such as mail swap. This is one of the services. Again, under particular limit, it's even free. And here is their documentation about C#. You can use it as a NuGet package, and this is exactly what I did. Basically, they provide a few important classes. The first one is inbox controller, which allows you to create here a unique inbox or unique email every time. And after that, you can read all of those emails when they are received. We can wait for them here, or even we can send emails. In certain cases, the sent email might be useful. As I said, we might create a plugin where if some of our very important tests fail, we can send an email, or even better, we can later send an SMS, and I'm going to explain how we did that. So I checked this documentation. As you can see here, there are many different languages, programming languages supported, which is excellent. And in our solution here, I created one new project. It's called Polaris-wide integrations, and I'm going to put all those classes right here under this project. It's not referencing, for example, the mobile or web, because we don't want to create spaghetti code. And if we look into the dependencies, you will notice that right here I installed all necessary packages for all the integrations that we are going to discuss. The first one is the mail swap NuGet package. The next one, even this one probably you don't need 𝑨𝒏𝒕𝒐𝒏 because we are referencing our API project. The reason for that is that some some third-party libraries don't provide C# SDKs, and in order to use them, we need to use their web REST API, and meaning you need to do like proper web requests to use them. Twilio will be the next library that we're going to discuss. This is used for SMS testing or even making phone calls. And in order to work with the Azure Storage Cloud, we need to install these two packages, Azure Storage Blobs and Windows Azure Storage. That's it. After that, I have a separate namespaces here under integration. We have Blob, email, SMS. I moved all of the auto-generated Lambda test API clients right here. And we have settings. Right now, I'm going to use this approach with the static settings. This is why I created this integration settings class. As you can see, we have static properties to the three integration services that we are going to integrate into our framework. We have a static property to our blob storage settings, to the Twilio settings, and mail swap. Right now, let's discuss the mail swap settings. They're very simple. We just need to get, when you do a registration, depending on your, again, you can start with the free account. Probably it will support up to a few thousand emails per month, which sometimes it's fine. After that, you need to pay for it. Again, there are different services. You can find here one more integration. It's called TestMu AI service that we are not going to cover now, but you can find more information about it in the video about email testing on the Lambda Test YouTube channel. So we need just the key. Again, all those keys will be initialized right here in the integration configuration loader. Most probably you can get them from environmental variables or later during the security module that we'll have later. We'll see how we can load that from, for example, Key Vault in Azure or Secrets Manager from AVS. But yeah, most of the time we're storing that in environmental variables. After that, instead of, I created this wrapper. It's a utility class that most of the time I prefer to use the word service as a suffix. This is a utility class that will help us to work with the SDK instead of, for example, here I added for you one example of how the test looks without that. Actually, here we use the mail swap, but yeah, if there is a node plugin, we will have to initialize many of the. It's very long, right? We always prefer to have these wrappers. If the SDK is changed, you can change it only here without affecting your tests. And moreover, usually the code, if you check here the documentation, sometimes it's very long. It has a lot of parameters, and most of the time you don't need all of this in your code. Instead, again, I created this static utility class. In a static constructor, I'm initializing getting from my integration settings API key. I'm initializing the inbox controller and the wait for API controller. This will wait for all of the emails. We have only two methods. One, create inbox without providing a name, or with a name if you want a specific suffix. Also, we have, this is very important, one method for waiting for the latest email. And here we are using this wait for controller API with some parameters. Again, as you can see, our specific method here, basically this is something like an adapter. So we are adapting these two interfaces, facade or adapter, and basically a static facade. Maybe it's better. And then we have sent email. Again, in some cases, this might be useful, as I said. And if we need to check how we use that, again, if we execute that in Lambda test, you'll notice that right now we have a new parameter here, use tunnel. And why we need that? In a minute, I'm going to explain what this does. But if you check the documentation, again, since this is locally hosted, this is, pay attention, even when I change that in my host file, this is actually run on localhost port 3000. And in order to access that outside of my machine in the Lambda test cloud, I need to run and use this Lambda test tunnel here. And I already started it. This tunnel, it's available for Windows, Mac, and Linux. And again, you need to, when you download this executable, you need to provide your user email, key, name the tunnel, that's it, and then it starts working. As I said, I already started it. As you can see, I use environmental variables, and on my Windows machine, I can access that through this syntax with percentage signs. That's it. But this is not the only thing that you need to change in our code. Now we need to provide a specific capability. And I modified a little bit the constructor of our Lambda test attribute. If you remember, this Lambda test attribute is responsible for initializing these grid settings that later we use in our driver factory to start the grid. So right here, because I didn't want to break all the existing tests, if I create and change just the single constructor, I added at the end this use tunnel parameter, but as default parameter. As default parameter means that right now it has a default value of false. By default it's off, and if I want to turn it on in the capabilities, I need to explicitly set it in my attribute, and this is exactly what I did in my test class. On top of that, I added two more parameters, default parameters here. If you remember, in the agenda, we're going to cover this auto-healing feature of Lambda test and the smart weights. This is why I added them here. And if you take a closer look below, here I added the tunnel, and this is my parameter. By default, this will be off, like this two. Yeah, in order to turn on, you guessed it right, the auto-healing, we need to set this capability and the smart weight right here. That's it. Again, later I'm going to show you an example for that. But yeah, if we return to our examples for emails, here we started the tunnel, and after that, when I try to log in, we navigate to the website and we click the email. This is basically the thing that I do is that I'm clicking here and I'm setting the email, and after that the code will be sent for me. And with the mail swap service, we'll create a unique inbox for me. I can even remove that. It's like we normally do. So I type the unique email address that MailSwap generated for me. Then we use the MailSwap wait for the latest email based on the inbox that we created before. So we will receive the email, and we are going to extract the code right here through this regex expression. And if we check, this is the account, this is the email that I received from this auto-generated email right here. This is the email with the code. And basically with the regex expression, I'm getting just this code here. That's it. Later, at the end of the module, I'm going to show you here a very interesting plugin for automatically authenticating us, but wait for it. Now let's see how we can do the same but for SMS. What I mean here is that instead of receiving an email with the code, we can receive the same message here with this unique one-time password, but as an SMS. In order to do that, we can use Twilio. Twilio is again a service, third-party service for giving you access to phone numbers for receiving SMS, sending SMS, making phone calls, etc. You can buy phones from all over the world. Of course, this is a paid feature, so yeah, all of those services are paid for the SMS, obviously. But yeah, you can check. They have a very nice Twilio C# SDK helper library. They have this NuGet package, Twilio. We need to add it, and then basically it's very simple to initialize it. And this is exactly what I did. Let me show you how we integrated that into our framework. Again, we are returning to this Polaris White integration, but this time I created a special namespace called SMS here. In this SMS, I created again Twilio settings and the Twilio service. Again, the Twilio settings, here we have a little bit more information. In order to initialize their library, we need account ID and authentication token. Most probably you will buy a single phone. However, if you have thousands of tests, probably if you want to run them in parallel, you need to be careful. Probably you will need a couple of phone numbers, or if you need to simulate like phone numbers from different countries, again, we can extend this particular setting. Right now, I have bought for this particular video for 1 month a single phone number. And also, I'm going to show you how we can create two plugins. One of them will be how we can wait for SMS instead of repeating the logic. And then I'm going to show you how we can send SMS on failure. This is very interesting. And we can control this behavior through this Boolean property. By default, it's false, but we can enable that. So right here under integration, authentication, you will find this SMS passwordless login tests. You will notice that here I added this attribute. In a minute, I'm going to explain how it works. For now, if you need, without any attributes or plugins, to use the Twilio service adapter that we created, utility class, I added here a private variable to the SMS listener. This will be the thing that we're going to use to listen for receiving new SMS. The first thing that you need to do is you need to call this Twilio service class. So we are initializing the Twilio static client, and after that we are initializing from the from number from our settings. We're going to start to listen for SMS. There are two variations of that, and also we can get we need at the end of the test execution to stop listening for SMS and call stop listening, and we can get all of the messages, SMS messages, or just the WASP message. Again, you need to be careful with this get WASP message, and especially if you use the same phone number in parallel for tests, probably this will lead to a disaster and many tests will fail. So you need to be careful. We're going to discuss how to handle that when we talk about scaling the tests and executing them in parallel. And I added two more methods for sending SMS. Again, I just checked their documentation. Probably you have different numbers, phone numbers for to send it from and to send it to. So the tests are very, very similar to the ones that I showed you about the emails. We're clicking the SMS tab, then typing, but from our static integrations, the Twilio phone number, and then we are using the Twilio service to get the WASP message using the SMS listener. As you can see here in the test initialize, we started listening for this particular phone number, part of our settings. And at the end, if the listener is not known, we are stop listening for the SMS. And of course, when we receive the the latest message, we have a similar extract code method to get just the one-time password. That's it. Again, I built this listen for SMS attribute and plugin because I didn't want every time to repeat this code. For example, initializing the listener, stopping the listener, etc. In order to handle that, again, I created this listen for SMS. This is outside. Maybe you can, it's fine, we can add that, at least these particular plugins, we can add them to our integration project. That's fine, because they are not related to our custom logic in the project. Yeah, so this is very simple attribute, nothing really special. We can set it only on a class level, as you can see. We cannot put it on top of tests. And after that, this listen for SMS plugin is deriving from our plugin observer. We have a static instance to the SMS listener. Again, if you run this in parallel, something else needs to be modified here. Before the original test initialize of the method, we check the attributes. If the attribute is present, then we should listen and we initialize the listener. And after that, before the test cleanup, we'll stop listening. That's it. As I said, I created one more plugin. As I said, in some enterprise projects, some people execute some of their very important tests. They're called heartbeat, even on production. Imagine that, I don't know, maybe you can have tests that are running on every 5 minutes, checking the most vital services for your web application. This might be the login, this might be the register form, or whether the online shopping is loading. Most of the time these tests are read-only because you don't want to insert or create something on production environment. And if some of the services is down, then we want somehow to notify our admins or our SWAT team or the most senior engineers so that they can check what's going on. Actually, in the past, I was part of such a project where we had something similar in place, and in a couple of occasions, we were getting up quite early, 3 a.m. during the night, to check why something happened, right? So how this works, again, we're deriving from this plugin observer, the base class for all the plugins. We're checking in the integration settings whether this feature was enabled or not. And if the outcome of the test is an error, meaning it failed, then we're getting our Twilio service, but this time we use this send SMS. Most of the time, probably this is just a fake random number. Maybe you will want to send multiple emails, or as you can see, the message here is some of our heartbeat tests failed on production, call the SWAT team. And we're notifying maybe the team leader for that. All right, let's continue. What else? Let's review now the blob storage. What is the blob storage? I already created the plugin. I'm going to explain it in a minute, but this is a demo account that I created. This is the blob storage. You can think of the blob storage, laser blob storage, something like cloud storage in Azure, where you can upload any files. This is like, let's say, an enterprise version of Google Drive or OneDrive. It's not that, but like we created this specific storage that you have SDKs that you can upload files here. It's not only that, because you have, for example, here file shares, you have queues, you have tables without a schema, and usually in these blob containers we can store huge files. That's it, that we can later read and write. And as you can notice here, I created a plugin for storing all of the videos that I downloaded with Lambda test APIs for previous executions. And I did the same for the screenshots right here. We have some screenshots. In order to learn how to use it, you can use, and I'm going to upload that, I'm going to add that to the description resources. They have a NuGet package that I already showed you how to install. It's very useful to use, it's very easy to use. You need to add this to packages here. After that, you just need to, basically they have a wrapper for their SDK. It's using their web REST API for reading files from the blob storage, uploading them. Basically, that's it. And the thing that I did is, again, in our integration project, you'll notice that I created a new namespace called blob. Inside this blob, actually, sorry, this is our demo project. In a minute, I'm going to explain this plugin here. But in our integration project right here, we have a blob namespace. Inside this blob namespace, we have settings. And the only setting that you need is you need to copy this connection string after you create the resource in Azure. After you have the connection string, this is the only thing that you need. I created this adapter wrapper facade. I forgot to make it static, but maybe it's a good thing to follow the same architecture and make all of our naming convention and make all of those adapters static utility classes. But anyway, we are providing the connection string, or we are reading it from the integration settings. As I said, I copied that from their MSDN documentation, but we can download the file if you want. Right now, you can get a file URL, you can check if the file exists, you can upload files by providing a file name and a file path if it's on your execution machine, or as a byte array. This will be the one that we are going to use in our plugin, because we are going to basically download the videos and the screenshots as byte array using our API client, and then we are going to upload it here. As you can see, we are parsing the connection string, then we are initializing and creating the blob client. We get a container reference, and this is basically the folder where the files are, and the page blob. And then we are calling their upload from byte array, and as I said, they have different methods here: upload from a file sync and many others. I didn't want to make our code more than needed complicated. This is why I called this wait method, and I haven't made it asynchronous here. All right, so let's see it in action. In this particular publisher plugin, as I said, the thing that we are going to do is that if, again, imagine that you're an enterprise and you want all of the videos available in your cloud storage. Again, for some reason, many of our clients actually want to do something similar because they need, for example, to be ISO certificated. And in order to prove that, you need to prove for every release how the release was tested. We need videos, we need screenshots, we need proof for what happened. Many often, again, you can, for example, if you use Lambda test to execute all of your tests, probably if you have an enterprise subscription or a custom subscription for you, probably they can somehow modify your account and these videos to be preserved a little bit longer. But these back enterprises, many often they want to store videos separately. And this is why in the past we created tools, or you can create such a plugin. In order to use the plugin, I'm going to use not only the blob service here, but I'm going to use the Lambda test API here. And one more thing, Lambda test hooks. Let's discuss these two things again. I'm going to remind you what is the Lambda Test API. The Lambda Test API, it's right here in this Swagger Open API. This is like documentation for all of the APIs available. It's really great. They basically give you access to everything. We have, as you can see here, when we have the session ID, and we have that when we create a session using the remote WebDriver, we have the session ID, and we can make requests here to get all the screenshots, to get the video. This is the two methods that we are going to use. If you watch the previous module, I showed you there how using this YAML file, we can, using separate tools, open source tools, we can generate APIs for that in C# instead of, you know, making those requests every time by hand. We're going to use these auto-generated APIs. And one more thing, usually we can access information here about the build, about the session, and many other things. However, there is one more interesting function. It's called one that hooks for Selenium automation. This is like small scripts that you can execute that can, for example, check. We're not going to cover all of them, but I will explain just some use cases, because this is like a third-party integration that it's pretty useful. You can check the current status of the test, whether the test passed or failed. You can check whether a particular file exists on the Lambda Test cloud. This is pretty useful because you're not going to execute your test on your machine, but it will be executed in the cloud. This is why if you download something, it will be downloaded on the Lambda Test cloud. And you need a way to verify, for example, what was downloaded. So you can check for existence, you can check the exact file content, you can list all the files, you can rename the Lambda Test name of the test or the build. There are other helpful things. For example, we are going to use right now Lambda Test screenshot. You know, before there is a capability, I think it's called visual, that can make screenshots for every particular action. Of course, this will impact most probably the execution time, and many often when I have video, I'm turning this off. However, again, if we want, if I have turned this off, using this hook here, I can instruct Lambda Test to make me a screenshot only in a particular moment. And this is very, again, useful because we are going to use that in our publisher plugin right now. We are going to store the video, but also if the test failed, then I'm going to capture a screenshot and save it to the blob storage. As you can see, we can do, I think this is also very helpful, get clipboard and set clipboard, because again, this is executed on another machine and you cannot directly control the clipboard. But like this, you have 3 methods here for doing that, and this is pretty useful. And I added that actually to our web project. I call that Lambda Test Hooks. It's right here in the web project. I have a folder called integrations. For a reason, I haven't put that into our integration project, because our integration project, it's not connected to the web project. It doesn't know about it. And right here, to trigger the hooks, we need to use our JavaScript adapter in order to send these scripts. So this, as you can see, this static utility class, it's using our driver adapter as a static variable here. And we are just executing these scripts that we are formatting them using string interpolation, providing all of the parameters. That's it, nothing more. All right. And as I said, I copied all of the auto-generated APIs from the previous module right here into our integration project, because before they were in the system test project, but their proper location is our integration project. And in our new plugin, we're going to use this session API client. Again, to, as you saw, we have methods for getting the link about the video and to the zip with screenshots. All right, So this plugin, be aware, it's a little bit more complicated, but really quickly I'm going to explain how it works. It's overriding only one method on after test cleanup, meaning that our test finished and then we're going to do that. We are checking whether this is a Lambda test execution, otherwise we don't have video recordings or screenshots, we cannot use the API obviously, and you don't want to execute that locally. So only if this is a Lambda test run, we're going to work with that. From our driver factory, we have a reference to the current session ID. This is something new that I added. It's a static property. It's a static property to that we are initializing when we start the grid here. So we are getting it from here. And if we return actually something new, I'm going to, yeah, we're going to fix that later. It's in another branch. All right, but yeah, we initialized the API client adapter, and after that we have the session API. Again, API client adapter, if you remember, this is something from our API project that we are going to use, for example, as you can see here, to download a specific file. Besides that, we use the session API client. This comes from the Lambda test API clients. We call this get session video asynchronous. Again, we don't directly use async methods. Again, to make it a little bit more simpler, but every time you need to call here result in order to wait for this request to be executed. So we get this video response. From there we have just a URL to the video, but again we don't need just the URL, but we want to download it locally. This is exactly what I'm doing. I'm using our API client, I'm downloading it async, and the result is a byte array. When we downloaded that, we haven't saved it to a file yet. This is just we downloaded in memory. Then I'm initializing the blob storage part of our integration project. We are creating here using string interpolation a unique name. The unique name is we are using this member info, which is a class part of reflection. This is the name of our test class. This is the name of our test. And we use string interpolation formatters for generating this stamp to format just this unique file name, right? And after that, I'm calling our upload file, that it's using this third-party integration to the blob storage. This will upload the file. This until here, we just uploaded the video. If you need all the screenshots, maybe you don't need them if you have a video recording, but I wanted to show you also that. Right now, I'm checking if this is a failed test, then I'm calling my static utility class lambda test hooks, and I'm extracting lambda test, please make a screenshot for me. Again, as part of our capabilities, I have turned off all of the screenshots during the execution, but this will create a separate, only a single screenshot for me. However, if you check the API, you will notice that it's returning a zip file, a link to the zip file with all of the screenshots. You cannot get just a single screenshot, right? This is why I'm using our API client to download in memory our zip file. When I have in memory the byte array with the zip file, I'm getting my temp folder, and I'm using some C# code here to create a new directory and use this special zip file library. It's part of the .NET framework to extract in memory from the byte array this zip file to the folder. After that, I'm getting all of the files, all of the screenshots, I'm generating similarly a unique name, and I'm uploading them to the blob storage. Then I'm deleting the zip file and deleting the directory. I know, again, here we use a lot of .NET libraries to work with that, but that's it. Again, it can be much more complex if you have additional tooling. All right, let's now discuss auto-healing and smart weights. As I said, auto-healing, I enable that through these additional parameters. By default, I turned off the tunnel, the smart weight, and the auto-healing. If you want to turn them on, we need to explicitly set the default parameters like this. In our test login application, I added this new checkout form. As you can see, it's just checkout index HTML. It's really a static web page using one of the Bootstrap demos. And just really quickly, again, you can check and you will find that this link to the Lambda test documentation. But in web applications, elements can change their locators due to updates, and this auto-healing feature is equipped to handle this seamlessly. It automatically detects new locators and continues the execution without any manual intervention. While it's really powerful addition to your testing arsenal, there are some limitations. For example, it cannot recover from, for example, WebDriver initialization or system level failures, and it can reduce test flakiness, but you need to review all of the logs and understand why the test need healing and fix all of the locators. But when you enable that, later in the logs, again, there is a separate video about that. You will find the link below. But as you can see here, we have this icon, and when you click it, it will say this was your original locator, it failed, and I found this one that it's working. It's really powerful when you enable it. Again, it's out of the scope right now to discuss the actual test. It's very simple. We have one page object here, just referencing all of the elements. I just, again, refactor a little bit the examples from Java before, integrated into the framework. That is what I did here. But yeah, we are just returning and using the framework in general, and we are deriving from the web page. And after that, the test, as you can see, is very simple. We are initializing this new local page. We navigate to it. We just fill the information. That's it. However, if we take a closer look to the example, right here, on purpose, I opened here the developer tools. Again, you can watch the video for more details, but I'm just going to highlight a few of the scenarios that I have tested at, and it worked. It works if, for example, the ID has been changed. It works if, for example, the placeholder here, and you built your locator using XPath based on it, it will continue to work. It will continue to work if you based your XPath locators on particular label. If you created your locator using the inner text, for example, for the button, if we change the button text here, it will continue to work. Also, it will continue to work if we delete here some of the elements. It will continue to work if we add new elements. And again, this is very powerful. However, keep in mind that this auto-healing feature is supported on all browsers except Internet Explorer, and this is really valuable. However, it does not replace good test design and error handling practices, and you need to be careful when you use it because there are additional checks, and this may impact the test execution times. Another feature that I told you about, it's called Smart Wait. As you can guess from the name, when you enable that, Lambda test automatically for you will wait, for example, for elements to exist, to be interactable, to be clickable, In many places where we used wait for Ajax, they will wait for all the requests to finish. This is really powerful. And why this is important? While we have this internal framework waiting mechanism using native WebDriver wait, keep in mind that because of the architecture of Selenium, for each of the wait requests, we are making a separate call to the cloud. Especially when you run your tests in the cloud, when you do these waits inside the cloud, it's much faster many times. If you compare that with making all those requests, because imagine that I'm here in Bulgaria, but the cloud is in US. This means that every time the requests are traveling all that time, and this can take a while. So many often, this is one of the benefits. Also, another benefit is that if we take a closer look to our framework, you will remember that in many instances, in order to stabilize our tests, we are not only relying on this internal waiting mechanism with the wait strategies, right? But instead, we were using this wait for Ajax method, right? However, we can use that only if the website is using jQuery for making the asynchronous requests and rewarding only parts of the web page. However, many modern websites are using other technologies such as React, Angular. Again, similar thing is possible in React and in Angular. I have built that into our enterprise frameworks. However, you will need additional JavaScript snippets that will be specific for Angular or React. So keep in mind that if you enable and if you work only on the Lambda Test Cloud, if you enable the smart wait, this will allow you probably most of the time handle most situations without those methods. However, there is a drawback, of course, when you locally work with something, and if you don't want to take your Lambda test threads for debugging purposes, because you might have many engineers, it's much easier to troubleshoot and build the test itself. It's good to have all other possibilities, right? So yeah, maybe we can combine them both. Again, you can check here this smart wait example where I have enabled the auto healing and the smart wait, providing a specific timeout here. And one more thing, let's see one more example. I want to show you instead of repeating the whole login authentication logic every time, like here, that's fine. If you are testing the login, the registration, it's fine, all of the tests to be as long. Of course, you can create patch objects, you can isolate how we are authenticated, you can put that every time in the test init, but again, every time you are repeating the whole code, or you need every time to delete all of the cookies. Most of the time, if you are using the browser, if you are calling delete all cookies, this will probably log you out. All right, so what is the alternative? The alternative many times is that we can create a similar authentication plugin based on attributes. As you can see right here, I use this attribute. It's called authentication. Right now, we can pick between different types. For example, create me a new user with no two-factor authentication. I have added here into our demo system tests one more factory for creating test users, but I combined that with our mail-swap service and with the Twilio service. This is really powerful because here in this test login application in the backend, we have I have added some web APIs for helping me to register a new user based on some input. And this is exactly what I did here. In this test user factory, this is a specific utility class, a factory for creating new users. I have, as you can see here, methods using Faker to create test users using real emails. And the way I do that is that every time I am using the mail swap service to create a unique user, I'm creating these test user models. Basically later they're converted to JSON and sent to my backend, and then vice versa from JSON to C# objects. And we're working everywhere with our API client, which if you remember from a previous module, this will enable us to have toast messages, BDD logging, and everything else. You'll see that every time. Again, regarding the two-factor authentication in a separate module, we're going to discuss that. For now, let's skip that. But in this authentication namespace, I added one more last plugin to cover now, and then we'll wrap up. So I added this authentication attribute. You'll notice here the only thing that I'm doing in this authentication attribute is that we have access to, and we have just a single property, authentication configuration. And we are initializing this authentication configuration from the parameters from the attribute here. What is the authentication type? Whether it's passwordless, two-factor authentication, single sign-on, whether we want a new user or existing user, and yeah, that's it. And this authentication configuration, it just holds all of that. And the whole logic is happening inside this plugin. Again, that we need to add later to our web test base class or mobile test class. Before initializing the test, I'm getting the attribute. If it's there, then we're calling the authentication service. And as you can see, we are initializing a new instance of the authentication service using the configuration and call authenticate user. So as you can guess, the whole logic is happening inside here, inside this authentication service. It will be up to you. You can make that static and provide this configuration directly to the authenticate user. But yeah, we have one of the things that you need to be careful. Right now, we don't support parallel execution. We're going to upgrade that in a later module. We just hold a reference to the test user that probably this authenticate user created. It's static. If we are going to use that in parallel, then something else needs to be modified here. But this authenticate user, as you can see, the thing that we do is that we are navigating to our home page. And after that, in this switch, depending on the authentication type, we're just calling different methods. For example, I extracted here this authenticate passwordless email logic. It's doing almost the same like we did in the test, but we're isolated everything here. If you it's completely fine if we refactor that using page objects, that's fine. We're just going to use the page objects here. But as you can see, we have get user, or we can integrate that with our test user factory. Instead of having a separate method here, we can refactor that later. We're going to extract the code, wait for the latest email, and all of that. I did the same for the SMS, but you can guess what I'm doing. I just moved all the logic here. Later, we can upgrade this particular solution even more with, for example, if we have such a logic, you can watch it in the other course about authentication testing. In my backend, I have a method for generating these authentication cookies, so I can authenticate even without going through the UI, but just navigating to the page, setting a specific authentication cookie, and bypass the login altogether with new user or without, it doesn't matter. But again, we are using the whole point is not to repeat everything, but again, we're integrating that together into our plugin architecture, and you can see how powerful this is, right? This was the last thing that I wanted us to cover. So we covered SMS, an email, passwordless login. You saw how powerful this Azure Blob storage can be. We can store and combine it with the 𝒏𝒕𝒐𝒏 APIs to store videos, screenshots, or other information that can be helpful in troubleshooting later tests. You can check the self-healing and smart weights. They are really powerful, especially if you are heavily depending on the Lambda test execution. Really powerful, and it can save a lot of time, but be careful again, especially if you use them. You need to measure how they impact your test execution times, and you need to be careful if the self-healing is working. Probably you need to check the logs more carefully and fix your test later when you have time. And we saw some plugins like, for example, waiting for SMS to be received, for sending SMS on test failure. You saw this advanced plugin for uploading videos and screenshots to the Blob storage, and this authentication plugin. And you can see how powerful this plugin architecture of the framework is, and we're combining all of these pieces together. And we're going to continue to do that in the next module when we cover result analysis integration. It will be really, really interesting. We're going to cover Allure reports, report portal. We're going to combine them with Azure continuous integration, and we're going to integrate everything together with the Lambda Test Cloud. For example, linking, customizing the report portal and the Allure into our framework to have BDD logging, to include all of those video links there, or builds. You'll see, it will be very, very useful to you. Hi guys, greetings from Bulgaria. This time we're going to discuss results analysis integration. This is the next module, part of our advanced test automation framework development course. But before we begin, as you know, please subscribe to the channel, hit the ring bell so that you get notified when new videos are published to the Lambda Test YouTube channel. Also check the awesome Lambda Test blog, because there are many detailed articles that can help you to be a much better test automation engineer. For this particular module, in the links below, you will find all relevant resources, courses linked, together with the GitHub repo, and I suggest to clone the repo. So clone the repo. It's called Polaris White Test Framework. And for this particular course, instead of creating every time separate repositories, I'm using a different technique. We have different branches for each particular module, because we're upgrading the framework little by little in these branches. So when you clone the repo, you need to check out this results analysis branch. And I suggest to watch all of the videos from the beginning of the modules, because I try all of the modules to be not connected between each other, but still some of the concepts we took a closer look in previous modules. You will find some jump links in the description below, and they will help you, if you don't want to watch the whole module, just to jump to the part that is interesting for you. So in this module about results analysis, we're going to cover many exciting things. In the past, we had a video about results analysis, but integrating with Java. Now I won't focus so much about these tools. Of course, I'm going to give you a refresh why we are going to integrate them, etc. But again, as the main focus for this particular course is to put everything together, and also build some advanced customizations to these tools. So first, we're going to begin with integrating our framework and executing all of the tests using Azure DevOps, a popular continuous integration, continuous deployment tool. After that, we're going to integrate together Allure, Report Portal. Also, I'm going to show you another interesting feature of Azure called App Insights. where we can collect some meta information about the execution of our tests, and maybe it can help us to resolve some problems in future. And the third part will be dedicated to extending these reporting solutions. For example, we're going to extend Allure and add BDD logging there, publish everything there. Also, I'm going to show you how we can integrate together Report Portal, Azure DevOps, and Lambda Test together, the three of them, where we are going to add links to the current executed test, the failed tests, to the videos in Lambda Test. Also, in the Report Portal, we're going to link the Azure DevOps build link and add some custom tags about your test environment, test suite, and many more. So let's begin with discussing the Azure DevOps. Until now, we have executed all of our tests locally through Visual Studio, right? As we discussed in one of the first modules, just to make the usage for you a little bit easier through the course, I have put this particular project right here in this solution. However, we have a separate repo where I moved these system tests, and we're using the framework as a submodule. For now, I will leave it like that. So we'll look into a simplified version where we will work with a single repository, but keep in mind that in most cases, it will be a little bit more different and more challenging. So, Azure DevOps is a popular continuous integration tool. You can think of it, again, on the Lambda Test channel, you will find separate courses about continuous integration with various tools. But since we are working with .NET, most probably you will work with GitHub Actions or Azure DevOps if you're enterprise. So I'm going to use Azure DevOps. You can think of it that many often, at least for the automated test, there are a couple of different architectures for how we execute our tests. The most popular way is to have a few such pipelines or workflows where we execute all of our tests or a subset of some of the suites every night. However, we can execute our smoke tests or the most important tests after each check-in or publish of your web application. Again, it depends on how big is the web application, etc., and the context. For now, let's assume that we have a single build for executing all of our tests because we don't have so many. I'm using right now the classic editor. And this classic editor, basically the thing that it gives us is that you can use here the buttons and the visual editor to configure everything. However, if we use, for example, you can use the, many often some people use this YAML syntax. We can view the YAML syntax for the whole build. And this is useful when you want to have the definition of your pipeline inside some repository so that you have, you can view the history, etc., and keep it there. For now, just to make it a little bit easier for us, I used the classic editor with all of these UIs here that can help me. So the first thing that when we configure a new pipeline here is that we need to download our source code. So as you can see here, I used GitHub, and then I basically said, please clone this repo and check out this branch. Of course, as I said, if you are using Polaris framework as a submodule, you will have one additional, for example, right here, you have to check this. This means that you're going to clone the repo of your system tests, and by default, they will download all of the submodules, in this case, Polaris framework. So after that, another thing that I did is, if we take a closer look here, we can name the agent job. Right here, I use this agent pool. By default, Azure DevOps can run on virtual machines. However, here I installed one of their agents on my machine, and I'm running it here. It's right here. It's listening for other jobs, and basically my machine now is a built agent for Azure DevOps, and yeah, it's going to execute all of this code on my machine. It will create a folder, it will download the source code, it will build it, it will run the test, etc. After that, my first step, the build as a whole is very simple. As you can see, we have just a few steps, 4 steps. I'm installing the correct version of the SDK. Right now I'm installing and I'm using this particular step, use .NET Core, and I'm installing version 8, which is one of the last ones. After that, if you click here the plus sign, you can view all of the tasks available for you. 2 of my steps are using this .NET Core, and through .NET Core, first I'm building the whole solution. I'm using this regex expression to instruct .NET what to build. In this case, it will build in all of the folders, all of the C# projects. And one additional thing here is that I'm specifying the build configuration. Please note this syntax with $, parentheses, and then the name of the variable. This variable comes from Azure DevOps. This is a custom, actually this is a default variable that comes for every build. This is called build configuration. If you remember, if you're not using, if you watch the module about configurations, we walked into a couple of variations of how we use configuration. Especially if you're using JSON configuration files, this build configuration will be quite important for you, because based on it, another configuration file will be loaded. Here you can create configurations like QA, production, development, etc., or for particular instance. So yeah, this configuration here is important, and if we want to get a particular variable, we use this syntax with the $. And after that, we use the same command here, .NET Core, but this time I'm using the command test right here. You can specify, instead of using a regex expression, you can specify directly the name of the project where your tests are located. And as you can see, we have a little bit more parameters here, right? First we are instructing again, which is the configuration that we don't want to build the project or restore any NuGet packages. And then we are applying this filter again. As you can see, I'm getting the filter from my variables. And later I'm going to explain about this logger report portal, but as you can guess, this is one of the integration points how we publish results to the report portal. Regarding the test command, I'm going to give you the link to this official documentation. This is the official documentation about the .NET test. As you can see, this CLI command, it helps us to run our tests from the command line. And it has a lot of arguments, right? We're going to use a few of them, only no build, which means that we are going to build the project in another step, and then we're going to use the filter. If we search for the filter, at the bottom of the documentation there's some examples, and you can use the same .NET test command to run tests for MS test, XUnit, NUnit, and we can apply filters such as, in our case, we're going to filter by category. This is additional attribute that we put on top of the tests, like this. Let me show you. In our test here, I have created another namespace called results. A little bit later I'm going to explain these plugins and event handlers, but for now pay attention to this category attribute, right? This category, I'm providing all of my categories as constants so that I don't copy paste the whole time all of the strings. And based on these categories here, we're going to apply the filter. All right. If we return to the command here, as I said, we're executing all of the tests here based on this command. Pay attention to this checkbox here. If you click it, by default, additional logger will be appended like that, which is called logger TRX. As you can see, if we hover here, you will see that it says we are going to add this logger TRX, which is TRX is the file extension for MS test results. And if you publish all of those results to Azure, this type of report will be created for you, which is okay. I mean, in the past we use it quite extensively. It's fine. I mean, you can see all of the failed tests, all new failed tests. You can find the duration. Also, if you click it, you can see the exception message and the stack trace. As I explained, however, if you're using Lambda test, I showed you in the previous modules how we can send this additional information to Lambda test, and then you can just check all the results there with the stack traces and everything. It really depends how you use Azure DevOps. If you're using their stories, books, test case management system, maybe it makes sense directly to work inside Azure DevOps. It will be up to you. Most of the time, if I have integrated report portal or these Allure reports that we're going to see in a minute, I have opened them here. Maybe you won't need a third place where you're going to check the results. So this is my Azure DevOps build. Again, another thing that is very vital is that we can apply such triggers here. When you click on triggers, we can schedule to be run a particular day and time, or on a build completion, or when there are pull requests, or when you integrate it, for example, when a package is published, then maybe you can trigger then your builds. Again, it depends on your architecture. Now let's return to our presentation and let's discuss now Allure and Report Portal. Before discussing how we can integrate them, really quickly I'm going to, for those of you who don't know these tools, to give you just a glimpse of what they are. First, I'm going to start with Report Portal. Report Portal is a very popular reporting solution. It's open source. You can deploy it on Docker, Kubernetes, and other cloud platforms. It's a full-fledged web application that it's, as we discuss later the installation guide, you will see that you need a very powerful machine to host it. And it will cost some money, right? If you want everything to be executed fast. However, you can create these really nice dashboards. They are very customizable, as you will see in a minute. You can rearrange them, you can add such widgets, and you can configure them with different filters. For example, here I have created such dashboards for our 𝑨𝒏𝒕𝒐𝒏 Enterprise Test Automation Framework. We have for it around 4,000 tests. As you can see, we have some filters about failed test cases trend, no passed test cases, launches duration, etc. Also later, there are other widgets for most failed tests or flaky tests as well. After that, you can see live, while the builds are running, each test can be visualized here while the run is running. You can, these runs will be populated and it will be displayed that they are running. This is significantly different than, for example, Allure reports that are generated at the end of particular run. Imagine that you have builds that are running for 12 hours. This means that the Allure report will be produced at the end of these 12 hours, and you will have this HTML report. But the report portal is a web portal where you can log in and you can see the currently executed builds. This means that you can have multiple reports at the same place. Multiple teams can work with it. You can have multiple dashboards. You can have multiple projects. So it's a full-fledged system for your whole company. It's not just a single thing. And after you have all of the launches, you will see that all the failures will be categorized in different categories here: product bug, automation bug, system issue, or whether they need to be investigated. After that, you can investigate them. The great thing, as you'll see in my real example later, is that they have a machine learning algorithm that will learn over time, and it will suggest and will do this auto analysis for you. This is really helpful, especially if you have thousands of tests. This will definitely save you time. And all the stack traces and everything, it will go here. Both Allure and Report Portal, they are available for integration with most of the most popular programming languages and technologies, which is really great. And this is why we are talking about them here. Also, the report portal can be integrated with third-party systems like Jira and popular test case management systems in case you want to submit a bug directly from here. And this is Allure. As I said, it's a little bit more basic. It doesn't have databases or whatever. It's just saving, as we'll discuss later, all of its data inside a particular folder in a JSON format. And later, through these JSONs, their executable is generating this static website with the information here. So this is again something similar that I did for the 𝒏𝒕𝒐𝒏 framework that I was developing. As you can see here, we have 1,600 tests, and similarly to what we have in Polaris, we have different controls or components for 𝒏𝒕𝒐𝒏, and I have grouped all of the tests relevant to each particular control in a separate suite. However, you can group them by features or stories. For example, in 𝒏𝒕𝒐𝒏 we have something called override globally actions for components, and this means that I have tests only for this particular feature, or we have these ensure extensions, or we can override something locally. It doesn't matter what it is, but it's another feature of the Allure that gives you another flexibility how you can group your tests. After that, there's some icons here. For example, this bump icon. It means that this is a flaky test. You will find a detailed stack trace here. We can also attach screenshots and videos, and I'm going to show you how we can do that. And what else? We have, again, you can view all of the suites here and all their total execution time, which sometimes is very helpful. I'm going to show you how we can extend it with additional tags and BDD logging. And there are some widgets. That's it. So let's look how we can integrate these two tools into our framework. So you will need a couple of NuGet packages. For the report portal, the most essential NuGet packages that you need to install are this report portal test logger. This will give you the possibility to use this custom logger in Azure DevOps, and this is actually, you can think of it, it is an extension to .NET Test, and basically at the end of every test they're publishing results there. We're going to discuss whether this is a bottleneck or not for you, because in some cases this can significantly slow down the test execution, but this will be up to you depending on the machine where you install the report portal. After that, you need this report portal and unit. For the extensions that we are going to build later, you will need these two additional packages, report portal Serilog and report portal shared. For the Allure, the only thing that you need to install is this Allure NUnit, right? That's it. After that, for the report portal, the only thing that you need now is this report portal config. Before explaining the config, let me show you their installation guide. You can navigate to their documentation. Deployment, as you can see, you can deploy it with Docker, without Docker, in Kubernetes, in Google Cloud. It depends on your infrastructure. Right now, I have deployed in my local Docker right here, right? So in order to test it and install it locally in your Docker, of course, you need to install Docker. After that, you need to download this Docker compose file. And after you have it, you just need to execute this particular command. In 5 minutes, you have everything configured for you. And when you navigate to the localhost this port, you can log in with the default users and administrators. That's it. And after that, you'll be able to log in to this localhost website. Let's refresh it. Also, you need to check all of the containers here. You need to make sure that they are green and that they are working. So now it loaded. Here I have already executed some of the tests. So these are my widgets for our current tests that I executed. I really like this overall statistics. As I explained, you can rearrange all of the dashboards. You'll see that I added one demo dashboard with auto-generated data, and I have one more, but you can have as many as you like. From here, you can add a new dashboard. Maybe if multiple teams are using the report portal, you can create many of such dashboards. And here under launches, you can apply filters right here. These are the tests that are running for our e-commerce Lambda test website and for some of the controls. A little bit later in the third part, I'm going to explain how we can customize it and add these additional attributes here. You will notice that I have the actual build number that comes from Azure. This is not by default. This is extensibility that we built. And also all of this information, I got it from my build. Also, you will notice that I added as a description this Lambda test build URL. It will navigate us to the actual build in Lambda test. Also, if we take a closer look to the failed tests, we have similarly linked to the build, linked to information about the current test suite and the actual build number. And after that, I have the stack trace, and also pay attention to these really cool links here. I have a link to my Lambda test video execution. I have again a link to the build URL and a link to the DevOps, Azure DevOps build. Why this is helpful? Because many often the report portal is used not only by test automation engineers, but their development managers, other business people, and these links are helpful for anyone. And when you click make decision, you will see that since I did a lot of runs right now, there is this auto analyzer suggestion, and it's suggesting that right now there are similar logs, and in the past we marked this as a system issue, and I can click here at the bottom apply, and it will mark it. So after you install the report portal, you will have a particular IP address depending where you have hosted it. Right now, since I'm running it locally on my machine, I'm running on localhost. And this is why in the report portal configuration in Visual Studio, I'm going to provide this URL here to the API. And after that, from the profile at the bottom, you will find these links: profile, administrate, and API. You will need to go there to get your authentication key that we need to put into report portal configuration. So as I said, you need to put here the URL, the IP address, where your report portal is. You need to generate this API key, again from profile. And then I have some information about the launches, a default name. Like runtime, you can change that, but I don't suggest you to do so because this can reflect the filters and the dashboards. But you can play with it if you want. You can change it. You can add default description and add some default attributes. That's it. This is the only thing that you need. And after that, after you install this report portal vs test logger, you'll be able to add and use this logger report portal. This logger again extends .NET Test, and it will send all the data runtime to your report portal. You will notice that, as I said, this can, if we take a closer look to their installation guide for the report portal, here somewhere there was information right here: recommended resources, 2 CPUs, 5 gigabytes of RAM. I noticed that if multiple teams are using simultaneously, this is not enough. Usually, in most cases, when I was adding report portal to our projects, we use at least 4 CPUs and 8 gigabytes of RAM, and even sometimes this is not enough, again depending on the load. If your machine is too slow depending on the resources, since the way the logger is working, again imagine that after each test we are connecting to the report portal and send some information there, this can significantly slow down the tests. If this is happening for you and you cannot upgrade the machine or is costing too much, then you can turn off the logger, and then they have an API for uploading the TRX file, to the report portal, and then the launch will be created. However, keep in mind that this is limiting, like you won't see real time that your tests are executing. Also, one more thing: if you, for example, are checking here this publish test results coverage, keep in mind that probably if you use the 2 loggers, 2 simultaneous runs will be created in the report portal. Sometimes it's helpful for you to have this TRX file created because in some of our projects, when we have the TRX file attached to the build, you can download it later and open it in Visual Studio. This is excellent because it will open all of the results directly in Visual Studio, like that in the Test Explorer, and you will be able to re-execute all of the failed tests. Otherwise, you have to search test by test every time and troubleshoot all of this. So it really depends how you use it, right? Alright, this is regarding the report portal. For the Allure, as I said, you need only this Allure NUnit NuGet package. After that, you have 2 configuration files. This Allure config.json, and maybe, this is an optional one, this categories.json file. In the Allure configuration, you just specify the folder in your bin folder where these JSON files that I told you about, where they will be stored. Let me show you. This is my current bin folder, right, for this system test project. And you will notice that together with all the DLLs, I have folder here, Allure results. This is generated automatically when you enable the Allure execution. And when you open this folder, you notice that there are hundreds of JSON files. This is normal. As I said, Allure doesn't have like a database, but it's storing everything inside these JSON files. This is why it's important to name correctly this folder. Later, when we configure the extension here, this step, this is a third-party step coming from an extension. You can find this in their documentation. There is a section integrations, Azure DevOps, and in order to have this step, you need to install this Allure report plugin that you can get from the Visual Studio Marketplace. After you install it, this will be integrated for you as we discussed before. So we will have this report here, this Allure report. This is inside my current Azure pipeline. I already installed this. And after that, I will be able to, identify all of the failures here, check the console logs, and everything else. I wanted to show you one more thing. Inside here, you will notice that we need to point to the exact same folder that we are specifying in the Allure configuration. Otherwise, this Allure report plugin won't know where these JSON files are in order to render them inside Azure DevOps. And these links here, this is additional meta information if you want to add and use the Allure specific attributes for linking issues, like for example in Jira or GitHub, and test case management systems. That's it. Also, Allure has, and you can find that in their documentation, they have this, let's say, simple way of categorizing your tests automatically based on regex expressions and statuses. So in these categories JSON here, in the JSON format, you can add different nodes. For example, I can categorize all of the tests that are with skipped status to be inside a group called ignored tests, or they can be placed inside a group product bug if they match their message and assertion message match this regex expression. The same can be like this calculator problem. So we can include both match statuses or trace regex expression or message regex expression. That's it. But again, this is optional. If you want, you can put it here. After that, if you want your test to be encoded compared to report portal, in report portal, you don't need to place any attributes or anything. You just need to install the NuGet package, use the logger, and provide this JSON configuration. That's it. However, for the Allure, it's a little bit different. For the Allure, you need at least to put this Allure NUnit on top of all of the test classes that you want to be included into the Allure report. And again, this is why you need to install this Allure NUnit NuGet package. Together with it, you have access to additional attributes like a parent suite, Allure epic, Allure feature, severity, owner. We can have a parent suite and a subsuite. And this is how you achieve, as you saw in the images from the 𝒏𝒕𝒐𝒏 framework, this is how we achieve this categorization of our test by feature or particular test suite. This is meta information that you put on top of your tests and test classes. That's it. Nothing more. Later I'm going to show you how we can extend that, and we're going to return to this. Alright, one more thing, part of our presentation, I wanted to explain how we can use App Insights. So what are the App Insights? Let me directly show you. In my demo Azure account, I created this App Insights service, Application Insights. And in the App Insights, you can think of it as a Google Analytics. This is analytics, but for different applications. Or this Application Insights, it's often abbreviated App Insights. This is a feature of Azure Monitor. This is a cloud-based service provided by Microsoft Azure that allows developers and DevOps teams to monitor the performance, availability, usage of their applications in real time. It provides deep insights into how applications are performing, where potential issues might be. You can track of App Insights automatically captures and handles exceptions and other errors that occur in your application, and provides a detailed stack traces later and context to help you diagnose and fix the issue. Also, you can implement custom error logging, etc., etc. In the past, why am I showing you this? In the past, when I was in the beginning of the development of the 𝑨𝒏𝒕𝒐𝒏 framework, we integrated this App Insights so that we can track which features of our framework are used most and which are not used, right? And of course, when you have this type of analytics, you can invest your time later in developing further particular features and then dropping others. Also, another really helpful thing, as I said, is this exception tracking. Imagine that you have, even if you have Report Portal, Allure, DevOps, Lambda test, all of them, most of the time, it really depends how you configure them, but in most cases how people use them, you don't have this bigger overview of all of the general exceptions that your framework is throwing, right? And this was one of the things that we integrated this App Insights so that we can track all of the exceptions that are thrown through our framework so that we can fix them before even our clients are reporting them. You can integrate that into your framework so that if many teams are using it, even if they don't understand why something is failing, you are going to see it later here and you're going to see a particular count of these particular exceptions. Also, I actually created an additional plugin that in a minute I'm going to show you, that is collecting information about all the tests that are executed, their name, their test suite, their duration, all the exceptions, and how many errors we have. They are all logged here in this big data database. And as you can see here, for the past 14 days, I can use this UI to filter all of the past or not past tests. Also, I can filter many different here parameters, custom properties that I can add, and I can see the exact exceptions. Moreover, when you click here, this detailed view will be opened, and you can use this SQL query mode where you can make this type of reports and fine-grain what you're searching for and debug it. The way this works, again, I'm going to link that into the description below. The right place to check is the, of course, official documentation for Application Insights API in this telemetry. It's called a telemetry API. Telemetry in software development means that we are gathering data on the use and performance of applications and application components. You can think that this can help you to add something like a Google Analytics, if my analogy is right, but for your framework. So we need a few NuGet packages, and then you need a very simple client. So I added this integration to our integration project right here, and I added a namespace called Insights. So these Insights, we have settings and Application Insights utility static class. Let me move that here. So inside the app inside settings, we have a connection string and whether this is enabled. Also, I installed this NuGet package, Microsoft Insights. That's it. This is the only thing that you need. And after that, in the service itself, it's very simple, just a single class wrapper. It's a static class in the same way like we built other integrations. We are getting the connection string from our static integration settings. Then I am initializing the telemetry client. This was something that I used a lot in the past, because many people outside of our company were using our open source framework. I wasn't sure what operating systems they are using. This is why this App Insights, it helps us to again understand how people are using our framework so that we can develop it further and whether we need to spend time supporting multiple platforms, right? Not only Windows. So I added here a few static methods for tracking exception. As you can see, it accepts a special object called exception telemetry. then most of the time we're going to use this track event. And if this is enabled, we are just using the telemetry client to track the particular event. And after that, I added one more plugin. It's called App Insights plugin. And if we open this plugin, you'll see that we need to derive from our plugin that comes from Polaris Core. And the thing that I do here is that we need to log the duration time of our tests. So I'm getting the full name of the test and then the start time. And I'm adding it to this static read-only dictionary that basically our key is the full name of the test and then the start time. After that, after the test cleanup, we're getting again the test full name. We're calculating the total execution time. And after that, we are creating this simple event telemetry class object instance. And I'm adding some meta information that will walk into App Insights, that the name will be automated test results. And we are providing properties such as the test name, the test suite, the test outcome, the duration. And in case our test failed, we are going to walk the exception as well. And one of the most important things is that, of course, you need to call the track event, send the event telemetry there, and don't forget to call the flush. The flush will force the App Insights to send all the requests to the cloud. You can do that also in the end of the whole execution as you wish. That's about the App Insights. It's really cool. Now, let's return to our short presentation. And now it's time to show you some reporting, some extensions to the reporting solutions. Let's begin with Allure. I'm going to show you first how we can create BDD logging like that. Do you see it? Like this is like very similar to the BDD logging that we introduced before and we have in continuous integration, etc. But this time here I use the Allure API. Let me show you how this works. If we return to the original BDD logging, if you remember, we were using our regular logger class, and this will create a log file or will directly send the data to the console. So basically we're using the same architecture. We are deriving from this base event handlers, but this time inside these demo system tests, I have a folder event handlers, and we have similar Allure steps event handlers, right? For the buttons, checkboxes, dates, emails, etc. How I found this? Well, there is a documentation about, it's not here, it's right here for the Allure. They have like divide tests into test steps when you check their documentation about NUnit. As you can see, we need to use here the Allure NUnit attribute, and after that they have an API using their facade here called Allure API, and then you can use this step. Of course, we can have nested steps, etc. I will keep it simple. We'll just use a single step, and this is why our event handlers are very simple. Again, this is how we use the logger. The message will be absolutely the same, but this time here I'm changing the logger with this Allure API step, and this will automatically create this nice BDD logging inside the Allure report. Awesome. The only thing that after that you need to do is that I created a base class for all of my test classes. It's called 𝑨𝒏𝒕𝒐𝒏 that is deriving from our original web test. And now I'm adding our App Insights plugin together to the execution engine, and I'm subscribing to all of these Allure steps handlers. That's it. The next thing that I wanted to show you is how we can add here files when you open a particular test, how we can add here videos and screenshots. If you're, again, most probably here you just want to add a link to the Lambda test video, for example, or screenshot. But for some reason, some people prefer to attach all the screenshots to Allure. You can use the same Allure API. If you remember, and if you watched the previous module about integrating third-party applications, you remember the plugin that we created for publishing to blob storage in Azure, the videos and the screenshots from Lambda test. This is exactly what I did in these two plugins. I published some screenshots and videos to Allure, and I did the same, but this time I published them to the Azure DevOps. You can do absolutely the same to the report portal, but for the report portal, I will show you it's more interesting how actually you can add these additional links that I showed you before. So in this plugin here, basically I copy-pasted absolutely the same plugin for the blob storage. So we're using extensively, as you can see here, we're checking whether this is a Lambda test run. After that, I'm getting the session. Using the session, I'm using the Lambda test session API client that we generated previously. So I'm, as you can see here, I'm getting the link to the video from Lambda test using the session API client. Then using our API client, I'm downloading the video in memory as a byte array. And after that, as you can see here, here is the main change. I have commented the initialization of the blob storage service and the link where I upload the file. And instead, the only change that I did is that in order to add this to our Allure report, we need to call this Allure add attachment. I need to provide the file name, the type of the file. In this case, this is video MP4. This downloaded video response is actually the byte array, of the video response, and the extension of the file. In this case, this is MP4. And at the bottom, there is one such change, but for the screenshots. The only difference here is that I mentioned that this is an image PNG. Something similar I did for the Azure DevOps, but this time you don't need to use like additional NuGet package or whatever. You can use native NUnit for MS Test. Keep in mind that for MS Test is a little bit different, and for XUnit. But if you're using NUnit, you can use the NUnit test context, and this test context give you this method add test attachment. After you, however, here you need to point a real file. This is the other change. The Allure API and the blob storage, they are working with byte arrays or links, but here you need first to save the file in a temp file to your machine, and then you can add it as a test attachment, and this will, when the run finishes, then this will be added to your Azure results later and to the TRX file. All right, and the last thing that I wanted to show you is if we switch back to the report portal, I want to show you how we can add this additional information here, these builds, change the description, and after that, how we can add the Lambda test links. The information about this is a little bit hard for you to find. In order to find it, I actually researched many of the report portal open source projects. In some of them, they have like information how to send walk information to the report portal. For some languages, their original documentation is good. For others, like C#, you need to navigate to their GitHub and check all the examples. However, if you want to send, for example, attachments to particular tests, again, this is the project that you need. Commons.net under the report portal project. And as you can see here, you can use this context current walk info. Another thing that I showed you before, if you want to create a similar BDD logging that I showed you, there are a couple of ways how you can do that. First, inside our core project, I installed one additional NuGet package. This is report portal 𝒌𝒏𝒕𝒐𝒏. This means that we can integrate a report portal logger inside our Polaris logger right here. When you install this 𝒌𝒏𝒕𝒐𝒏 extension for the report portal, right here at the bottom, you will find that I added this. From the global settings, I added a new property called is report portal logging enable. If you enable that, then we're going to use their extension, and this will add additional sync. This is called the sync, where basically when you use the logger, it will, for example, write to the file, write to the console, write to the debug, or other places like the report portal, right? And this is awesome because this means that if you enable this custom logger, this means that your original BDD logging here, you won't need to do other event handlers, but they directly will walk messages to the report portal, which is awesome. So this is one of the extensions. Another place where I found the actual implementation that I'm going to show you now is this example .NET NUnit. This is actually a link from their NUnit documentation. It's directly referring to this example NUnit GitHub repo. I cloned the repo, I checked most of their source, and I found this extension. This extension, as you will see, is an original NUnit native extension. This is why, because we're extending the NUnit engine and its test event listeners, which is awesome, by the way. And as you can see here, they have this report portal listener. It's something similar to our observers, but they are using event and delegates. And using this report portal listener, we can execute logic before test finishes and after test started, or before the whole run. And each of these events, as you can see, they have event arguments. Inside these event arguments, we have access to their particular API requests. We have access to the reporter. We will use this test reporter walk to create walk messages to the report portal, but as you can see, we are extending their execution workflow, which is awesome. If we drill down, you will find other interesting places like, for example, scoping, adding attachments like files. Also, you will notice that they have tests and they have a very similar architecture to our, where they use these event observers. Now when you know about the observer pattern, you can see it everywhere. So let's see how we can use that in our framework, but this time inside this demo system tests. This will be the last thing that I'm going to show you today. Inside this plugin namespace, I added this NUnit extension. I call this report portal test walk extension. Since this is a native NUnit extension, the only thing that you need to do is to place this NUnit attribute on top of it and extend this iTest event listener that comes from NUnit. After that, you don't need to register it somewhere, whatever. The NUnit engine will register automatically and it will execute it. But you need to make sure that everywhere you wrap all of the code with these try-catch clauses. Otherwise, if something happens with the report portal integration, all the tests will fail. And of course, you don't want that. Probably here is a good place to put your App Insights event publishing, because this is a critical infrastructure error. So I used two events here that I subscribed before run started and before test finished. Before I explain all the logic here, you will notice that before the run started, in order to get information about the test suite, the run environment, the release name, the build name, we are getting these environmental variables. But probably you will wonder from where we are getting this information. You will notice that we are getting them as they're coming from a process. And this is a good question. We're providing this information through our Azure pipeline. When you use Azure variables here, right here, I created all of this meta information right here. So I created Azure DevOps build. This is a default build variable, build ID. This is how we are going to generate the Azure DevOps build ID, because if you pay attention up here, not here, but for example, for this specific URL, you will notice that this part of the URL is the same. The only thing that changes is this build ID. So when I have the build ID, I can generate this URL and I can navigate all of the users here. And this is how we are going to get it. And when you have all of the variables here, all of these variables will be present as environmental variables in the current process. This means that in your code, when you use environmental variables, get variable, but for the process, you will have access to this Azure DevOps build ID, this build name. As you can see, I built it from the current test suite, the current build number, and the run environment. The run environment, as I explained at the beginning of the module, this is like the name of your environment, whether this is a QA environment, development environment, production environment, acceptance, testing environment, whatever, or the name of particular instance. So in this case, this is the QA environment. Also, we have the category, which is our suite, and we have our filter. And we have also a release name. A release name, many often this is needed for some people want to know that, because if we keep some of the runs indefinitely, as I explained in the previous video, when we downloaded all of the videos from Lambda test, many often for certification purposes, for example, ISO certification, we need to be able to prove when we have such certification that we executed all of the tests for the particular release. And this will be the thing that you can apply the filter, right? In your portal later, when you want to mark a particular build as final, you can go here to, for example, this run, and from actions you can edit it, and when you edit it here, you can mark it as final. Right here, you can add other custom categories if you want, or maybe you can do that automatically. Another change that I did is that inside our, as you can see, we have the build name, right? But also there is one more change. You will notice that right now I changed the build name of our Lambda test execution, and this is the build name that comes from Azure DevOps build. And also, if we open the tests right now, these are not random names like before, right? But this is the exact name of my tests. And the place where I'm changing that is that inside, let me see, inside the Lambda test attribute, inside the, actually this is the second, we need the web one. So inside the Lambda test attribute that we are using, you will see that we are getting the same environmental variable as a process. And after that, we are setting this grid settings build name that later we are passing here as a build name. This will change again. This will be the build ID for Azure DevOps, which is awesome. Another thing that I'm doing inside our browser lifecycle plugin, we are initializing our grid settings. For the grid settings, somewhere here, I'm setting the test name, which comes from the reflection. This is the name of the test. And later, inside our driver factory, inside our driver factory, in the place where we're initializing all of the grid options, we're setting this custom name. This will be like a name capability for the Lambda test, and this will set the exact name of the test. Again, many often this is hard for you to do this dynamically, but we are doing it because we are using observers. For the observers, we know the test name. Then the test name, we're initializing this grid configuration, and later, before starting with the driver factory, initializing the remote web driver, I'm setting the name. However, we are connecting all the dots, right? And now, if we return to our report portal test extension, this method will be executed, as you can guess from the name, before the actual run. So we are getting all of those environmental variables. And I have now access to the launch request. This means that report portal at the end of this method will make this start launch request. So I'm clearing all of the current attributes, and I'm adding new ones if these environmental variables are not known. I'm initializing the suite, the instance, the release, and the build, and I'm overriding them from these environmental variables. On top of that, if my build name is not known, again, I'm adding this build attribute, and also I'm building the Lambda test build URL. Basically, if you use this query parameter search text with the build name, this will open the whole build and you will be able to click it. And then I'm just initializing the description property to the Lambda test URL. That's it. And the most important part is happening inside this another event handler called after test finished. Again, we have some access to some arguments from this test item finished event argument. We're checking, is report portal enabled? Is this a Lambda test run? If yes, then similarly to what we did in other plugins, we're getting the current session. We are using the session API to get information about the session. Then I'm getting the current test shared URL and I'm sharing it for 30 days. Again, I'm getting that from the response, and here I use another from the API clients. And the thing that I showed you that I found in the GitHub repo for the Inuit extension examples for the report portal, we can use this e-test reporter walk, and we need to initialize this create log item requests. And basically we are specifying the level, the time, and I'm providing all the text here. In this case, using string interpolation, I'm attaching the link to the whole test, to the video. I'm doing something similar for the Lambda test build URL, similarly to what we attached to the description. And for the Azure DevOps build ID logging, as I explained, when you get the build ID, the only thing that we do is that in this integration settings, I added my full URL there because it will be different every time for different projects. So I'm building this URL, and again, I'm publishing it. That's it. And maybe if you want additional attributes, I'm adding them here. And at the end, you need to call this e-test reporter finish with the finish test item request, and everything will be published for you. Again, I wrapped everything here inside this try-catch box. Maybe you can use again these app insights that we checked before. And again, this is awesome because you will have this additional information about the build here, about these tags. When you open failed tests, you have all the stack trace and all the BDD logging I explained before, but most probably this is very, very, very helpful, and it was a feature that many clients that we were working for requested from us. This is why I'm teaching you how to use it. So we covered a lot. We saw how we can create an Azure DevOps build using our framework. We saw how we can integrate Allure and Report Portal, and also how to use App Insights to track features or track global exceptions that are happening inside your framework, and track metrics, for example, bottlenecks for really long executing tests. We saw some extensions, how you can send information like screenshots and videos to Allure, Report Portal, and Azure DevOps. But maybe one of the most important plugins that we developed is how we extended NUnit to extend Report Portal and connect it with Lambda Test and Azure DevOps and put everything together. So in the next video, in the next module, we're going to cover how to do performance testing using our current framework. We're going to use a lot bidirectional APIs. We're going to use Google White House. We're going to use Lambda Test. It will be quite interesting. Hi guys, greetings from Bulgaria. This will be our next module out of our course about advanced test automation framework development. This time we're going to integrate performance testing tooling into our framework. Keep in mind that actually we're not going to talk about JMeter, K6 or other search while testing tools, but instead we're going to use CDP bidirectional APIs at Google White House to perform some performance analysis, but more about that later. Before we begin, please subscribe to the channel, hit the ring bell if you haven't done so, so that you get notified when new videos are published. Also check the Awesome Test Lambda Test blog, because there are many detailed articles that can help you to be a much better test automation engineer. Now, in the links below, you will find all helpful resources such as some relevant videos that I'm going to mention through the module, also some helpful articles of the code examples. They're part of a GitHub repo, if you remember. So you need to clone this repo. It's called 𝒏𝒐𝒏 Test Framework. And I suggest to check and watch all of the modules from start to beginning, from the first to the last, because I try to, when I record all the different modules, I try to make them not connected between each other. However, in every module we're upgrading our current framework. So instead of having a separate repo, we have a single repo where each module has a dedicated branch. So for this particular module, you need to check out this performance tools branch. Also keep in mind that there are some jump links if you want to watch just a particular part of the module. So here is what we are going to discuss. First, a little bit of theory about what type of performance analysis we are going to do, and particular features of Selenium 4, and in particular Chrome development tools and bidirectional APIs, like geolocation, network throttling, and others. After that, we're going to discuss, when you're going to do a performance analysis, you need to understand what is your web application, and this is why we're going to discuss progressive web applications and, in short, single page applications, because when you do this type of performance analysis, there are essential stuff that you need to check depending on the type of your web application. Of course, we're going to mention Google White House because we are going to integrate it, and after that I'm going to present to you how I integrated all of those different tools inside our 𝒏𝒐𝒏 test automation framework. And we'll have two modes. Basically, when you execute your tests locally, we're going to use CDP emulations because it's easier for you when you develop your tests. However, I will consider that when you execute your tests during nightly or continuous integration, I'm going to show you how we can use the Lambda Test platform. So we're going to have a switch there because they have many native capabilities, for example, for geolocation, network throttling, native integration with Google White House. So we're going to use a combination between Lambda Test APIs, Lambda Test hooks, Lambda Test Selenium capabilities to enable all of that. And on top of them, we're going to add some assertions because we need, over time to verify the performance of our web application. So let's begin and talk about these different testing tooling that's available for you in Selenium. The first thing, again, I have a very detailed, another video that is very detailed talking about this type of geolocation localization testing. I will put the link below, but right now I will just give you very quick overview about these different types of testing that we can achieve with certain emulations part of the Chrome development tools, and of course now we can access them through Selenium 4. So this localization testing and using the sensors of your browser, we can basically change where we are and simulate that. And certain applications, like especially the ones that are having a map or whatever, will adapt the UI and the content for a specific region or locale. As you can see here, we can change the locale and the time zone. We're going to integrate that. It's important capability of our framework. When you change the location, for example, your website can be translated to another language. Particular features can be turned on and off. For example, the text might be displayed in another format, left to right, right to left, etc. So yeah, also we can do a globalization testing, which is focused more on product features and capabilities that allow the app to be used globally. For example, able to change the language of the website, support multiple languages, different time zones, support for various number of formats. As you can say, they will be changed depending on the country. These text formats, left to right, right to left, etc. Also, we can do this geolocation testing, as the name suggests, is a type of testing where you perform tests on your website from IPs of various countries worldwide. You can apply geofencing, which is a method to send notifications, geotagging, allowing you to put geographical tags over social media elements, geoblocking for restricting particular content, like this YouTube video here, etc. And regarding our current topic about performance testing, as you'll see, we can emulate particular stuff, like, for example, the geolocation in Chrome Developer Tools. Of course, this won't probably change the performance of your application. However, if you use the native capabilities of Lambda tests for geolocation, they're going to execute your tests really in this particular location that you mentioned, for example, Finland or United States. And this means that depending on where your server is, probably the speed of your website will be different. Nowadays, we use content delivering networks, CDNs, and load balancers to handle that. However, all of that should be tested, right? And we can use this in conjunction with network throttling. In a minute, I'm going to show you what this is, but basically we can simulate different network speeds, like 3G, 4G, 5G, etc. And again, you can emulate that in Chrome, but through Lambda test, they have these native capabilities to do so via Lambda test hooks and some Selenium capabilities that I'm going to show. Now, also another part that you can do natively with Lambda test, but also nowadays with bidirectional APIs, is that we can record all of the requests and responses. This is again important for performance analysis. Because imagine maybe when your web application is hosted behind a load balancer, you need to check whether all of the resources are loaded with the correct times. You can check, for example, the compression, because on one node this can be turned off, on the other turned on. For example, I had a case where I had to test captchas and their images because they can be loaded from different nodes. And this can vary depending on the load balancer and its rules. Also, the same is valid for the CDN and its settings. And it's important when you catch and record all of the requests in the responses, you can assert that the size of all of the requests. This might be very important to check whether they were received from the cache or fetched directly from the server. In a minute, we're going to discuss progressive web applications, and as you learn, this is very important for progressive web applications. And as I said, we have other emulations. We already integrated that into our framework. If you remember, in the driver factory, we can emulate different devices. And here in this mid-tier mobile, we can emulate network speeds like 3G, 4G. You have some limits with the available pre-configured options in Chrome Developer Tools. However, in 𝒏𝒕𝒐𝒏, as I'm going to show you in the documentation, we have a little bit more options. All right, so let's talk now about progressive web applications. One very popular, this is not an advertisement, I just use the Starbucks app because it's a very popular website that it's progressive web application. To explain it, so a progressive web application, or PWA, is a type of a web application that leverages modern web technologies to deliver an app-like experience to users across different devices and platforms. PWAs combine the best of both web and mobile applications, providing benefits of web technologies like accessibility, reach with performance, user experience, typically associated with native mobile apps. And we have responsiveness. They're designed to work on any device. They have offline capabilities, which is very interesting because they are web applications, right? And they use service workers. In a minute, I'm going to show you a live demo. They can cache resources and content, allowing users to access the application even when they're offline or on a poor network connections. Of course, some of the features will be limited, but still you can open it even if you're offline. Also, as you can see here, you can install that on your device, no matter whether this is a desktop or mobile, including the ability to see it full screen or to have an icon on the home screen. Also, you have automatic updates. They will be updated automatically in the background, ensuring users always have access to the latest version without needing manually to download updates. However, doing this performance analysis, you need to understand how this works because many often there are some nitty-gritty details that we need to consider when we do this type of performance analysis. Again, through the CDP, you can, or when you check the recorded responses, you can check whether the requests were received from the cache or not. You can turn off the cache and see what happens. You can access, for example, some of the data that it's recorded into the local storage or the session storage, etc. So when we do this performance testing, we need to ensure that our progressive web application loads quickly across different devices and network conditions. 𝒏𝒕𝒐𝒏 is excellent for that, or this type of emulation. This includes testing the loading speed of the initial page and any subsequent navigations, because like single page applications, initially when we load the application, all of the resources are cached and downloaded, right? Also, we need to ensure that the PWA renders smoothly with minimal lag, especially during transition animations and when there is a background update. Again, you need to simulate that, and maybe there are some push notifications. We need to check, and we can simulate that, as I showed you with the CDP, when we're in an offline mode, to test the correct registration and operations of the service workers, which are critical for offline capabilities. And again, cache updates ensure that the cache is appropriately updated when the PWA is updated. Let's talk now a little bit about single page applications like Gmail, Twitter, Pinterest, and others. It's often abbreviated SPA, or single page application. This is a type of web application that loads a single HTML page and dynamically updates the content as the user interacts with the app. Probably you won't have different URLs, right? You have a single URL there without requiring a full page reload. And spas really, they rely heavily on JavaScript frameworks like Angular, React, and Vue.js for render content on the client side. And the main advantage of SPA is this seamless and fast user experience, as only the necessary data is fetched from the server and the page doesn't reload completely. Progressive web applications, they actually can be multi-page or single-page applications. It really depends. But they focus more on providing this enhanced performance, offline capabilities, and the ability to be installed on devices like native apps. This is not completely true about pure single-page applications. And also these PWAs, they require certain technologies like service workers, manifest files, and others. And again, when you do this performance analysis, spas, they often, single-page applications often have faster subsequent page loads after the initial load because only the necessary data is fetched. But they can have a slow initial load if the JavaScript bundle is large. And they can suffer from performance issues if they are not optimized properly, particularly on mobile devices with poor network conditions. Let me show you. Here I have opened here some of these applications. When you open the Chrome Developer Tools and you go to application, you will see all of those background services, right, that are syncing the application behind the scenes. Also, a lot of the data is stored here inside this cache storage bucket, local storage, session storage, etc., not only relying on cookies. And I had this once when we were testing a SPA application, single-page application in an enterprise project. They were converting the old one to a single-page application. And actually, thanks to this approach that I'm going to show you with this analysis of this sort of matrix. In a minute, I'm going to present to you the code, but if you see here, I have printed to the console all of those native performance metrics. And thanks to them, especially to these two, while we were doing this performance analysis on the single-page application, we caught a memory leak, which was really causing the browser to crash in certain amount of usage of this single-page application. And this, as you can imagine, it's happening for single-page applications because they are not reloading the whole content. And this type of performance analysis is really crucial for that. In a minute, I'm going to explain a little bit more about all of those metrics here. But yeah, let's return to our presentation now. So let's discuss now really shortly Google Lighthouse. This is a tool built by Google. It's open source auditing tool for developers. It works over Chrome DevTools protocol and runs a series of audits to measure the web application and the test on the following: performance, accessibility, SEO, best practices. It measures some scores about progressive web applications. And it works as a Chrome add-on. It's actually part of DevTools. It has a command line utility and as a Node.js application. And here you can see like the HTML report, and also from the right you will see that actually we have a native integration between Lighthouse and Lambdas, which is really awesome. And we are going to use that. And what are all of those metrics? In a minute, let's talk about this here. Actually, I'm going to provide a link to a very interesting Google documentation for developers about performance metrics. And as you know, this performance of a website is essential. But when we use the word fast in this context, what do we mean? The performance turnout is something relative. A website might be fast for one user situated in Europe and slow for another who lives on an island. Two websites may finish loading relatively at the same time. However, one of them may seem that it's loading much faster. Another may appear to load fast, but to respond poorly on user interactions. And over the past few years, members of the Chrome team, with collaboration with 𝑨𝒏𝒕𝒐𝒏 Web Performance Working Group, have been working to standardize a set of new APIs and metrics that more accurately measure how users experience the performance of a web page. They try to give answers to a few questions. Is it happening? Is it useful? Is it usable? Is it delightful? And what are the types of the metric? There are several other types of metric that are relevant to how users perceive performance. For example, how quickly a page can load and render all of its visual elements to the screen. How quickly a page can load and execute any required JavaScript code for components to respond promptly to user interactions. After page load, how quickly can the page respond to user interactions? Do elements on the page shift in ways that users don't expect and potentially interfere with their interactions? Do transactions and animations render at a consistent frame rate and flow fluidly from one state to the next? So there are many important metrics. Again, I'm not going to speak about all of them now. I'm going to link this very helpful blog and documentation. But let me quickly discuss just two of those metrics. For example, first contentful paint and first meaningful paint. First contentful paint measures when the page starts loading to when any part of the page contents is rendered on the screen. And while the largest contentful paint measures when the page starts loading to when the largest text block or image element is rendered on the screen. Again, you can read about all of them. It's out of the scope of this particular video. However, we are going to assert those times because they're really important. So let's now focus more on the actual coding, right? So before showing you the actual code, I'm going to link all the resources that I'm going to show you. But the primary place where you need to read is, of course, the Selenium documentation, and especially this particular section here about bidirectional APIs and CDP. And we're going to talk now about these network features. You have here network interception. We're going to use that. When we have a response, we're going to store it in a collection. The same for the request. Here you have a request header, etc. We have here this performance metric. This is how we are going to get them, right? Again, in a minute, I'm going to explain what these are, but we're going to assert them, and probably we'll have a threshold that above this threshold maybe we can throw an exception. If and probably there are many of the capabilities of DevTools protocol are not really documented here because they're quite a lot. You can find them. I have shared a few times this excellent documentation about the DevTools protocol. This is the website, Home DevTools GitHub.io. And from the left, you can find all of the different domains. So for the current module, we're going to use this performance domain and the emulation domain. So in the performance domain, on top, you will find all of the available methods. We're going to use this get metrics. And also, before getting the metrics, we need to enable recording the metrics, of course. And be careful, you will find and you will be able to execute all these commands via C# and Java and other languages. However, don't use these experimental options because many often they are deprecated. And also keep in mind that if you are not using the bidirectional APIs that are suggested by Selenium team, these specific CDP methods, they're connected to particular browser version. This means that if something worked in version 115 of Chrome, and if you update up to 120, something might not work. However, most probably, for most of the time, if you're not using the experimental options, you are safe. However, as you'll see in the code, there is a drawback about that, because every time you need to update your usings and mention the exact browser version there. And the second domain that primarily now we're going to use in this particular module is called emulation. And in the emulation, here we have geolocation override. We can override the metrics. We already did that. Also, you can set a particular user agent. You can override the time zone, and many more, as you can see here. Again, half of them are experimental, so don't use them. All right, this is regarding the CDP and what we are going to use there. As I said, usually during local development and debugging sessions, I suggest to use this type of emulation, but later when you execute your tests in the cloud, obviously it's better to use the native capabilities of Lambda tests. And this is why I'm going to provide you all of those links, for example, for network throttling. As you can see here, this is a native capability that we can enable through this capability, network throttling. And there are particular values. As I said, we have regular 4G, regular 3G, regular 2G, offline, etc., which is excellent, and you can use them. Here you can see the download and the upload speed. As I said, and as you'll see, actually we can, through this Lambda test hook, we can set different download and upload speeds if you want really something custom. Most of the time, probably these pre-configured profiles will work for you, but if you need something else, this is Java. Actually here, as I'm going to show you, in C# we'll just use dictionary of string and object and provide of these key value pairs. That's it. And I'm going to wrap this in a Lambda test hook class. Next, as another capability, we can set the time zone. Again, this is not affecting the, and talking about the performance, but it's something about these emulation techniques. It's interesting. Next, if you want to download such a file, this is like a zip file for all the requests and responses. You can do that as part of the 𝑨𝒏𝒕𝒐𝒏 API. There is a method I'm going to show you that we can add that to our service utility class to download this zip file with all the requests. It's useful to have a library for making some assertions that I'm going to show you, that there are no error codes, or for checking for sizes of the responses and the resources. However, sometimes it's useful to have this zip file so that, for example, when you need to further deep dive with the developers of the web application, you can just attach that to a bug report or to this analysis report, and you can give them this zip file, which is excellent instead of writing something custom, right? All right, so again, here I'm going to give you this about network throttling. Also, you can change, there is a capability like language, and you can set a different language here for the application and emulate that. Also here, you can find some Android locales. We're going to use a native there are two modes in Lambda test. First, here I have, in a minute, just a second. Here I already executed one of my tests where I enabled all these features. And as you can see, I have a native report of Google White House. And there are two modes. Basically, you can turn this on for all of your tests. And in the end, this report will be generated. Or if we want to trigger that manually, there is a Lambda test hook with this JavaScript where you can provide a custom URL. Here, as you can see there, any URL. And we can generate multiple such reports through this hook. It's a little bit tricky how to use it. As you'll see, the code is a little bit more complex. The benefit here is that instead of just viewing that in our Lambda test platform, if you want to, for example, perform certain assertions for these scores, like with the native tool, we can do that. For example, we can create a regular test that it's run every night and check that the score don't fall below 90 or 80, right? And we can check those scores. And the big benefit of this hook is that actually it returns, when executed, this huge JSON result. As you can see, there are so many like super detailed statistics about all of the resources, all of the times, like with all of the audits. It's basically a JSON version of the whole report. It's very big. And later I'm going to show you how with code we're converting this JSON file to C# objects that we can later assert some of the scores, which is like super cool, right? And when you execute the hook, this is what you're going to receive. As you can see here, actually the response is a dictionary of a string and an object. The first one, it contains a message saying that White House report generated successfully. And then the whole JSON that I showed you is actually the value of this key, of the key data. And we're going to get just this value JSON, and we are going to deserialize it to C# objects. And later, we're going to add additional assertions to verify that and perform this analysis, but every day, not just, but with code, right? All right, so I'm going to, again, here we have other Lambda test hooks. As I explained, you have this Lambda network throttle. So instead of using the capability, we can change the network speed a little bit later during the execution. So we can do that. And as you can see here, we can fetch also not in a zip, but if you need to verify and do certain assertions, instead of using the emulation of CDP, we can use this hook to fetch all of the requests and the responses in their times, which is a great thing again. Or you can use here the API, and from the API we can get some of the logs as well. Also, don't forget that if we use CDP, you need to provide this here, CDP to true. All right, let's now switch to the code. Now, this is my test that I created specifically. You will find in our demo system tests under the performance namespace. It's called to do tests. I'm going to, and I used this demo website in a few occasions. Just really quickly, I'm going to explain what it's doing. This is like a simple to-do application. The same to-do application was written in different technologies, React, Angular, Vue, Knockout.js, etc. And it's very simple application. We're just adding to-do items. We can cross them, we can delete them. That's it. again, the actual implementation is not really important. We are using our framework to navigate to the page. I'm opening a specific technology, and here the specific part is that actually I in the original code I even added 100 items to the to-do list so that my test is a little bit longer, so that I can print all of those metrics, right? And you will notice that I have a new methods part of my DevTools service. It's called get performance metrics, and I'm calling this result because I don't want to make the whole test asynchronous. And we are printing to the console all of the metrics. Of course, we don't need to manually do that every time, but this is, I just wanted to print here to show you what all those metrics are. Again, some of those performance metrics are some internals for the Chrome browser. I don't understand all of them. You can check in details the Chrome for Developers website. There are some, most of the time when you do this performance analysis, probably you won't care about most of them, but at least these 5 that are at the bottom are very important. DOM content loaded, navigation start. I told you about these 2 about the heap, that you can catch memory leaks. Now we're going to use our plugin architecture for, as you can see here, I added a bunch of attributes. In a minute I'm going to explain them. But let's first take a look into what methods we added to this service here, to our DevTools service. So initially in our DevTools service, we had just a few methods about capturing and listening to the console logs, JavaScript exceptions, and pinning the script, right? Now I added other methods for starting network traffic monitoring. You will see that I have concurrent back collections containing information about the requests and about the responses. Why concurrent back but not a list? Because all of this is happening in parallel of those requests, and a regular collection probably you will receive deadlocks. This is why this special concurrent back collection part of the C#, it's thread safe, and we're going to collect all the requests there. You will notice that this network domain part of the bidirectional APIs, they have 2 events, response received and request sent, and we subscribe to them, and we are just adding all the information in our 2 collections. And in order to start monitoring, of course, we need to call this method. The clear network traffic, basically we are wiping out these two collections. We have, and I added some methods here for getting specific request URLs by name, getting the response content, some assertions for reading from the responses history, by type, by partial URL, asserting that there are no error codes. As you can see here, we are using some filters for that. We are asserting here that there are no error codes. In this link syntax here, we have additional methods for checking that a request was made or not made, etc., etc. Now, the interesting part about the emulation, if you remember when initially we were discussing the CDP implementation and bidirectional APIs, they actually use for the C# library this command design pattern that we used for, and we discussed during the configuration module that we were discussing our settings for the framework. But basically for all of the commands, we need to initialize such settings object, and all of them you will notice that they're behind a particular domain: emulation, performance, security. So right now, if we are talking about geolocation, all of them are behind the emulation. So you have geolocation override, you have time zone override, where we are setting the time zone ID. We have one for locale, we have for device metrics that we were, if you remember, in the initial modules when we implemented this mobile emulation. Then we can ignore all the certificates. Please note that this is behind the security domain. Under the network domain, as I mentioned, we can, for example, block particular resources. We can emulate an offline mode here using emulate network conditions. We can emulate, for example, connection time, download throughput, upload throughput, and these two, we're going to use them, as I said, part of the performance domain for turning on first, instructing the CDP to start collecting all those metrics, and in the end, we can get them as a metric array. That's it. And how this, again, I told you that it's a little bit tricky when you use these domains because they're bound to a specific browser version. And if you remember here, we have a global using class. Inside of it, I actually use two approaches. First, we have these global usings, meaning that you don't need in every file to mention this particular using. And also I use these aliases, namespace aliases, using aliases, where I don't, instead of providing the whole namespace, I use the alias. This is exactly what I used in the 𝒏𝒕𝒐𝒏 service. And the tricky part, as I said, is this here. This is the version of the browser. And by doing so, when we upgrade our browser to a different version, and you want to use another version of the 𝒏𝒕𝒐𝒏 protocol, then you will need just to update this particular file instead of searching where everywhere you put those. All right. Next, if we return to our demo test, you will notice that I added all of those new attributes. All of them, of course, they are working both with the lambda test attribute and with the local execution. So we have geolocation by latitude and longitude, we have time zone, we have locale, network emulation, we have tree for mentioning whether we want to capture the network traffic, capture the native performance metrics, and capture the White House performance metrics. Let's quickly review them. You will find all of them under plugins, performance here. So let's deep dive. First, let's check the geolocation attribute. They are very simple. I mean, they contain most of the time, they're just containing information about the locale, the longitude, the latitude. You will notice that we have two constructors because, for example, if you use lambda test or the native codes for geolocation, like those ones, probably you don't need to put the longitude and longitude, right? If you want a particular location that it's not directly here, but for example, a particular town or particular building, then you can use the other constructor here for mentioning specific coordinates. And we have all of those static classes with constants. After that, we have the local attribute containing the locale. We have similar static class containing all of the codes. We have network emulation attribute containing, you'll see whether we want an offline mode, latency, download throughput, upload throughput. You will notice that we have connection type required for 𝒏𝒕𝒐𝒏 protocol and connection type names. As I said, we have additional connection types for the lambda test cloud. This is why we support both. And we have a few different constructors. These are the network types provided by lambda test instead of, you know, using magic strings everywhere. We have performance matrix names. These are the names that you see exactly here. If you remember the getMetrics method, it returns an array of metric objects. Every metric object contains a name and a value, and those are the names. And we can, as you will see, filter by those names. This is why I have a class with all of them. In a minute, I'm going to discuss the performance service. It contains and give you access to those assertion methods, and the main logic is happening inside our plugin. And we have this also time zone attribute containing the time zone name, which is something for Lambda test, and time zone ID for CDP. Now, if we return to our to-do test, you will see that everywhere I have all of those assertions, where I'm basically asserting this matrix here. I believe that the big part of your performance analysis will be like checking all of those times, especially in Google Lighthouse. As we'll see, we have a native capability using the Lambda test hook for triggering this. In a minute, I'm going to explain that. But regarding the native performance metrics, you will notice that they are part of this performance services class. Actually, we can remove that, even like that, use it a little bit shorter, because on top I use a static using for these performance services and performance metrics. This is the benefit of using static classes for holding off our constants, because we can use this syntax with using static, and after that we don't need to mention here first the name of the class, then the constant, and this is making our code a little bit more concise. You will notice that most of the time I'm asserting that the metric is less than. We have another method above than, but usually you want to verify that while you execute your test under particular geolocation, network throttling, etc., all of those values are below a certain threshold, right? Otherwise, you want to fail the test. Now, let's first discuss our new plugin, which is called Performance Testing Plugin, right? This Performance Testing Plugin, you will notice that, again, we derive from our core plugin, coming from our core project. And we execute particular logic before the test initialize, after the test initialize, and after the test cleanup. Usually, as you will see in the before test initialize, since this plugin will be executed before our browser launching plugin, we're going to add new capabilities. These new capabilities, we are going to instruct our driver factory that when starts the execution in Lambda test, we want to use these new capabilities. In a minute, you're going to see what we do here. The big part of this plugin here, you will notice, is actually we are using some reflection to get these custom attributes. On purpose, I didn't make a generic method for that. We can definitely do that. Instead of having 7 methods, we can create, for example, a method like that. Get T attribute, and we need to mention here where T attribute derives from an attribute. And then instead of having all of them, we can use just the generic version. That's fine. But yeah, most of the time, again, we use usually attributes or annotations in Java for providing meta information. Like in our case, we are setting the locale, the geolocation, the time zone, whether we want to capture a performance matrix, etc. So here in the initial part of all of those methods, we are just getting information about whether we have the attributes or not. Everywhere we are checking, is this here? Is it set? If it's not set, of course, we are not going to set these custom grid options. This custom grid options is just a dictionary of string and objects. I have added that to our driver factory. And you will notice that here, when we add these grid options for Usually we provide them and we set them in our Lambda test attribute right here in the grid arguments. Mainly here we are setting whether we want a video, whether we have a tunnel, setting the build, etc. But I added this additional option where, as you can see, we are for eaching this dictionary of string and objects, adding these additional parameters. And this way, when we have plugins for that, we can enrich that, or even later in another parts of your code, you can add custom capabilities. So if I have the geolocation, I read the documentation of Lambda test and I set this geolocation capability. Then we set the time zone, the language with the locale. If we have network emulation, we are enabling the network throttling capability and adding here the connection type name. As I said, there is a difference and we have more options for Lambda tests regarding these pre-configured profiles. If we have and we need to capture the network traffic, you need to set the network capability to true. And if you want by default to have White House report, you need to enable and set this performance false. However, if you read the Lambda test documentation regarding the White House Lambda test hook, you will read there that they told us that we need to turn this off if we are going to use the hook. Since I'm using the hook instead of this, I turn this off, but I'm leaving it here for you just to, if you want to use it. Also, after test cleanup, I'm just clearing the network traffic. That's it. Now, right now, it doesn't matter whether this will be executed in Lambda test or not. Even if you're not executing, just this will be ignored. So that's fine. This is why I haven't added another branch here. So after we do the test initialize, this means that our session was created in Lambda test already. This is why it matters right here. Since this, if you remember how the observer design pattern works, we are basically for eaching all the plugins. And when you add your plugin, it really matters right here. When we add the plugins, their order matters. If you put and initialize the performance testing plugin after the browser lifecycle plugin, this means that we're going to start the Lambda test session and then add all of those additional capabilities and nothing will change. This is why we are first adding all of those capabilities before the test initialize, and since they are going to be executed in the order that we added them to the plugin execution engine, then after that the initialization and starting the session will happen. All right, since the browser and the session are started during this before this initialize phase, this means that if we want to execute additional logics like additional Lambda test hooks, etc., or CDP emulation commands, we can do that in the after test initialize. So I'm initializing the driver adapter where I can basically I can use all of the geolocation emulation methods. This is exactly what I do. As you can see here, we have an additional check. Is this a Lambda test run or not? If it's not a Lambda test run, then I'm checking, do we have all of those attributes? If yes, then I'm just executing and calling all of those emulation methods, overriding the geolocation, overriding the time zone, overriding the locale, emulating the network conditions, starting the network monitoring, and all of that. If it's a Lambda test run, the native capability that we are going to use is actually about the network throttling. As I said, we have a few Lambda test hooks. The native one that most probably you are going to use is this connection type name, 3G, 4G, etc. Again, if we take a closer look how this works, we are just executing this snippet of JavaScript, providing the profile, 3G, 4G, right? Lambda test throttle network. We can, let's just close other tabs. And also we can add this particular snippet to our Lambda test hooks for specifying additional download, custom download and upload speed and latency using again this Lambda test throttle network. Again, I told you that the syntax there in the documentation is using Java and C#. Instead of map, of course, we use dictionary of string and object. I'm initializing this dictionary and adding this as keys and this as values. That's it. And we're getting this information part of our attribute. That's it. And at the end, no matter what is the whether this is a native run, local execution, or in Lambda test, we in order to be able to access all of those metrics here, we need to turn on the performance metrics, right? Again, I'm using the wait method because this method by default is awaitable, and this wait will just wait until the command is sent and received from the DevTools protocol. All right, and after that, this will work both ways, locally and when you execute your tests in the cloud. I have a version 2 of the framework, of the plugin. And this version 2, why it's different? Because actually right now we're controlling everything through attributes, right? However, I extended our web settings and I added all of those new settings here in our static web settings class. And you'll see that we have additional keys for setting the geolocation, setting a custom geolocation, latitude, longitude, accuracy, a custom set time zone, lookout, enabling the throttling. I have this network throttling settings, like for example, turning it off, changing the download throughput, etc. Again, most probably you won't want all of the tests to be emulated or do this type of performance analysis, but just of a subset of your tests. This is why I usually, I think just the attribute solution will be fine for you. But however, here again, I refactored the same plugin, and you will notice that we have here this OR clauses where if we don't have the attribute, we will check, do we have set this to true? If it's true, then we are going to get it from the web settings. You'll notice that we use this special operator with 2 question marks. This means that if this is null, then we're going to get the geolocation default value. Again, this will be executed only if some of these 2 are true. If we have attribute or if this is true. If this is null, this won't throw no reference exception, because again we're using this special operator with the question mark dot, and C# is protecting us instead of having very complex if conditions here. So I refactored the whole code to support that. As you can see here, we're using the web settings. Now let's discuss how we do this type of assertions that I told you about. Again, they're part of this performance service class that you can find right here under the performance namespace. These native performance metrics, you will notice that we initialize the adapter and then we call getMetrics.result, and this is returning like a metric array. And then after that, we just filter the metric by name, getting its value, and then we're performing assertion and we're throwing an exception if something happens. Also, we have a specific event where you can subscribe, and we can implement BDD logging, toast messages, and everything else that was related to the events if you watch previous modules. This is how this works. Also, we have another method for checking native performance metrics above them. you will notice that we have many other assertions here. They're related actually to this logic here, perform White House analysis. As I told you, Lambda tests, they provide this native hook about generating Lighthouse report. And you will find it in this separate documentation. It's not part of the original list of Lambda test hooks. It's right here. This is the full list, and again here you won't find the one for Lambda test Lighthouse integration, but you will find it here under generate multiple White House reports. It's a little bit trickier since it takes a little bit longer to execute, and if we open it again, it's part of this Lambda test hooks class. It's right here under integrations, under the Polaris web. And you will notice that we are returning that in this dictionary string object format. If you remember, the thing that this hook is returning is a dictionary of string and object. And we need to extract the JSON from this key value pair of data and the JSON here. I'm using here native WebDriver wait for if there is an error, specifically WebDriver exception. In a few times, you will notice that you may receive, for example, timeout exception. Again, because this is very time consuming, and again, it's not up to the Lambda test, but probably you will need to retry it a few times until it's fetched correctly. Otherwise, you may receive this failed to generate White House report message. So every time I'm using the hook and I'm checking if we are returning dictionary of string and object, that's fine. If this contains an error, then we repeat that. That's it. Usually it takes around 1 minute, 2 minutes to generate the report. So that's why I told you that probably it's not a good idea to execute that for all of your tests, especially if you have thousands of tests. Keep in mind that even if you use the geolocation, capturing the performance metrics, you need to be very careful enabling them one by one, because if you enable them for all of your tests, this means that probably this will affect significantly the execution times of your tests. So I have this Lambda test hook, I'm executing it. So in my JSON response, as I told you, it will return a dictionary. And in this dictionary, I'm getting the value, the JSON, and using the key data. And then I'm converting this JSON here that I showed you before. This is the JSON. I'm converting it to native C# objects. I put them here in this file, performance report. As you see, they're quite a lot because this is a very big file, right? But this will be serialized to this root object that if we check it, you will notice that it has, for example, the White House version, the fetch time. We have all of the audits and all of the categories. Probably you access all of the audits, for example, first contentful paint, the largest contentful paint, first meaningful paint, and probably you are going to assert them. So I added some pre-configured assertions for some of those meaningful metrics for us, part of the report. And as you can see here, I'm getting the actual value from performance report, value audits, first meaningful paint dot score. And I'm asserting them that it's more than something or less than something. Again, probably most of the time you are going to use less than. So you can use the pre-configured methods for most of the most useful metrics, or I added a generic method where you can use this Lambda syntax for accessing all of the different properties, part of this report, and then apply a generic assertion here. And this will fail if this condition is not met. Again, using these metrics, this is very helpful. In the past, as part of one of the enterprise projects that I was part of, the developers there, they were developing this performance plugin, performance optimization plugin for certain applications, and they had like 100 different optimizations. And we were quite extensively using this sort of analysis for checking whether all of those performance optimizations are working or not. Again, using this native integration between White House and Selenium, and all of those additional metrics that are part and provided by Chrome developer tools. Together, again, with these verifications for capturing the network. All right, we covered a lot of things. Again, we were discussing some of the native CDP emulations and all of the native Lambda test capabilities about geolocation, setting time zones, capturing the network traffic. Also, we discussed the progressive web applications, single page applications, what is Google White House, how we can implement and integrate all of those emulations inside our framework using the observer design pattern together with our plugin architecture. We extended the DevTools service. Yeah, quite a lot. In the next module, we're going to cover some security best practices. In our framework, we are going to add new services. It will be very interesting, so stay tuned. Hi guys, greetings from Bulgaria. I am Anton, and this will be our next video part of our course about advanced test automation frameworks development. This time we're going to talk about security best practices. If you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when new videos are published to the Lambda Test YouTube channel. Also check the awesome Lambda Test blog because there are many detailed articles that can help you to be a much better test automation engineer. In the links below, you will find a link to the GitHub repo with the full source code and also some reference articles to deep dive into some of the topics and also some other video courses. So, before we begin, please clone the repo. It's called Polaris White Test Framework. For this particular course, instead of creating a separate repo for each particular module, I am creating different branches in this particular repo, Polaris White Test Framework. So for this particular video, after you clone the repo, check out this Security Best Practices branch. I'm doing so because we're upgrading the framework with each particular module bit by bit, and you can find all the upgrades in the separate branches. I suggest to watch the whole playlist from the beginning, from module 1. I'm always trying to create these modules separate from each other. However, they're built as something bigger, right, in mind. So I suggest to clone the repo and check the code while together with my explanations in the video, and this will help you significantly. Also, you will find in the description below some jump links if you want to skip some of the parts. Now, let's discuss now the agenda for this particular module. First, we're going to discuss what is zero trust architecture. I need to emphasize that for this particular module, I am not going to discuss topics like security testing. Instead, we're going to focus on these security best practices for keeping and saving the secrets in our framework the right way, how we can find some vulnerabilities using dependency scans. And in the third part, we're going to talk about hiding secrets. Imagine that when we execute our tests in the cloud, as you know, there's many logs like the Selenium logs or the BDD logs that contain what we are typing. And imagine that we can expose this way some of the secrets like the password or the emails. Of course, we're not going to talk only about hiding the secrets using environmental variables. This is part, but we discussed this in the past. Instead, I'm going to present to you two different solutions, like centralized secrets managers like 𝒏𝒕𝒐𝒏 𝑨𝒏𝒈𝒆𝒍𝒐𝒗 and AVS Secrets Manager, and we're going to integrate them tightly into our framework and have this backward compatibility with environmental variables. And in the end, we're going to discuss how to hide the secrets in a Lambda test, because they have additional capabilities for that. And also we're going to apply the same refactoring for the framework for hiding the secrets in our toast messages and BDD logging. So let's begin. First, what is Zero Trust architecture? Zero Trust is a modern security approach based on the principle of never trust, always verify. Unlike traditional security models that assume that everything inside the network is safe, Zero Trust treats every user, device, and service both inside and outside the network as untrusted until proven otherwise. And let's discuss now some of the key concepts here. The first one is least privilege access. Only grant users and systems the minimum permission necessary to perform their tasks. This reduces the risk of unauthorized access of data breaches. So how to apply it in our context? For your test automation framework, don't grant full access to databases, APIs, or systems. If a test only needs to read data, ensure it has read-only access. For secrets, avoid hard-coding credentials in your tests and use secure storages like Azure Key Vault or AVS Secrets Manager to limit access. We'll focus on that in the next section. The next one, continuous verification. Even after initial authentication, continuously verify identities and permissions. This ensures that every access request is legit, especially during long sessions or repeated access. So how to apply it? If your tests are running against an API that uses token-based authentication like OAuth, OAuth2, make sure the tokens are short-lived and that tests regularly re-authenticate. This ensures that if permissions change or credentials are compromised, they don't persist throughout long test sessions. This is why, for example, in Azure DevOps, when we authenticate our test agents, these tokens by default are valid only for 30 days or even less. And this is a rule of thumb for passwords as well. All right, so the next one is segmentation. Break down resources into smaller, isolated segments, ensuring that access to one part doesn't automatically grant access to everything else. This limits the impact of potential breaches. This is especially true when we work on test environments, because I saw that many teams in the industry, they use the same password or the same user, and this user has access to everything, even if it's test environment, because they think that they're safe and they give this user like this gold mode. So how to apply it? Tests should be configured with different credentials for each environment. This is obvious. For example, tests running in development shouldn't have access to production systems or data. This helps limit the scope of potential breaches or issues during testing. I know that it sounds like common sense, but believe me, many people still do it. Alright, so no implicit trust. No device, user, or network is inherently trusted regardless of its location, whether inside or outside the network perimeter. Every request is treated as potential malicious and is verified accordingly. Alright, so incorporating Zero Trust into your security model ensures that even if part of the system is compromised, it won't compromise the entire network, offering stronger protection for modern applications and systems and test automation frameworks. Now, connected to some of the key points part of this architecture, let's discuss now dependency vulnerability scans. Nowadays, if you watch some of the previous modules of this course, you know that we are using large amount of third-party dependencies and libraries as NuGet packages. And it's really important to implement NuGet package auditing or dependency vulnerability scans. I'm going to show you now two approaches for doing that. There is one built-in approach into Visual Studio that it's using the NuGet built-in capabilities, NuGet auditing. So NuGet can alert developers to vulnerabilities if they're using the .NET CLI or Visual Studio. This is powered by GitHub Security Advisories database. So when we open here the NuGet Packages Explorer, you will notice that I have this warning sign here under installed. These are our installed packages. I also marked here this checkbox, show only vulnerable NuGet packages. And you can see that I have this top level package, 𝒏𝒕𝒐𝒏, because I use it in a couple of my projects to make REST web API calls. And from the right side, you can see what the vulnerability detected, the vulnerability scan detected. Here is a short description, and also we can open this link here. And probably there is a suggestion to upgrade it. This is one way of how you can find such vulnerabilities, but you can do this manually from Visual Studio. Another way is if we run the following command, .NET list package vulnerable. This .NET CLI, if you remember, we use it to run our tests in from the command line. And when we integrate into CI/CD pipelines in Azure DevOps, in a second I'm going to show you how we can integrate that in our continuous integration. We can use this particular command, or I'm going to show you one more tool. So after you run this command, on the console you will see these particular results. We have a top level package, it's called 𝒏𝒕𝒐𝒏. This is the version. You can see that this is a moderate severity of the vulnerability, and I always suggest to open these particular links here that will contain more information about this vulnerability. Let's see what we have there. I opened here the vulnerability. As you can see, this is, as I said, it's part of the GitHub engine. So here is the GitHub advisory database that these tools are using. And we have a summary, we have details, we have a proof of concept, how this can be reproduced, and some other references and the impact. And maybe sometimes there are some suggestions about what we need to do. And as you can see here, these are the two affected versions, and the suggestion is to upgrade the 𝒏𝒕𝒐𝒏 to this particular patched version. All right. If you use GitHub Actions for CI/CD, I think this will be automatically done for you. Another tool that I'm going to show you is OWASP dependency check. This OWASP dependency check is part of the OWASP Foundation, which works to improve the security of software through its community-led open source software projects. In another video, probably, if we discuss security testing, they have quite a lot of projects that help security testing. They have security testing checklists for mobile, web API, web. They also have another tool for that, it's open source proxy for scanning web applications and finding vulnerabilities. They have many other projects for supporting security testing. This particular tool helps identify publicly disclosed vulnerabilities in project dependencies. It supports multiple languages, including C#. It's using another database, this database, let me find it. Yeah, National Vulnerability Database. You will see that again when you download the COI version. You can run it without an API key, but it will be very, very slow. This tool uses this National Vulnerability Database of United States. And you can get a key for free. You just need to mention the name of your organization, email address, and what is the sector. You get the API key, and then everything will be much, much, much faster. I suggest to check the tool documentation. As you can see, it has so many arguments here to run it from the command line. It's much more powerful than the GitHub version. This is why I'm showing you. In order to run it, this is the command here. Dependencies check. After you download it, you need to add it. If you're not going to run it from the folder when you unzip it, you need to add it to your path environmental variables. And after that, you can call dependency check scan, then path to your project. And after that, you have a format of HTML and an output directory. That's it. After you run this command, the following report will be generated for you. Here is the report. This is the HTML version of the report. As you can see, I mentioned the report directory dependency check report. You will notice that this tool caught again the REST# dependency, this particular version. However, it caught one more vulnerability in the report portal integration with the Selenium logger. And as you can see, both of them actually have a severity of medium. When you scroll down, you will find a little bit more information about both. And if you click on some of the links, you will see that again, this website will show up with more details about what is the issue and how you can solve it. Now, we can integrate that in our continuous integration. This is the Azure DevOps. If you watch the video about results analysis integration, we created this Azure pipeline for running our tests and publish the results. We have an integration with Allure and then with Report Portal. But again, here the focus is how we can run these vulnerability checks inside our pipeline. So again, you remember that we have this .NET Core task here in Azure pipeline. And as you can see here from the dropdown, we have different commands like packing a particular project to NuGet package, we can publish it, we can execute all of the tests from the project, we can build it, etc., etc. However, we don't have this specific command for listing all the vulnerabilities, list package. This is why we need to pick here a custom command. And our custom command will be list package. And after that, as some arguments, we're going to pass this vulnerable so that we can list all the vulnerabilities. By default, probably this is not going to fail your build. You need additional logic for parsing the results and maybe fail your build. This is why I suggest to download and install an extension for this OWASP dependency check task. It will give you the power to do the same thing that I showed you before with the OWASP dependency checker. So we need to provide path to the projects that we want to scan. As you can see, we can scan more than one project if we use regex expression. Also, you can even not only publish an HTML report, but we can generate CSV, JSON, JUnit, and other formats. And it's even better we can upload the reports as artifacts after the build completed. Really awesome. And as you can see, it has many other options. You can provide here the NPI key. If you got one from their website, you can experiment with some other analyzers. That's it. Really awesome stuff. All right, let's continue with our presentation. Let's now talk about hiding secrets, right? Let's open our solution. And if I open the Lambda test attribute here, you remember that in order to integrate with Lambda test, many often always actually we need this username and access key, right? So when developing a test automation framework, security is a critical aspect, especially when managing such sensitive information like API keys, credentials, and other configuration secrets. So integrating environmental variables, Azure Key Vault, AWS Secrets Manager, we're ensuring securely handling of this sensitive data. So when dealing with this sensitive information, hardcoding them in your source code or storing them in configuration files such as JSON introduces significant security risk, as these files can be easily exposed or leaked during code sharing or deployment. Again, instead, using environmental variables provides a more secure alternative since they keep sensitive data outside of your source control. This is why, until now, I used environmental variables. However, while environmental variables add an extra layer of security, managing secrets at scale, imagine that you're a team of 20 QAs in your organization. This means that on every development machine, all of the people that are writing such automated tests, they need to have, I don't know, maybe 5 up to 20 such secrets, depending on the context. This means that if those secrets expire in a month, all of those people need to update all of those secrets on these machines. But imagine that you're handling your own build machines. There you need to update all those environmental variables again. Then you need to update them again in all of the pipelines. But usually in big enterprise projects, we are not talking about one pipeline. Even in smaller projects, like 10 engineers, if they are working there, we have maybe 20 pipelines. Imagine the scale of that. So it's a lot of maintainability issues, right? So this is where tools like Azure Key Vault come into play, offering centralized encrypted storage solution that simplifies secrets management and access control. Azure Key Vault integrates with other Azure services, enables automated secrets rotation, and provides fine-grained access permissions, making it superior options for securely managing secrets across distributed systems. It's so what is Azure Key Vault? Let me open it here. I created a Key Vault in my demo Azure account. This is the Key Vault. So Azure Key Vault is a cloud-based service that helps safeguard cryptographic keys, secrets, and other sensitive data. It is designed for securely storing and accessing secrets in applications, including automation frameworks. It's centralized management. It has these access policies right here. You can restrict access to specific users or applications, ensuring only authorized entities can retrieve sensitive data. Usually, a completely different team is responsible for configuring and setting the secrets. Probably this will be your admins, right? Admin department or Azure DevOps team. And they will just assign you a role, and on your machine and in your test automation frameworks or pipelines, you just access those secrets via these integrations. This is usually how it works. So when we create this service in Azure, again, most of the time you won't have direct access, and this is the whole point of it. We have different people managing it. This is making it harder for someone to steal secrets. So when you go here to generate import, you can manually add secrets. Like you can provide the name here. This will be similar to the name of your environmental variables. This is the name of the secret. You provide the secret itself here. This will be your username, your password, authentication key, etc. We can set even activation and expiration dates for that, and we can enable it or disable it. It's really awesome. So how we can start using it? By the way, another implementation that I'm going to show you, if your company is not using Azure, there are completely similar tools provided by AWS or Google Clouds. The AWS Cloud tool is called AWS Secrets Manager. Again, it offers the same things. I'm going to show you how we can use it as well. So in order to start using with the Azure Key Vault, as with the other integrations that we built into our framework for these third parties, they offer NuGet packages, right? One obvious question is how we authenticate, so that obviously you need first to use PowerShell to sign into Azure, and if you have access to the Azure Key Vault, after that the NuGet packages that are responsible for authenticating, they will do that. You don't need to manually store anything on your machine. There are alternative approaches how you can do it. I suggest to use the suggested prerequisite here using PowerShell. After that, you need to install two NuGet packages. This is getting started using the Key Vault Secret Quant library for .NET. So you need to install this Azure Security Key Vault Secrets, and we need one more, this Azure.identity. Again, this will be responsible for handling the authentication to the Azure cloud. After that, it's pretty simple how we use it. Their SDK, they provide this secret client. This secret client, it requires the vault URL, that maybe this is something that you can supply in your JSON configuration or static configuration files, or you can even store that in an environmental variable. It will be up to you. After that, we have two methods, getSecret, setSecret. Most of the time in the test automation, probably you just use getSecret, that's it. And we will get, for example, the 𝒏𝒕𝒐𝒏 username, the 𝒏𝒕𝒐𝒏 password, etc. Let's see how we can integrate that into our framework. As you can see here, I implemented one key class called Secrets Resolver. In a second, I'm going to explain what it is, but let's first define the requirement. Since we're building a framework, we cannot force all of our users to use a specific key vault or the AWS Secrets Manager, right? Some of our users might decide that it's easier for them not to pay for that, but to use environmental variables, and that's fine. This is why we can integrate all of them. And by doing so, by creating this utility class, Secrets Resolver, we'll do more than that. Even this will ease if we need to change the logic later. For example, if you need to switch from Azure Key Vault to AWS Secrets Manager, or to switch completely to environmental variables. You don't need to go into 100 files in your framework to make those changes, right? So instead of this time going to the integration project, I'm going to create those classes here in the core project. The reason for that is that all other projects are referencing the core project together with the integrations. So it doesn't make sense. Our configuration core classes are located here in the core project. This is why I'm going to move all of those secret managers here. You will notice that I created a new namespace called secrets, and we have two child namespaces, one for AWS, one for Azure, and here is our secrets resolver. Again, the secrets resolver, as you will see in a minute, it's combining environmental variables, Azure Key Vault, AWS Secrets Manager, and even we have one additional feature in the configuration using files. What is this feature? If you remember the video and if you watch it about configurations, you remember that we have this alternative syntax, not hard coding some of the secrets or usernames, like here. This is not a secret, but this is the name of the project. But obviously, if we want to hide something, we can instruct the framework that the value for this key here is actually present in an environmental variable. And also we will have another prefix here called vault and another secret manager to instruct the framework that this value here is present in environmental variable, key vault, or secrets manager. And the part and the framework, what it will do, it will remove the curly brackets, it will remove this prefix here, and it will replace the whole thing with the value present in this environmental variable. However, sometimes we need an alternative syntax, as you will see, because we don't know by default whether this is the real value or it's something holding a secret. And then we need additional logic for checking for that. If this is not a secret, we need to return directly the value here. So we will have a method for that in our secrets resolver as well. Let's first see how the key vault integration works. As I said, this is our core project, and these are the NuGet packages that I installed. We have one for the AWS Secrets Manager, and I have the two NuGet packages for Azure Key Vault. So both of them, as you can see, they have both utility classes and their related options design configurations settings, right? These settings are pretty simple. They contain the endpoint, the region, whether this is enabled. For the key vault, just the endpoint and whether this is enabled. That's it. So how the key vault works? We have usings to Azure Identity. Again, this is for allowing us to authenticate. Then we have a reference, static reference to the secret client. We are keeping the same design, making this class static. Everything here is static, and it's easier for us to use it. I exposed one property, whether this is available or not. Depending on that, in our secrets resolver, will trigger the branching. And after that, we have some initialization logic that, again, I copied just from their documentation. Here we are initializing the client, providing the vault URL, getting the from the settings the key vault endpoint, and again here we are just using the Azure Identity NuGet package for initializing it. I mentioned that I initialized that from the CLI. That's it. And after that, I exposed just the getSecret method, where we're calling secret client getSecret by name. That's it. The AWS Secrets Manager works in a similar way. We have a few usings here. Again, the class is static. We have a static reference to the Amazon Secrets Manager. We have a method for initializing the client from the endpoint and the region. And then one difference is that their method is asynchronous. instead of making my method asynchronous async to, I simplified a little bit and I called result, which will force to wait here until we receive the secret. That's it. And then we need to convert the secret. If it's a binary, we need to convert it to a string. And then if the secret is a string, then we're going to return it. That's it. And now the secrets resolver. We have one simple method called getSecret by name. This is the name of the environmental variable, or basically our secret in the key vault or inside the secrets manager. As you can see, first we are checking and we're getting the environmental variable, replacing this prefix here, environment, as we saw in the JSON config. We are also removing everywhere these curly brackets here. And after that, we are checking, do we have such an environmental variable? If yes, then we are not making any other calls to the key vault. We are just returning the environmental variable. Else, if the key vault is available and we initialize it, then we are calling key vault getSecret. Again, we are replacing the vault. Actually, here for the secrets manager is another prefix. I have a bug here. It should be like that. Then we are replacing the vault and returning the value. That's it, the whole thing. So if we return to our lambda test attribute, if we use just the simpler version of this method, not any other config versions, this is how we are going to use it. Not with environmental variables, but we are going to call our secrets resolver.getSecret, then providing the name of the secret itself, whether this is an environmental variable or the name in the key vault. This is version 1. However, as I told you, if we are using the more sophisticated approach using JSON files, you actually don't know whether you need to return directly the value or whether you need to read something from environmental variable or the vault. This is why in our secrets manager, secrets resolver, we have an alternative method accepting a function here called getValue. And this getValue actually will be, as we can see, this is how we use it. Let's remove the comments here. So we're getting the section, the web settings section. So we have our web settings here. We're not talking, please be aware, we're not talking about static version of the settings for simpler projects. We're talking about JSON files because they will be different for each environment. And as you can see here, instead of providing just the name, like here, we use lambda expression, providing web settings, grid settings, arguments, username to string, or any other setting here that we want to return, for example, not default browser, but something else. And the thing that we're going to do here is now our secrets resolver, we will need to check if this contains our specific syntax with the curly brackets and environment underscore or vault underscore or sc underscore, then it will do something else. Otherwise, it will just return the actual value present in the configuration itself. So here is the branching. If this begins with curly bracket environment or curly bracket vault or curly bracket sm underscore, we're calling the respective stuff to get the data, environmental variables, key vault, EVS secrets, or we are just returning the value itself. I know that this is making it much harder to use these JSON configurations. This is why I wanted a simpler version of that. The simpler version is if we comment that, we can actually use such extension method for the strings. I put this extension method to the secrets resolver as well. As you can see, the only difference here is that we have here the key word this config value, and then this is of course static, and then we execute the same logic, or actually you can execute this method here so that we don't repeat the whole code. This is how it works. All right, let me uncomment that and let's proceed with the last part of hiding data, especially in Lambda test. I executed a few tests here on Lambda test. I have two tests. If you watch some of my videos regarding single sign-on master authentication, I will put them in the comments below. We have there a demo application for login using different formats, like for example using two-factor authentication in these security codes, and also with Google and Meta identity providers with passwordless login using emails and SMS. This is out of the scope of this particular video, but there I'm also showing how you can work around CAPTCHAs. And I re-implemented these particular examples, but in C#. But the whole point that I wanted to explain now is that let's rewatch the video. Let me just refresh it. So when we watch the video, the whole thing is that here I'm typing some passwords, right? And we have toast messages. In toast messages also, we can see this is the demo app that I'm talking about and the CAPTCHA. In a second, I'm going to explain really quick. It's out of the scope. But this password, as you saw it, is the problematic one. Because when we type it, if we scroll here, you will see that we have a text command here, right? And usually for the text commands, here you're going to see the actual value of the command that is typed. And also you're going to see it right here in the request body. And anyone that has access to your Lambda test account or to some of the links the password will be visible to it, to him. So we want to protect that. And as you can see, I protected that by masking it. How we can do that? It's really interesting. You won't find this in, there are two problems right now. This Lambda test logs, and the next one is our BDD logging. And I'm going to explain how to do both of them. So for Lambda test, this is easy. You won't again find this into regular capabilities generator. Actually, when you go to the awesome Lambda test documentation, you will find this section, testing capabilities. At the bottom of this section, the last part is about masking sensitive data. And you have a capability called Lambda mask commands. Actually, we can mask all, as you can see, we can hide and redact all of the text sent via the send keys command. This is related to text, emails, passwords, anything else, and also about cookies. If you again watch some of the videos that I link below about mastering authentication, and if you watch this video, there I'm explaining how we can speed up the test execution by skipping the login into the application altogether if we have a mechanism for setting the authentication cookies. So many often we use cookies for example, setting shopping carts, setting other important but sometimes sensitive information. This is why it makes sense to hide this into the logs. So at the bottom, you will find here 4 different languages how you can, I will report that because here they have a bug. But these are, in a second I'm going to show you how we can implement that. So in my Visual Studio again, here at the bottom of our Lambda test attribute, right here, that we are, putting on top of our test classes so that we instruct that we need to run the test inside Lambda test. I have added a new global setting for the logging settings called should mask sensitive info. If this is true, then we are creating this mask commands new string array with set values, set cookies, get cookies. Again, it will be up to you whether to put all of them. I suggest to use the defaults and put the 3 of them. And then I am adding this lambda mask commands and providing the array here. That's it. After that, if you initialize that, everything will be hidden in the logs. However, there is one more thing. You remember that we have BDD logging, right? When we talked about extending some of the elements, you can see it here. We have it inside the continuous integration walks as well. Also, we can print it into report portal in many places. So you want definitely to hide this information there. Also, in the videos on Lambda test, if you turn on the toast messages that I turn off right now, so that the test is faster, you will notice that I have actually implemented this asterisk here for hiding some of the secret information. But this is something additionally that I did. I based it again on our should mask sensitive info property. And let's deep dive of how this works. If we go to our components, for example, let's say the text field, you will remember that we implemented that via this event handlers text set, right? And inside our type text, you will notice that I have one new addition here to our type text. This is this info type. This info type is a very simple enumeration marking whether the information typed inside the input is informational or a secret. And after that, I'm providing here the text set. You will notice that here we're using the wrapped element, we're clearing the input and sending keys, and after that I'm invoking the event here, text set. You will notice that I'm providing here the component action event args. This is the class that holds all the information for all of the subscribers, all the implementators of this event, all the event handlers. So we have event handlers for the BDD logging and the toast messages and any others. Actually here, so if we look into the actual implementation right here, for example, for the password, let's say, you will notice here that I have this BDD logging password event handler, and I'm calling just my logger. I haven't changed anything. I'm just saying typing this particular action value, this will be my password, or in other implementations here, the value inside the text field or the email or the date, etc. I wanted to make it simpler so that I don't need to go over all of those classes. The way this works is that I basically hide all of this inside this component actions event args. I introduced a new variable called action value, and I have now this action value property that I had before. When we set it, I haven't changed anything. I'm setting it just to the value that we are assigning, the password and the email. However, when we return it, you will see that I'm checking the global settings now, the logging settings. Should we mask the sensitive info? And whether the info type is secret. If it is a secret, if both of these are true, that we need to mask and that this is a secret, then I'm returning asterisk, I'm masking it. Otherwise, we're returning the action value. And this means that every time when we're printing something or validating text, etc., this will be implemented for us. And this is how this masking here works. So we are saying typing this asterisk into the username, whatever, and also this is implemented for the validate. Again, not everywhere I have set that the text is a secret. By default here, for the password components, I'm passing by default when I'm invoking the event here password set, I said that this is always a secret because it's a password. However, when dealing with emails, by default, again, I set a secret, but it will be up to you. If you want to see the emails, then fine, you just change it to info. When you type text, it will be up to you. Again, I implemented this test that I told you about regarding bypassing the two-factor and the CAPTCHA. So when you type, for example, here, the 2FA code, if you don't want the 2FA code to be visible in the BDD logs or in the toast messages, then fine. Now you can say info type and you can say secret. That's fine, and then this will be hidden. But since I added this info type as default parameter, it didn't break all of my existing tests because basically they continue to work with the original implementation accepting one parameter. The same is valid for validate inner text. If you want to hide it, I have added some again default parameters here regarding the info type. If you want to hide the secret, if it's something secret, you can add it to the validate methods as well. Yeah, that's it. And one more thing, to bypass the CAPTCHA, if you watch the video, you will remember that I implemented a way for, in our test code for the application, I added that we have this hidden input where when we set the value attribute to this particular known only for us GUID, then we are bypassing the CAPTCHA. Again, this is really important to be available only for your test environment, not in production. However, again, it's not a good practice to, hard code this in your code. Instead, I would suggest again to use the secret searches over here and to hide this GUID there. All right, that's it. So we covered a lot. We talked about zero trust architecture. We saw how we can scan for vulnerability of some of our NuGet packages. This is really important. So always check whether your NuGet packages are up to date. I always suggest at least use environmental variables instead of hard coding data. And if your team is even bigger than 2-3 people, then I always encourage you to use Azure Key Vault because you can later integrate it into your pipelines. I actually forgot to show you that. Here, when you go to this library, it contains some default, variables for your pipelines, like for example, key vault endpoint, key vault name, LT access name, username. As you can see, before that, I had all of those configured as variable group that I assigned to my pipeline. But now you can use this link secrets from Azure Key Vault as variables. This is really awesome because you can reuse this Key Vault in all of your pipelines instead of going everywhere and linking that and maintaining them in Azure. Again, when you have the Key Vault, it has these access policies. They're much fine-grained. It's really awesome. It's really important, again, to manage these secrets the right way. And always don't forget to hide your secrets inside those logs, BDD logs, those messages, and you have these native capabilities of Lambda test to do so. In the next video, that will be the last module part of this course, we're going to talk about execution environments and scalability, running your tests in parallel, and all of the things that you need to know how to handle that the right way in your framework. Hi guys, greetings from Bulgaria. I'm Anton, and this will be our last module part of the Advanced Test Automation Framework Development course. This time we're going to discuss how to design scalable test automation. But before we begin, please subscribe to the channel, hit the ring bell so that you get notified
when new videos are published on the Lambda Test YouTube channel. Also check the awesome Lambda Test blog because there are many detailed articles that can help you to be a much better test automation engineer. Now, in the links below, you will find reference resources, all the related articles and other helpful YouTube videos, and the link to the GitHub repo. I suggest to clone the repo and work besides me. This is the repo for 𝑨𝒏𝒕𝒐𝒏 test framework, and if you have watched some of the previous modules, you know that I'm not creating separate repos for the modules, but instead I'm creating separate branches. So this time the branch is called Scalability Test Automation. You will find also some jump links to particular topics. Now let's begin. Here are the topics that we're going to cover. First, shortly, I'm going to explain what is a scalable test automation architecture, why we need it. After that, bit by bit, we're going to refactor the framework to support scalable test automation execution, like running tests in parallel. Right now, the framework is not ready. For a reason, I did that because otherwise we had to make it much more complex from the beginning. But I think now it's the moment to refactor and add some C# stuff there to make it thread safe. In some of the parts, we're going to use thread local. In other parts, we're going to use walk statements. And in third parts, we're going to use the lazy. After that, you're going to see a demo how to run some of the tests in parallel using the Lambda Test Cloud. And we're going to discuss 3 different designs of your tests if you want to execute them in parallel. We're going to see copy pasting the same class, which is obviously a bad practice. Then we're going to utilize some base classes. I'm going to explain how you can use our file configuration for creating separate builds. So there are many different variations depending on your context. So it's good to know all of them. And of course, some of the best practices and best practices, not designing your tests so that they depend on each other. The first test, creating data for the second, and verifying the data in the third. Obviously, this won't work if you run all of the tests in parallel. The last piece that maybe deserves a whole module or a course by itself is how to handle global settings in your application, feature flags. Again, this is a big topic, but we are going to discuss just the part that concerns our tests when they execute in parallel, and how we can design to work with those flags, and how we can group our tests so that they don't collide with each other when they need to modify a particular global setting or a feature flag. So let's begin by discussing how to design a scalable test automation. A well-architectured test automation framework is essential for scalability and efficiency. It's not just about automating tests, but ensuring the framework can adapt to the growing complexity of the project, especially when it comes to parallel execution and configuration management. Scalability allows the framework to handle a high volume of tests without bottlenecks, ensuring smooth execution even as the test suite grows. Parallel execution is key to improving the feedback loop, significantly reducing total test execution time. By running tests simultaneously, we can deliver faster feedback to developers. For example, executing tests in parallel can cut down a suite that would take hours to run sequentially into minutes. This optimization requires the framework to efficiently handle test distribution across threads and manage global settings, particularly environments like Lambda tests, where multiple configurations are run concurrently. In the end, parallel execution enables faster releases while ensuring the framework remains scalable and adaptable. Let's see how we can refactor our tests to run in parallel. For the job, again, you need to clone the specific branch that I told you about. In our demo project, demo system test, I created a new namespace called Scalable. You're going to find all of our tests, first we're going to begin with these three. I implemented again tests for this to-do application. Let me really quickly remind you what is this application. Here is the application. It's very popular demo website. It's called To-Do MVC. Here the same to-do application is rewritten on different popular technologies like React, Angular, Vue.js, etc. When you click on a particular technology, the rewritten to-do application is open. And obviously we can add to-do items here by coffee, by milk, by car, and we can check, delete some nodes. We can verify how many of them left. You can filter them, and that's it. Yeah, we can reorder them or check them. That's it. Right now, I want all those tests to be executed on Lambda tests, so I'm going to use the native features of our framework that we built. We're going to run them on from the latest version. On purpose, I have, instead of using test case attributes, I just created multiple of those tests with different items. We're opening technologies and we're verifying a little bit different stuff so that we can simulate a suite with tests, right? Because I want to run them in parallel. I haven't implemented page objects or other more complex design patterns. All of the methods that are using our framework are put here. All of those methods will be run on Chrome. I copied absolutely the same class 2 times, and we're going just to change the Lambda test attribute, and I'm going to mention that I want to execute the same test but on Edge, and then on the latest version of Firefox. Since we have 3 classes, Unit allows you to specify how you want to run tests in parallel using this parallelizable attribute. This attribute can be applied at different levels: assembly level via this keyword assembly 2 dots, on a class level or on a method level. It has different values for this parallel scope, which you can use to control the level of parallelism. We have all, children, fixtures, and self. Children means you're going to run the child tests or individual tests within a fixture in parallel. If you say fixtures, this means that we are going to run the test fixtures or the test classes in parallel with other test classes. You can also control the number of concurrent threads or processes used by any unit through this level of parallelism attribute. This limits the number of threads up to 5. I'm not going to use it. I'm going to use all of my available cores. When running tests in parallel, it's crucial to avoid shared state between tests that can lead to race conditions. There are a few strategies, like in a minute we're going to start refactoring our code to use thread-safe mechanisms like thread local. Because if you think about it, every test fixture will open a session. But if you remember how we structured our framework from before, everything is static, which means that we cannot use the same session for different tests. It will be a complete disaster. One test will navigate to one page, the second one to a different one. They will search for different elements. Obviously, we need each thread or process to have a separate instance of iWebDriver and to hold a separate session to the Lambda test. This is exactly what we are going to do, but first, let me demonstrate how we run the tests in parallel here. Of course, if you run them from the CLI, there are different commands, but right now I'm going to show you how to do that in Visual Studio. You just select the 3 files and then click Run Tests. Let me open the specific builds. You will notice that we have right now 3 tests with the same name. This is for a reason, because in the 3 of them, here we're using Chrome, here we're using Edge, and here we're using Firefox. This is happening because we're running in parallel the fixtures that have absolutely the same tests. Here I already executed all of them. For one of the technologies, we actually have a bug and it's not working properly. But all of the other tests were executed successfully on the latest version of all of those browsers. Also, I added some labels here. Later, I'm going to show you how we can use those tags from latest and others with the specific version so that we can filter by them. Here, I have another one that we are going to see later during the module. Utilizing these settings, you can filter the test results, and here I applied a specific global setting, enable promotions, but we can also set some tags for the browser version. They're running right now. I'm going to stop that. And instead, let's begin talking about how actually discuss what changes I applied so that we can run them in parallel. As I said, by default, if you don't apply this, you will see that this totally doesn't work. The first place that we need to start is our driver factory. I already applied this particular refactoring, and I used the keyword thread local. Before, we had these static properties for holding a reference to the browser configuration, to custom driver options, especially to the wrap driver. Why we need this thread local? Thread local is a class in C# that provides thread local storage of data. In simple terms, it allows each thread to have its own separate instance of a particular object. This ensures that each thread operates on its own data without interference from other threads, which can be crucial in scenarios like parallel test execution or multi-threaded applications where shared state can lead to race conditions or data inconsistencies. So each thread access here the thread local variable get its own independent instance of the variable, meaning the state it's local to the thread, to the process, right? Values stored in this thread local variable by one thread are isolated from values stored by other threads. This eliminates the need for explicit synchronization mechanisms like locks for that variable. We're going to use locks, but in other scenarios. The thread local instance exists for the lifetime of the thread. Once the thread terminates, the associated data is automatically garbage collected. Now, why are we using thread local? Probably some of you know that we have actually a specific attribute here called thread static. Why are we not using thread static attribute? While the thread static attribute also provides thread local storage, it is less flexible than thread local. For instance, thread static does not support initializing the values for each thread, like thread local right here. Furthermore, thread local can be disposed when no longer needed, making it more efficient in resource management, right? Why I haven't wrapped actually all those properties directly in thread local? I did this for a reason, because when you have a thread local, in order to access what's inside this thread safe storage, you need to call this value property. And if I have implemented this type of refactoring directly on the properties, this was going to force me everywhere inside my code to go there and update the properties. This would lead to many compilation errors. This is why I left my properties, but inside my properties, I use these thread local static variables that are, again, thread specific. And from now on, when you use the driver factory, this means every test fixture parallel process will hold a separate instance to the driver factory. I implemented the same thing for mobile. The second change should be inside our base classes, these two here. Why? If we check, we have, if you remember, when we talk about troubleshooting, we added this exception. There isn't a mechanism inside a unit or MS test inside this test context, it doesn't know what was the error of the test. So we need to run this static exception that we are catching from the app domain, first chance exception. Otherwise, it will lead to very strange behavior in the framework. Where we use these exceptions? Inside our web project, we built this Lambda test results plugin. This is one of the places. If you open this Lambda test results plugin, for those of you that watch the video about troubleshooting, you remember that we have this Lambda test hook for sending the exception so that you have access to the whole stack trace, the actual exception message. If this exception, because it's static, if we don't make it thread local, this means that it's possible to see an exception from another test, which will be really bad. It will really complicate the troubleshooting. So this is one of the places where we need to update that. Now, in MS Test, because the class initialization, the class init method is static, because of that, we have a little bit more complex logic for holding all of the initialized test classes. And because many features can access that at the same time, I'm using another mechanism called lock. This synchronized access to ensure that the test classes are initialized only once in a thread-safe manner. We're going to use lock in a few other places where it's not a thread specific, but this path will be accessed from multiple parallel processes. In our web tests, if you remember, when we were talking about test data, we're using quite extensively web APIs. In order to access our web APIs, inside our pages, we have this app. When we go to core, we have web test. Inside web test, this is the base class for all of the web test classes. We have access not only to the web app, but also to the app of the API. Here, for a reason, I wrap the API client in a thread local. While our REST client from the REST sharp is generally thread safe, if you are managing multiple requests in parallel using the same instance, you need to make sure you handle headers and other options carefully. You might want to create a new REST request for each request execution to avoid any shared state issues. If you watch the configuration module, you know that we have two mechanisms for working with configurations depending on your context. You can rely on the options design pattern and use static options classes, or in some more complex scenarios, we can directly use these JSON files. We are not working directly with JSON or parsing this text. Instead, we have a configuration service that is deserializing that into C# model classes. In order to work with it in parallel, I implemented a few changes as well. This was my previous code, private static read-only I configuration root. Everything that is static and you're not changing it, probably you need to be careful about it. Particular refactoring will be needed if you want to execute your test in parallel. In order to understand what is lazy, we need first to discuss what is a deadlock. A deadlock is a situation where two or more threads are blocked forever, waiting for each other to release a resource they need to proceed. In simple terms, it's like a circular waiting scenario where each thread holds a resource that another thread needs and is waiting for a resource that other threads holds, resulting in a permanent standstill. Lazy provides built-in locking mechanisms to ensure that the initialization happens only once, even in multi-threaded environments. This is used for lazy loading. If you remember, we implemented lazy loading when we were discussing the adapter design pattern. Lazy is very good option because of this built-in mechanism, but also the configuration initialization will only happen when it's accessed for the first time and potentially improving the performance if the configuration is not always needed. The other code stays absolutely the same. We wrapped our iConfiguration root that comes from Microsoft Extension Configuration. Similarly to the thread local, this lazy gives you initialization inside the constructor using Lambda expression. We need to make sure to set this isThreadSafe property to true in order to start this built-in locking mechanism. Another part, so that we don't mess up everything, is our plugin execution engine that we use in our observer design pattern, part of the plugin architecture. Before, we were holding all of our plugins inside a hash set. In order to prevent dead walks, maybe you can use walk, or maybe it's safe just to wrap the hash set inside thread local. This is important so that multiple plugins are not executed multiple times. If you watched the previous modules about security best practices, you remember that we introduced something called Key Vault for keeping secrets inside the cloud. This Key Vault, Azure Key Vault, is using this secret client. Right now, I'm using this static read-only lock object again. This ensures that only one thread can execute the critical section of the call protected by the lock statement. This will prevent any race conditions and deadlocks. For settings or for specific browser versions, because imagine that inside our tests, I showed you like 3 classes, but this is only if we want to run the test on the latest version of the browsers. However, imagine that if we need to support at least 3 versions, 2 versions behind the latest. There are so many files, right? Obviously, this is not a good practice to copy paste all of the tests and all of the logic, right? This is why another strategy here, if you're not going to utilize the configurations that I'm going to mention in a minute, is to create such a base class where you move all of the tests, you remove the test fixture, you mark the test class as abstract so that you're not able to run all of those tests inside the test explorer. I copied all the tests here, all the utility methods, nothing more. And that in all of those classes, they're just empty classes deriving from this base class. The only difference lies inside the Lambda test attribute that my plugins are using. We change here the version of the browser, and later we're going to discuss if you have separate builds for that. I apply different categories. In this way, we can execute all of those tests in multiple threads. Let's run them. This will execute all the tests inside Lambda test multiple times. I already did that here, but I'm going to show you that this is happening. All right, we are waiting. Let's see. Yeah, they start executing. Here is the new build. We have 9 parallel tests from the different fixtures. We have those labels 𝑨126. We have Firefox 128. We have Chrome latest, etc. Later, when you click on tags, you can see all of those tags and you can filter by them. We can see all tests that were executed on from 127. This is very helpful so that you can filter later particular problems that are happening. This is one of the ways how we can execute those tests on different configurations. This is particularly useful if you want inside your runs on every execution of your continuous integration to run all of those tests. However, sometimes this is not needed. Maybe you can create separate Azure DevOps builds. We can create copies of this particular build and create many of those configurations for the different browsers. Many times we call these tests compatibility tests. They are not needed to be executed every day. Many often we execute them once per week or even once per release just to check that everything is fine. Most of the time, executing on the latest version is completely okay. To be able to have this shorter feedback loop, we are not executing them against all the different variations of the browsers. We are not executing all the tests, but just the smoke test suite. We do the same in some of the enterprise projects that I'm part of. We have such compatibility tests for specific instances of the application built for specific clients where they have different configurations and settings, etc. But again, we're not running them continuously. And we want just to execute these particular builds a few times. We're creating separate dashboards inside the report portal for that. It will depend on your context. But another very efficient way of doing so without creating such additional classes is to create different instances of these test framework settings. And inside the different files, you're going to change here the browser version, browser itself, maybe the different resolution again, to depend on the context of your application. If we check our test results, you will notice that our walk is complete mess. This is happening because Logger is actually static. Right now, when 9 parallel tests are running, they're printing on the console at the same time. This means that you see one line from test 1, then from test 3, then from test 6. It doesn't matter, but this log, when you see the PDD logging, when you check the raw logs inside Jenkins or Azure DevOps or GitHub Actions, they will be a total mess. They're completely useless. We need to refactor the logger so that we see a particular logs only for a specific test, the complete log, in the right order, instead of having this messed up logging. This particular refactoring will be a little bit more challenging. If you remember, we put our logger inside a specific namespace inside Polaris Wide core. We're using the logger quite extensively in order to support this BDD logging. Years ago, I thought that this is not very useful feature. However, many of our clients actually found it very useful and they use it for troubleshooting. They use it for finding out what the test is doing. If we take a closer look, you will notice that in a minute I'm going to show you the thread safe logger. This is the not thread safe version. It's static utility class. This is the not thread safe. It's static read only. This is why it's printing at the moment when you ask the logger directly on the console or inside the file. The thing that I want to do is not print immediately, but collect all of the logs inside a particular collection that it's thread safe, and then print it one by one, all of the logs. This is exactly what I implemented in my thread safe logger. I have 2 thread local storages. One of them obviously is holding the logger. And inside this thread local storage, I have a dictionary of string and the value is a list of strings. The key will be the current executed test, but its full name, the namespace, the test class, and the test itself, which is unique. Then inside the list will hold all of its related logs. In the end of the test, during the test cleanup phase, we're going to print all the messages one by one. We're going to wrap it, as you see in a log statement, so that we are sure that we're going to print them in the right order. This is our S log buffer. S comes from that because it's static. Also, I added one more property called current test full name that we are initializing inside our log plugin. We have inside the log info methods, I'm using this accumulate log method. This accumulate log, first, we're checking. We need to use this value everywhere because it's thread local storage. This is actually accessing directly our dictionary. We're checking, do we have a key for our current test full name? If not, we're adding the key, the current test full name, and we are initializing a new list of string, an empty list. Then we're getting the current thread or current process ID so that we can add it to the log. Also, we're printing the datetime now the log level and the message using string interpolation. We are adding them to the specific list of logs for this test. The log level is this info error warning because later we can control that via settings. I added again here an object called push log because I'm using this log statement so that only one parallel process at a time can print all of the logs. This will ensure that the logs are following the exact order, iterating through the list of the logs for this particular test, getting it from the dictionary. We're iterating it, we're printing it on the console, on the file, everywhere that we configured, and we are cleaning the logs. That's it. This is this push logs, which is a new method. Since I don't want every time manually to call the logger to push all of the logs, I created using our plugin architecture, I created logger push plugin, which is very simple. It's deriving from our plugin. We're implementing on before test cleanup. We're calling logger.push logs, which during the test cleanup phase will just print all the messages. The only thing that you need to do is to replace this implementation with the thread safe logger. One more thing, in order to implement the tags, you need the tags that I showed you in Lambda test. They're not available in the Lambda test automation capabilities generator. You need to navigate through the Lambda test documentation. Under the how-to guides, you'll find an article called Group Test Using Custom Tags. We need to create an array or a list with the tags as strings. After that, we need to call this capability, set capability tags, custom tags. In order to support that, inside our driver factory, I added one new hash set. Why hash set? Because I don't want multiple tags to be repeated, like from latest, etc. Hash set is just holding unique values. Later, during the starting the grid, when we initialize all of the grid options, we are adding all of the tags. For the particular browser and the browser version, I added in here driver factory tags at browser description, browser version. What is this get description? This is enumeration. I used this custom implementation that we built before. I added this description attribute and using a reflection. This extension method get description is reading just the text here. When I use my num.getDescription, I'm reading this string. We're adding the browser string and then the browser version string. If we have any other tags, later when we execute that, for example, for the settings and the feature flags, we are going to add them here as well. We need one more thing actually to change in order all of those logger stuff to work. If you remember how we created those event handlers for the BDD login, we introduced new event and delegates for all of the components of those events. They're static. By default, if you subscribe multiple times this event, you will see multiple logs. This is why we need to apply this refactoring. You cannot directly implement thread local to the event. We need this private static read-only variable wrapping the event handler itself. The thread local ensures that each thread hits its own independent copy of the event handler. This means that multiple threads will not share the same clicked event handler instance, avoiding race conditions. When a handler is added via the clicked event, the code first checks if the clicked has been created for the current thread by checking is this value created. And if it hasn't been created for the current thread, the handler is assigned to the clicked value. And the same we're doing when we're unsubscribing for the event handler. You need to apply this. I added this for the button, for the anchor, and for the text field, as well as for our validate methods. But we need to apply that for all of the components and make them thread safe. Let's move to the next subject. In the context of automated testing, making one test dependent on another is considered a bad practice. It's especially problematic when tests are executed in parallel, as the execution order is not guaranteed. Test 1 depends on the execution of the outcome of test 2, or vice versa. This is problematic because if the first test fails or it's skipped, the second test will also fail due to missing preconditions. For example, test 1 is registering a user. Test 2 relies on the first to log into the system. Then test 3 is making a purchase for the same user. And the fourth test is verifying the order inside the user's account profile. When tests run in parallel, there is no guarantee of the execution order. This means test 2 might run before test 1, resulting in a failure because the items it expects do not exist yet. So, test suites become fragile and harder to maintain if the structure or sequence of the test changes. Tests that depend on others may break, leading to false negatives. I encourage you always to make tests independent and, whenever possible, each test to be able to run in isolation, creating its own test data. We discussed that multiple times during the design pattern series and also here when we were talking about APIs. For example, this test users factory, we use it to create separate users. I created one short example for that. It's part of the scalability namespace. You can find it right here. To do tests with order, I use the order attribute part of NUnit. This order will force NUnit to run them in this particular order. However, this is not guaranteed if you run them in parallel. For example, this first test is adding to the items. Then the second one is verifying those items. Many often, when particular items are really persisted inside the database, many people were using this approach. But again, it became a disaster when you tried to run them in parallel. And not only in parallel, but as I explained, if the first test fails, then all others are failing as well, leading to many fragile tests. Another way of how people are solving this problem or thinking that they're solving it is that they're using, if you select multiple tests, if you open the context menu, you will find that there is an option for adding them to a playlist. This is a special mechanism in .NET for creating test suites. We can create a new playlist or a test suite. This is a manual process. While you can control the order inside the playlist, there is no automatic way to specify the order here in the UI when creating the playlist. Even if you reorder them, because this is possible. If you open here, I have one such a playlist, I saved it here. So this playlist file is in an XML format, which means that you can control the order of the execution inside these playlist files by manually editing the .playlist file and reordering the tests in the XML. However, this is not a recommended practice because if the tests are set to run in parallel with this parallelizable attribute, the playlist order might not be enforced because the tests could be run concurrently on different threads. Even though controlling the order in a playlist is possible, try to avoid making tests dependent on the execution order. Self-contained tests that do not rely on prior state are more robust. Now we are going to discuss settings. I prepared one sample table holding settings. Global settings are configurations that apply across the entire web application and affect its behavior for all user or instances. These settings often control core functionalities such as UI preferences, for example, dark mode, default language, specific features or behavior. Security settings, enabling, disabling two-factor authentication. Regional settings, currency, country-specific features for compliance with regulations, formatting settings, and much more. So when dealing with a large system that has, for example, 1,000 global settings, controlling various behaviors and running 10,000 tests across 10 parallel builds or processes, there is a high risk of test failures due to settings conflicts. This happens because one test may update a global setting that another test running in a different process relies on. Without carefully managing and analyzing these dependencies, settings can be overwritten, leading to unpredictable failures and unreliable results. To avoid this, you need to analyze the dependencies between settings and tests and create settings dependencies trees or such tables. These tree will show how different tests depend on a specific settings, helping you group tests in a way that minimizes conflicts. Based on this analysis, you can decide which tests can safely run in parallel without causing failures due to shared global settings. It's really helpful to have such documentation about all the settings, some of the default values, and possible values for the settings. Here is the other relationship, the table that help us to analyze all of those dependencies. First, we have the name of the setting, the global setting that controls some aspects of the system. Then we have the test group that depend on or modify this setting. The dependency type describes the nature of the dependency, whether it's visual, functional, security, etc. In the next column, called conflict potential, we put how likely it is for this setting to cause issues in parallel execution, high, medium, and low. And then we have another one for for parallel execution, indicating whether tests relying on this setting can be run in parallel with others. Of course, we can overcomplicate this. I suggest to have separate groups of tests that do not rely and this is exactly what we're doing in many enterprise projects that have so many settings. Believe me, if you're watching full course and if you need such a framework, probably you will hit this problem. This is why I'm mentioning it in exactly this particular module. Safe parallel execution, some settings like max items per page or items in cart limit can be safely used across different tests in parallel without causing conflicts, as long as the tests do not modify the setting during execution. By analyzing setting dependencies, you can group the tests with non-conflict settings to run in parallel. For instance, UI visual tests can be grouped separately from functional or security tests. To demonstrate how to handle application settings in web tests, especially when running in parallel, we'll build a mock setting service with these 10 different settings to show how to safely manage these settings within your tests. We'll integrate these settings with Lambda tests for scalability. You can later integrate that with Allure and the report portal. You can use their tagging options as well. You will find that I have here a namespace called app settings. This is where I implemented that. I'm calling this mock setting service. Most probably inside your setting service, you're going to use a web API to update those settings. I encourage you every time when your test is relying on a particular setting to update it to the setting that you're expecting. My mocking service, at least the first version, in a minute I'm going to show you a second version that it's thread safe and it's event driven in order to allow supporting BDD logging. But for now, let's keep it simple. I have enumeration with all of those settings from the table that I showed you. Then we have the mock setting service holding the current settings and the default settings values. We are initializing them in the constructor. Then you have methods for getting the setting, restoring to the default, and getting all. I have one test here, test class. In a minute, I'm going to explain these attributes. I used the plugin architecture. I have created this plugin. But for now, let's see the version without plugins. So I am initializing the mock setting service. Maybe we need to refactor that. In all of the tests, we are first setting the settings that we need, enabling the dark mode, how many items maximum we can have per page. And after that, we're getting a particular setting and we can verify something. In the end of all of the tests during test cleanup, we're restoring them to their default values. Of course, I don't want every time to repeat this code for restoring or setting something. I think it's very beneficial to create such attributes. When I have the attributes, we can build a plugin using the observers design pattern, so we can set those settings before the test execution and then restore the default during the test cleanup phase. So I created this things attribute inside this plugin namespace. We have properties to the settings enumeration, its value, its object, because it can be a boolean, it can be a string, it can be an int. I have one more property for whether we want to set tags in Lambda test or not. Later, you can utilize the flag for other tools. Right now, I made my attribute to be sent on top of only classes, not tests, but you can change that. I said that we can apply multiple of those attributes because we can have multiple settings that needs to be changed. And inside my plugin, I have two methods: on before test initialize and on after test cleanup. We have a special method called getSettingsAttribute. The return time of this method is list of tuple. A tuple is a lightweight data structure that can hold a fixed number of elements, each of which can be of a different types. In C#, tuples are useful for returning multiple values from a method without needing to create a separate class or a structure to hold them. Because here I'm getting multiple attributes this time, not a single attribute. The select method, which is part of link, we use it to project each settings attribute into tuple containing its setting and value. When we have the list of these tuples, we're initializing the mock setting service, and I'm just for each of the settings. I'm calling settings, set setting, and maybe I forgot here to branch that, because if you remember inside the attribute, I have this set tag. Every time I adding the tags with this settings, item 1, item 2, this is how we work with tuples, because you can have more than 2. We're adding those tags for the settings. As you can guess, inside the after test cleanup, we're doing the same, but this time we are restoring to the default. This is how our plugin with the setting works. Let's discuss quickly what a feature flag is. Then we're going to wrap up this module and a course. So the feature flags, also called feature toggles, allow you to turn features on and off without redeploying the application. This is especially useful when running tests with different configurations for user segments, devices, and geolocations. They help you test features in isolation, control rollouts, and run API tests without disrupting other functionalities. There is a difference between feature flags and remote configuration and global settings. The feature flags control whether a specific feature is available, dark mode, toggle, beta feature access, and they usually have binary state on and off, true or false. While the remote configuration, they adjust operational settings, for example, the currency type, the API endpoint, that aren't directly tied to feature availability. Feature flags are ideal for managing toggles across different environments, test suites, while configuration defines how those environments behaves. Please note, we will focus on how feature flags concern our tests running in parallel. We won't discuss whether you need to use similar flags in the automated tests. Usually, these feature toggles, they need to be short-lived. The discussion about feature toggles deserves a whole video. We'll just focus on this particular part only. So, when to use feature flags before showing you the actual demo code. Introducing a new feature to a small percentage of user and gradually ramping up as confidence grows. I'm going to show you some Lambda test features that can help you test that. Compare different versions of features across segments to measure performance and behavior. Control features exposure to specific groups, beta testers, to gather feedback before wider release. Flags let you merge incomplete features into the code base and deploy it with feature turned off until ready. A small number of feature flags can generate a large number of possible test combinations. For example, 3 flags, 8 combinations, 10 flags, over 1,000 combinations. And managing these combinations increases complexity, so I suggest you to create similar tables like we did for the settings. You need to account for both enabled and disabled states, which requires a solid test matrix for different user segments and geographies. I prepared one OWASP demo for that. We have another namespace called feature flags. We have a feature flag service similar to the one for settings. I made this already thread safe. All those dictionaries with the default and the current state are wrapped. They're thread local. You can use even thread safe dictionaries if you want. But also we have some event handlers in order to support BDD logging. We have BDD logging feature flags handlers. As I explained, I built such a event-enabled mock setting service for the setting service as well. There's some events here, settings retrieve, updated, restore, and we have some implementations for the BDD logging as well. An enumeration with the feature flags, types, some event handlers for the BDD logging and others. Very simple methods, a static method for getting the feature flag, setting the feature flag, and restoring to the default. That's it. And static methods to raise the events. And I have created a similar plugin. We have attribute similar to the settings, but this time we hold a property to the feature flag, whether it's enabled and whether we need to set tags inside the Lambda test. And inside the plugin, we are doing absolutely the same. We are just for eaching, but this time I made our feature flag service static. It's a utility class. We are getting the attributes and we are for eaching them and calling our service and restoring them. The interesting part is that you will see that I'm not using only my feature flag attributes, but the so-called user fragments. It means that you can use the feature flags to turn on a specific feature only for particular devices, for browser version, or for your geolocation. Let's say India or Finland, you can test the feature only there. In order to verify that, Lambda test can help this geolocation. We are using it later in other plugins that are combining the Lambda test. We are going to execute all those tests in this particular place, which is really awesome. We can change the time zone, we can change the locale. Again, it depends how your feature flag is working. Many companies, they use these feature flags just to roll out a particular feature to a set of devices, for example, Samsung devices or iPhone devices or particular version of Android. You can use Lambda test to test these feature flags and user segments and check. You need to check definitely when the feature flag is on and off. You can check the code. It's absolutely the same code like the settings, but I just use the utility feature flag service. If you use the plugin, you don't need to use the utility class manually. We covered a lot of stuff. First, we discussed this scalable test automation architecture, why you need it. Then we refactored a big chunk of our framework to support parallel test execution. We reviewed some of the features of the C# that can help to make our code thread safe, discussing the thread local, the walk mechanism, lazy, and others. We made our logger work much better when we run our tests in parallel. We reviewed a few strategies of how you can run your tests in parallel using any unit parallelizable attribute, and how you can use base classes or use separate builds using our configuration management using files. After that, we discuss some bad practices, why it's not good to using order attribute and your tests to be dependent on each other. Last but not least, we covered what are the global settings and feature toggles and how to handle them properly when you run your tests in parallel.
Hi guys, greetings from Bulgaria. I'm Anton, and in this module we are going to cover accessibility, functional and automated testing. But before we begin, please subscribe to the channel, hit the ring bell so that you get notified when new videos are published to the channel. Also check the awesome Lambda test blog because there are many advanced test automation articles that can help you to be a much better test automation engineer. In the links below you will find reference resources, the link to the GitHub repo, and also jump links to particular sections. Here is what we are going to cover. First, we're going to discuss what is accessibility. Then we're going to explore Axe, which is a set of tools that help automating accessibility testing. After that, we're going to cover Lambda Test Accessibility DevTools plugin. By the way, this is the abbreviation here for accessibility, A11Y. Then we're going to discuss some why you need to care about screen readers, some of the best of them on the market, and we're going to see how this is tightly integrated into the Lambda test platform and how you can easily do this type of testing. Then we're going to cover Google White House. If you remember some and watch some of the other modules, mainly when we talk about Google White House, we use it for performance measurement. However, it's much more than that. It also contains some accessibility checks, and because of its tight integration into the Lambda test, we can utilize that and see some numbers and use it for this purpose. However, as we're going to discuss, I would recommend to use Lambda test accessibility automation because it's much tighter integrated into the platform, and you can reuse your existing automated test to do some very detailed accessibility automated tests without doing something special. So let's begin. A lot of things to cover. First, what is accessibility? In simple terms, it's ensuring that our website and applications are usable for all individuals, including those with disabilities. This involves considering the need of people with various impairments, whether visual, auditory, motor, or cognitive. The idea is to remove barriers that may prevent these users from fully engaging with digital content. Accessibility goes beyond just making a website look good, it's about creating an experience that works for everyone. By designing with accessibility in mind from the start, we not only avoid costly redesigns but also create more inclusive web for significant audience. For context, approximately 27% of adults in the US alone have some forms of disability according to CDC, and this percentage is expected to increase as population age. So, by adhering to accessibility standards and guidelines, we ensure that our websites work seamlessly with assistive tools like screen readers and keyboard navigation, helping users interact, navigate, and contribute to content. Accessibility, therefore, becomes a critical aspect of creating digital experiences that are inclusive and legally compliant, as we will discuss later, while also meeting the needs of a broader audience. Now, let's discuss the Web Content Accessibility Guidelines, or WCAG. These are global standards for making web content accessible, created by the W3C Web Accessibility Initiative, WAI. WCAG is based on 4 essential principles. Perceivable. Content must be presented in ways that users can perceive through their senses. For example, visual content should have descriptions for screen reader users, and auditory content should have transcripts for those with hearing impairments. It should be operable. All functions must be accessible to users with different input methods, like keyboards or voice commands, rather than relying solely on a mouse. Understandable. Content should be easy to read and predictable. We want users to understand the structure, the language, and layout, ensuring they aren't disoriented as they navigate. And it should be robust. Content should be adaptable to various assistive technologies, making it future-proof and compatible across different platforms. These principles are then divided into 3 conformance levels: Level A. This is the basic level, addressing the most fundamental accessibility barriers. Failing to meet this level typically means a website is unusable for many. Then you have AA. Most websites aim for this level as it addresses broader range of issues that commonly affect users with disabilities. Then we have AAA. This is the highest standard and is often achieved in specialized cases through it isn't a requirement for every website. With the release of 𝑨𝒏𝒕𝒐𝒏 2.1, the guidelines expanded to include accessibility for mobile devices, people with cognitive disabilities, and users with low vision. So 𝑨𝒏𝒕𝒐𝒏 is continuously evolving to meet modern accessibility needs, ensuring we build truly inclusive digital spaces. Now, let's talk about the laws and regulations that make accessibility a necessity. Accessibility isn't just best practice, it's legal requirement in many countries. So, the Web Content Accessibility Guideline. This isn't just a guideline, it forms the basis for many laws worldwide, setting the accessibility standard for digital content. Then we have European Union Web Accessibility Directive. This directive requires that all public sectors, websites, and mobile apps meet 𝑨𝒏𝒕𝒐𝒏 2.1 level EE standards. In Europe, compliance is mandatory for government and public sector sites. Then we have Americans with Disabilities Act, ADA. In the United States, the ADA requires public-facing websites to be accessible to all users, including those with disabilities. It's the basis for many lawsuits where organizations didn't provide adequate accessibility. And then we have the 21st Century Communication and Video Accessibility Act. This US law covers accessibility for digital communication services, ensuring features like SMS, email, and video calling are usable for individuals with disabilities. And why this matters? Besides avoiding legal risks, accessible websites promote inclusivity and boost brand reputation. Accessibility makes websites easier to navigate for everyone, increases engagement, and can even improve SEO by making content more structured and understandable for search engines. So complying with these standards and laws supports not only the user experience but also the business. To support accessibility, the W3C Web Accessibility Initiative, WAI, has provided a set of design patterns. These are practical solutions for building accessible interactive elements like buttons, modals, and navigation menus. And these patterns ensure that elements are operable by users relying on assistive technologies like screen readers and keyboard navigation. One key tool here is ARIA, or Accessible Rich Internet Applications. ARIA adds extra attributes to HTML elements, letting screen readers interpret interactive components correctly. So let's look a few common WAI patterns. Here I open the website. For example, this is the accordion, the area expanded attribute. Here you can see an example. So here we have this attribute area expanded to true. This area expanded attribute lets screen readers announce whether a section is open or closed, helping users understand and navigate collapsible content. Now, if we go just to the patterns right here into the whole navigation, we can go to the home, then design patterns, and here, for example, we can open the button, right? So inside the button, there is a very detailed explanation about the pattern, and we can see some examples. Again, here we have the attributes rights. By adding ARIA rows like row button, we make sure that the screen readers recognize buttons correctly, allowing users to know if a button is pressed or unpressed. We have tab indexes and many more, right? And then we can check, for example, models, right? So for models, area model true helps focus the screen reader within the dialog, so the user isn't distracted by the background content. These WAI patterns are crucial for testing, as we can verify that each component functions as expected, ensuring proper ARIA row validations, keyboard accessibility, screen reader compatibility, and focus management. They essentially provide a roadmap for making dynamic content accessible. To wrap up, let's go over some key accessibility checks that help ensure compliance with WCAG. So, first, make sure every image has alternative text that conveys its meaning. This helps screen readers describe images to users with visual impairments. Then we have the color contrasts. Maintain a contrast ratio of at least 4.5 to 1 between text and background to ensure readability, especially for users with low vision. Keyboard accessibility, this is very important. Ensure users can navigate the entire website using just the keyboard, making all interactive elements accessible without a mouse. Inaccessible forms. As users navigate the website, they encounter various form fields. However, numerous online forms lack proper or empty form labels, hindering screen readers from conveying crucial control information. This challenges visually impaired users depending on assistive technologies to navigate and complete forms. Enhance user-friendliness and accessibility of all input fields or contact forms on your website by ensuring they contain explicit labels. You can use the label element in each field code, as it will enable screen readers to accurately convey required field information to users. Focus management. Make sure that the user can see whether their keyboard focus is, especially on interactive elements, so they don't lose track of where they are on the page. For videos, provide captions and transcripts to ensure content is accessible to users who are deaf or hard of hearing. Avoid generic links like click here. Instead, use meaningful descriptions like learn about accessibility guidelines, which improves both usability and SEO. Another web accessibility issue is the improper use of headings in the content of web applications. Users with disabilities are less likely to read the entire web page. They mainly depend on assistive technologies to navigate the content. Such users depend on headings to move around the website. It is suggested that informative content be included in headings that describe the subsequent content. Ensure that the headings hierarchy is logical from H1 to H6 to facilitate easy navigation for users. These checks help us catch common accessibility issues, and as we proceed, we'll use these principles to analyze and address specific accessibility warnings in our testing tools, like those offered by Lambda Test. By focusing on these areas, we can create more accessible, inclusive, and user-friendly digital experience. Keep in mind that I haven't discussed all of the different checks and verifications. There are many more, and there are many articles from the Lambda Test blog, as I mentioned. that covers all of those topics in much more details. So check the reference resources. Now, let's explore Axe. I will directly open the GitHub repo here. This is the Axe core project. So what's Axe? Axe is widely used open source accessibility testing toolkit by 𝒏𝒕𝒐𝒏 systems. It's built specifically to help developers identify and resolve accessibility issues on their website or applications. You might already know Axe as a browser extension, but it also has a command line interface. Here is the command line interface. To use it, you need Node.js. This command line allows us to run accessibility tests directly from the command line. This is COI is powerful for automated testing setups because we can schedule tests as part of our CI/CD pipelines without manual intervention. With a simple command, Axe scans a page and outputs results that are actionable and 𝑨𝒏𝒕𝒐𝒗 compliant. By the way, Lambda Test Accessibility product is powered by the Axe core by 𝒏𝒕𝒐𝒏. And here you can see some commands, right? You just need, again, to install the Node.js. You can just provide some websites. You can also mention particular rules, or whether you want to scan for 𝑨𝒏𝒕𝒐𝒗 1A, 2A, 3A, right? And you can disable some rules. And you can output into different folders. While Axe CLI is excellent for command line integrations, today I will focus on how Axe works within a test automation setup, particularly with Selenium and C#. And here you will find also this link in the reference links in the description below. I'm going to discuss this 𝒏𝒕𝒐𝒏 Axe core Selenium. It's a NuGet package, right? So the Axe project GitHub has packages tailored for different environments, including Selenium WebDriver, allowing us to automate accessibility testing in end-to-end tests. The Axe Selenium C# library brings accessibility testing right into the WebDriver session, so it runs alongside other UI or functional tests. This means we can validate accessibility as part of our UI test flows, catching issues that might go unnoticed in purely visual checks. Again, there are a few GitHub pages that I'm going to provide. As you can see, they have Axe core for Playwright, for Selenium. They have this common project. I think this is the essential link that you need because it's like a full-blown documentation. We need to install this package, 𝒏𝒕𝒐𝒏 Axe Selenium. In a minute, I'm going to show you my project with C#. I already created that, and I use there the Lambda Test e-commerce website that we have automated in many other modules. As you can see, they provide this Axe builder. So we create an Axe builder instance, and then we need to call analyze. The analyze method scans the page and capture accessibility violations based on the 𝑨𝒏𝒕𝒐𝒗 standards. The results include details on each violation, making it easy to locate and fix issues. And this approach allows us to keep accessibility checks embedded within our broader test flow. So let's see it in action. As I said, I prepared a solution. We have different demos for the various topics that we are going to cover. Right now, you need to open this product purchase Axe tests. Again, this is a standard NUnit project. We have a few NuGet packages already installed. Here are the installed packages. So the most important package that you need is this dequeax core Selenium. And also they suggest to use fluent assertions. I'm not a huge fan of the fluent assertions. You can use whatever assertion library you want, but if you read their documentation, they suggest to use fluent assertions. Besides that, I'm using standard Selenium NUnit setup. After that, we have an NUnit test class. We have the WebDriver. I also used some page objects. Again, this is out of the scope for covering them, but I just didn't want to use just random Selenium commands, but at least follow some structure. Again, we're automating this e-commerce playground website, like an online shopping center demo website by Lambda test. Let me quickly show you for those of you who don't know. Yeah, here it is. It's basically, we can search for products, we can buy them. Again, right now it's out of the scope to check the actual flow of the test. This is not important. The whole thing is that I'm initializing the driver here. Right now I'm going to run this locally, and later I'm going to show you how you can use not use Axe, but since the Lambda test products are tightly integrated with it, we don't need to install NuGet packages or the builder. I think the builder is nice, and this is why I'm going to show you in order to, for example, if you have some issues that were noticed during the automated testing, this is nice for debugging purposes and drill down much more details. So I have my page objects and model classes here. I'm completing my test, right? We call Axe Builder. Again, there are particular syntaxes like with the CLI. We can mention just to run the builder with particular rules. Maybe it's suggested to move them to a constant classes. Again, we can run with tags 𝑨𝒏𝒕𝒐𝒏 1a, 2a, 3a, etc. We can disable rules, and then the most important method is analyze. Then in this violations collection, we have containing all of the issues with explanations, etc. Also, if you check their documentation, we can, when we run this analysis on a web page, we can run it just on a particular section, for example, on a table or in a bigger div. With this include, you need to use CSS for that. Also, you can exclude some elements. For example, imagine that you have advertisement that it's not coming from you, Google AdSense or something else, and you can exclude these elements. This can get out of hand quite fast. For example, if you check their documentation here, you can see some rules. I think this is really hard to read. However, it's nice. Like, there are some configurations instructing it to check also iframes. You can also check some shadow DOM elements from shadow selectors. Again, this is out of the scope now. It's just good to have an idea that this exists. I have actually one more thing. You're going to ask why we are not just writing our own checks instead of using Axe or using Lambda test, right? In order to show you, I already created such tests, implementing some of the rules. For example, here we're using native WebDriver for checking for that there are no duplicate IDs. We're checking for color contrast issues. In order to do that, we need to do these expressions with regular expressions, these calculations for checking the colors. We need to calculate the contrast ratio with these mathematical expressions, right? Then we can verify the heading order or to check the form labels. We can check for touch target size or for keyboard operability. We can check for tab order using the index attribute, right? And use tab. We can check for keyboard navigation, for links having names and area labels. We can check, this is very simple, to check that all of the images and links have alt attribute and that it's set. As you can imagine, these are just some of the checks, right? So now, why should we avoid relying solely on WebDriver without tools like Axe for accessibility checks? Manually coded checks can't effectively detect all accessibility issues. For example, we can write tests to check for duplicate IDs or contrast ratio. While these basic checks may detect some issues, they don't cover the full spectrum of 𝑨𝒏𝒕𝒐𝒗 requirements like ARIA, role validations, or focus management. Tools like Axe automate these complex checks, making them more thorough and reliable. Additionally, Axe provides meaningful explanations and solutions, reducing the manual efforts and expertise needed to identify and fix accessibility problems. And as you can imagine, since they're all of those tools, you don't need to reinvent the wheel and write your own library. It doesn't make sense, right? Again, I will show you a little bit later how much easier is to use the Lambda test integrations and dashboard with the Lambda test accessibility automation. It's really great because you don't need to do that. You don't need to call Axe. Everything is built in. And you have this historical dashboard, you can filter, you can check for the solutions and everything. I think maybe this is the thing that I would always prefer. Right now, let's discuss something else. Let's talk about Lambda test accessibility DevTools plugin. So, to address the web accessibility issues and ensure the quality of software applications, the most effective approach is to perform web accessibility testing. I think until now, you should understand that. So, Web Accessibility DevTools is a browser extension designed to help developers and testers identify and resolve accessibility issues within web applications. It simplifies the process of ensuring your website is usable by everyone regardless of their abilities. I always say that you don't need to rely always just on your automated tests. You need first to do this type of functional tests and work all of the issues, right? This is the first step, and I think this plugin is excellent helper for that. So what are the key features? The DevTools can scan the entire web pages, the full page scan, specific website elements, the partial page scan, or even multiple pages simultaneously, multi-page scan, to identify accessibility violations. The scanning process is powered by Axe Core and helps ensure your website adheres to accessibility standards like 𝑨𝒏𝒕𝒐𝒗. After a scan, the DevTools generate a comprehensive report that details all identified accessibility issues. This report includes the severity level, critical, serious, or minor, of each issue, along with a clear explanation as suggested remediation steps. By identifying and fixing accessibility issues, you create a website that is usable for everyone, including users with disabilities. Using this DevTools plugin helps mitigate potential legal risk associated with non-compliance. And again, accessibility websites, they tend to rank higher in search engine results pages as search engines consider accessibility a factor. So how to use it? First, you need to go to this accessibility tab and download the plugin. You need to click Add to Chrome, and then you need to log into your Lambda test account. After that, you can pick one of the 4 methods for scanning. And of course, you need to open here the DevTools and click on the Accessibility DevTools tab. Then, again, you can click on the full page scan button to start the scanning for accessibility issues for this particular page. This will list down all of the issues after the scanning your complete web page. You can click on those issues to check with which particular element it's causing the issue. And now it's time for demo. Let me show you. This is right here from the accessibility tab right here. I can access my manual reports from the plugin and automation reports that we will cover a little bit later. If I open the Lambda test website, and if I open my DevTools, here you will find Accessibility DevTools. I already installed the plugin. And when I click here, again, you have access to your dashboard and to the different scans. And really quickly, we have found 96 issues. There is just one critical, and I can click it. And as you can see here from the right, we can highlight the issue directly in the browser, and even we can see how to fix it. It's really excellent. And now when I go to my manual reports, if I refresh here, you will see that right now instead of 3, I have 4. I think this is the best thing here, that we have the history of all of the different checks and forms. As you can see here, we can filter by the different page scans, we can filter by the different criteria, we can download the report, export to CSV, PDF, and JSON, we can share the results with someone and link that to a bug report. All right, let's move on. Now, let's discuss the importance of screen readers. Let's start by understanding why screen readers are crucial. Navigating websites or mobile apps can be challenging for users with visual or cognitive impairments. These users rely on assistive technologies like screen readers, which convert on-screen text and elements into audio and braille, helping them access digital content effectively. Testing with screen readers ensure that these users have a seamless, accessible experience, helping us catch issues that could prevent them from navigating, reading, or interacting with content. So, how screen readers function? First, you have text-to-speech. This feature translates text, buttons, and images into spoken words through the device's audio. The screen reader sends text to the TTS engine, which processes it into spoken language. It reads everything from headings and links to images with alt text, enhancing navigation. Then you have braille displays. For those who rely on touch, screen readers can convert text into braille on a tactile display. For navigation, screen readers primarily use keyboard shortcuts. Keys like tab move through elements, and enter activates them. This system is made possible through well-structured semantic HTML, meaning each heading, link, and image needs the correct label and hierarchy, as we discussed previously. Following are some of the screen readers that testers can use for accessibility testing. Though there are other screen readers available, the following are the popular ones. First, you have job access with speech. It is one of the most used screen readers and a good option for performing screen reader testing. This is compatible with Windows and supports different programming languages. You can also easily leverage the voice and speech rates with its built-in features and navigate the web via voice commands. However, it is not freely available and requires purchase to use it. Then we have non-visual desktop access. It is another popular screen reader that it's open source and freely available. It also works for Windows and allows users to access the contrast through Braille, display, or voice. In a minute, you're going to see a demo with it using the Lambda Test platform. Then we have TalkBack. It is an accessibility feature built into Android devices to help visually impaired users interact with their devices. It provides spoken feedback, allowing users to hear what they touch, select, and activate on their device screens. And then you have VoiceOver. The screen reader is specifically designed for Apple. Although highly advanced, and the QAs and developers generally don't recommend it for accessibility testing as JAWS and NVDA. So, testing with screen readers involve accessing how effectively user can navigate and comprehend our website. We want to ensure users can tap through elements and that each item like headings, links, and buttons is accurately read aloud. Testing should include ensuring alt text is provided for non-text elements like images, using appropriate heading tags for clear page structure, making sure each form field has label read by the screen reader, checking that elements are navigatable and operatable via keyboard only, verifying that link text provides clear information about where each link leads. Now, various screen readers are available in the market. However, configuring each one to meet specific user needs can be difficult. Additionally, you need to ensure cross-browser accessibility and multiple mobile devices, verifying how your website or mobile apps perform across different browser devices and operating systems. And this is where Lambda Test comes into play. When you go to desktop or virtual mobile, you can pick an operating system, browser version, and resolution. If we copy the website right here or this one, we can start. Also, you will find a link in the reference resources below that it's covering mobile accessibility testing as well. So when this virtual machine is created for you, it's really quick. As you can see, this is Chrome 130, Windows 11, this particular resolution. From the left menu here, you can click accessibility, and then we can turn on the screen reader right here. And here you can
Automation capabilities generator for Selenium and 𝒏𝒕𝒐𝒏 Lambda test. Clickable link www.lambdaTest.com link graphic. List with 5 items link live. Link automate.
Then you can turn it off after you finish the testing and we can shut down the machine. I think this is very, very good integration, right? Now, let's really briefly discuss Google Lighthouse. Google Lighthouse is a versatile auditing tool integrated into Lambda Test, providing high-level insights on performance, SEO, and accessibility. For accessibility, Lighthouse runs quick checks based on WCAG standards, flagging common issues like missing alt text, incorrect color contrast, and missing form labels. To use it with Lambda Test, simply configure the test in your dashboard and Lighthouse will run its audits automatically across different browsers and devices, with reports accessible via Lambda Test API and dashboard. Let me show you. Right here, let's find the correct. Here you can find the accessibility API. Also, we have such an API for Google White House. In a minute, we're going to cover how you can run. So here is the White House. In order to start using White House, you just need to add this capability, performance to true. Again, we already, if you watch some of the videos, part of the Advanced Test Automation Framework Development Series, we covered it in one of the videos where we discuss integration with performance analysis tools. But again, you can use it for accessibility as well. After you set this to true, you don't need to do anything else. At the end of your test execution, you will find this tab here, performance, and then under performance you will find all of these scores, and when you click on accessibility you will find all of those different checks. One more thing, since this is run particularly at the end of the test, we actually have a Lambda test hook. Again, in this series about advanced framework development, we covered extensively what the hooks are, but the hooks allow you to run some particular script so that we can instruct Lambda test to run the Lambda test White House integration at a particular point. For example, in the middle of your test workflow. And we use that again in this particular integration before for performance analysis. So you can do that, for example, bypassing the login. You can then run that and then one more time. Also, you can use some of the APIs here for fetching some of the results and then do particular assertions. I already did that. Again, I copied some of the code that we had before. You will find it here. So in this particular test, purchase test cloud, I already made it available. In a minute, when we talk about Lambda test accessibility automation, we're going to discuss mainly these capabilities. However, I also mention this performance to true so that we have Google White House report as well. And I have built this White House service. This White House service, as I said, is using the Lambda test hooks. Again, the Lambda test hooks, you can find more about them in one of the documentation links that I will provide in the description. But as I said, hooks are little scripts that allow you, for example, to set, to update the build name, to update the test name, to list some of the files, to check for file existence on the machine, etc. But also, again, generate this White House report. It's a little bit more complex here since this takes a while and we're waiting for this to return a particular result. And after that, after we have the results in a JSON format, this White House service, again, before we were parsing the results, this JSON into meaningful here objects, right? Basically, we're converting these JSON results from the White House report to C# objects or Java objects, it doesn't matter. And then we're using the builder pattern. Again, you can watch the video part of the framework series to understand more about this design. The thing that I added to this particular service is that right now we're also providing some accessibility assertions, accessibility score above, or checking for example, color contrast or out, etc. And this is how we use it. At the bottom, you can see an example. So I'm triggering and performing the White House analysis, and I can do some assertions. Without that, you will just see the numbers and everything inside the Lambda test dashboard, but you cannot fail the test, for example, if something is below a particular threshold or if you have some issues. Again, I suggest not to use this, but instead probably integrate and use the Lambda test accessibility automation. Now, if we need to compare Axe and by the way, if you configure, I want to show you one more thing before comparing Axe and White House. Here, I will give you this link just to see how this accessibility scoring is working. So to start configuring your test using the Lambda test dashboard, White House results covering accessibility scores, detected issues as you saw, and improvement recommendations are available directly within the Lambda test. If we need to maintain higher 𝑨𝒏𝒕𝒐𝒗 conformance like AAA, we can customize additional assertions using the Lambda test API, as we'll discuss in a minute. And this allows for more refined checks on specific elements or attributes. Now, White House is ideal for quick overviews, but Axe is purpose-built for accessibility testing and digs deeper into 𝑨𝒏𝒕𝒐𝒗 requirements. Axe, detailed issue report, and customizable rules offer granular insights. Where White House provides broad accessibility checks along with performance and SEO, Axe gives more focused reports and allows tests to be customized per accessibility need, making it better suited for in-depth developer-centric testing and debugging. If your goal is broad cross-device testing, Lambda test White House integration provides the scalability needed, but for developer-focused detailed fixes, Axe is more specialized, allowing you to catch and address issues at the code level. But again, if you use Lambda test automation, accessibility automation, it will contain all those information in a central place. Now let's discuss the Lambda test accessibility automated testing integration. So Lambda test accessibility automation transforms complex accessibility testing into streamlined, efficient process, making it easier for teams to maintain web accessibility standards. It integrates seamlessly with your existing test frameworks like Selenium or Cypress, enabling you to continuously check accessibility compliance as part of your CI/CD pipelines. Lambda test accessibility automation scans web pages, detects accessibility issues, and categorizes them by severity, critical, high, medium, and low, providing recommendations for remediation. So again, easy integration. To begin, simply set the accessibility to true, this capability. In a minute we are going to see the code. And Lambda test will automatically scan all URLs for accessibility issues. There is no need to change workflows. Lambda test fits right. For example, by enabling this feature, you can check for 𝑨𝒏𝒕𝒐𝒗 2.1, level A, AA, AAA compliance as your test runs. Nothing more. You don't need X builders or additional assertions. This will run directly. Another strong feature is that Lambda test also provides this DOM change monitoring. This feature automatically triggers scans whenever a web page's DOM changes, such as when a dynamic element like a carousel or modal is updated. This ensures that any accessibility issues caused by these changes are detected immediately without additional configuration. You will have this comprehensive dashboard in the demo that you will see, where all accessibility reports from both manual and automated scans are stored. The dashboard provides detailed insights into issues found, right here, and you can track trends over time, compare historical data, and see real-time accessibility metrics across different browser and devices. I think this is maybe one of the strongest points here, that you can run it across multiple devices and browsers and browser versions. If your project involves integrating data into other tools and systems, Lambda test provides an API to retrieve accessibility data. I am going to show you this in the demo shortly. This is especially useful for teams needing to fetch issues details programmatically and merge accessibility test results into their custom reporting tools. Also, Lambda test helps reduce redundant data by eliminating duplicate issues when your test suite accesses the same URL multiple times. This keeps your reports focused and concise, making it easier to prioritize fixes. Another great feature is the variety of reporting formats available. As I showed you before, you can export to PDF, JSON, and CSV, allowing you to easily share the reports with stakeholders. Plus, you can directly mark an issue as a bug in tools like Jira. From the Lambda test dashboard, simply create bug tickets for any detected accessibility issue, ensuring a smooth workflow between testers and developers. Now, let's quickly discuss anything, how to use that. So, to use with Selenium, you can find here accessibility automation. I'm going to use Selenium, but also you can check it for Cypress or HyperExecute. Again, we'll need these 4 capabilities. This is the one that you need, accessibility true. And if you want to further configure everything, the 𝑨𝒏𝒕𝒐𝒗 version, best practice needs to review, you can do it from here. After that, here my tests. Also, as I showed you, there is this API accessibility testing, and you can get the by test ID all of the issues, and you can fetch them. I'm going to show you how this works. So if you go to our tests, you will find here test cloud, and then above, again, I made all of the configurations that you need to execute those tests in Lambda tests. You just need to set this environmental variable for your user and access key. Again, probably you will need to turn off the Google White House, this performance, if you wish, if you're going just to use it for accessibility. Then we need these 4 keys as we discussed, and then nothing else is needed. I mean, you just need to run the test and you will see the result. I already executed the test, obviously, and right here, these were our manual reports. And here, if I click automation reports, you will see that I have many runs here for some of my tests. We can filter, as we discussed before, by the different levels, 1A, AAA, whether it's critical or medium. We can see all of the issues right here. Again, we can filter them and apply like that. When we click, again, the great thing is that you see some examples, some of the elements that you have problem with, and then you have a fix. And as we discussed, you can download from here and export to PDF, JSON, or CSV. You can share it, you can walk a bug, and again, you can filter from here. If you want to use the API that explained that you have access to, if you watch, you will find a link to, again, this advanced series about creating advanced test automation frameworks. There, in details, I explain how from this Swagger we can generate these API clients. Here I haven't created an API for all of the Lambda test APIs. I just created one for the session, the White House API, and the one about accessibility. And I'm using here REST-sharp. And this is basically an SDK, a client, for making this HTTP request to the API. Why we need the session? You need the session to get the session details. providing the session ID that we get from the remote WebDriver. Then when you have the current session right here, we call Accessibility API client, and this get test issue data async, and you need to mention the current test ID. And after that, you have access to test info and total issues, and you have access to all the fixes and everything that you see on the dashboard. Also, right here, I have created a data-driven test where I just run multiple times for all of those URLs, and I populated the dashboard automatically, which is excellent. So Lambda test accessibility automation transforms the complexity of accessibility testing into a simplified, more manageable process. It fits effortlessly into existing testing frameworks, supporting teams, and maintaining key accessibility standards without disrupting the workflow. This tool is pivotal for developers aiming to deliver inclusive web experiences efficiently. Today, we explored the critical aspects of accessibility and its impact on user inclusivity, focusing on tools and standards that make digital content more maintainable to everyone. We began with an overview of what is accessibility, accessibility principles, and why 𝑨𝒏𝒕𝒐𝒏 Web Content Accessibility Guidelines are essential. We discussed major accessibility walls like ADA and Europe Web Accessibility Directive, which reinforms the importance of accessible design. Next, we delved into the WAI ARIA patterns, enhancing the functionality of interactive elements for screen readers and keyboard users. Then we demonstrated using Axe and Google White House tools for accessibility checks, each providing unique insights for developers and testers. Lambda test accessibility automation was introduced, offering robustness, cross-browser accessibility testing, compliance monitoring, and detailed issues reporting, all while seamlessly integrating with the CI/CD pipelines. We also saw the Lambda test accessibility DevTools plugin and the Lambda test feature for supporting screen readers across a wide range of devices. Our goal was to highlight how these tools ensure a more inclusive web experience, helping us build accessible applications that serve a diverse user base effectively. Hi guys, greetings from Bulgaria. I'm Anton, and in this video we're going to talk about automated security testing with Selenium, and we're going to combine it with OWASP 𝒏𝒕𝒐𝒏. But before we begin, first check the Awesome Lambda Test YouTube channel, hit the ring bell, subscribe so that you get notified when new videos are published each week. Also check the Awesome Lambda Test blog, because there are many detailed articles that can help you to be a much better test automation engineer. In the links below you will find reference resources like articles, YouTube videos, and GitHub repo to the source code with all of the demos that I'm going to present to you. You will find also jump links to particular sections of the video so that you can skip some parts if you want. Here is what we are going to cover. First, we are going to talk about why web security testing matters. We're going to discuss the OWASP and the common top 10 attacks very shortly. Then the major thing will be about talking about the tool called OWASP 𝒏𝒕𝒐𝒏 or Z attacking proxy. And we're going to see it in action. Manually, we're going to test a website. Then we're going to integrate its daemon or headless mode with its web API with our Selenium tests. And I'm going to show you after that how we can combine it with Lambda tests to know and execute all of those tests in the Lambda test cloud. Lastly, shortly, we're going to discuss how we can integrate all of that in continuous integration pipelines such as GitHub Actions. So, why web security testing matters? Here are some reasons. Web applications are frequent targets for cyber attacks. According to the last year 𝑨𝒏𝒕𝒐𝒏 vulnerability statistics report, over 33% of vulnerabilities discovered were of a high or critical severity, highlighting significant security gaps in web applications. Web applications are some of the most common targets for cyber attacks today, and studies show that over 40% of all cyber attacks target web applications, and in some industries like healthcare and e-commerce, this percentage is even higher. And what's more, around 76% of web applications have at least one critical security vulnerability. These vulnerabilities can be things like insecure configurations, old libraries, or input fields that aren't properly checked. They might seem small, but they're easy for attackers to exploit and can cause huge problems for businesses. To help us understand these risks, there is something called OWASP Top 10 that we're going to discuss in a minute, which lists the most critical security issues for web applications. It's a great starting point if you want to know where your app might be at risk. Now, security breaches can have severe consequences. The last year IBM cost report, data breach report, indicates that the global average cost of a data breach reached 4.45 million. This is all-time high. And beyond financial losses, breaches erode customer trust and damage reputation. For instance, in a famous breach in 2017, exposed personal information of over 140 million people, leading to significant financial penalties and a lasting impact on company reputation. Now, with so many risks, security testing has become essential. In the past, most security testing was done manually, often at the very end of development. But in today's fast-paced world, that's not enough anymore, and vulnerabilities need to be found and fixed early, continuously. This is where automated security testing comes in. By using tools like OWASP 𝒏𝒕𝒐𝒏, you can scan your application for vulnerabilities as part of your development process. And when you combine 𝒏𝒏 with tooling like Selenium WebDriver, you can automate real user interactions, bypassing authentication, and check for security flaws at the same time. For example, you can integrate automated security testing in your CI/CD pipeline. That means every time your team makes a change to the application, it gets tested for vulnerabilities. It's faster, more reliable, and much easier to scale. Keep in mind, automated security testing doesn't replace manual penetration testing. It's just your first line of defense, catching and fixing the obvious issues early so that you have few risks to worry about later. Now, let's understand the OWASP common attacks. First, let's discuss what is OWASP. Let me show you a very important website. I'm going to give you, this is the website of OWASP here. So the Open Web Application Security Project, or OWASP, is a global non-profit organization dedicated to improving software security, and it provides free resources, tools, and community-driven projects to help organizations develop and maintain and operate secure applications. One of OWASP's most recognized contributions is this OWASP Top 10, a regularly updated list highlighting the most critical security risks to web applications. We're going to check it, some of the, for example, top 5 and discuss the rest. But when you open, for example, injection, here you're going to see some statistics. You have the overview, descriptions, how to prevent it, some attack scenarios, and many other relevant resources. So let's discuss some of the top 10. For example, SQL injection. SQL injection occurs when attackers insert malicious SQL queries into input fields, allowing unauthorized access to the database. For example, an attacker enters this script below into a login form, bypassing authentication and gaining access to user data. Of course, this is a very simple example. And a real-world incident in 2012, a major breach exploited SQL injection to access millions of user records. Then we have the cross-site scripting. Cross-site scripting attacks involve injecting malicious scripts into web applications viewed by other users, potentially stealing session cookies or defacing websites. And as an example, an attacker posts a comment containing the script, which executes when other users view the comment. In 2014, a popular social media platform suffered a cross-site scripting attack that spread a malicious worm to millions of users. Then we have insecure deserializations. This vulnerability arises when untrusted data is deserialized, leading to remote code execution or privilege escalation. And the example here is that the attacker manipulates serialized objects to execute arbitrary code on the server. In 2015, a vulnerability in a widely used library allowed attackers to exploit insecure deserialization affecting numerous applications. And by the way, to prevent that, you can check one of our previous videos about security best practices, part of the framework, advanced framework development course. And there we discussed another popular OWASP tool for scanning for such library vulnerabilities in our frameworks. Then we have security misconfiguration. This occurs when security settings are improperly configured, leaving application vulnerable. And this is usually the usual example is leaving the default credentials unchanged or enabling unnecessary features can expose the system to attacks. In 2018, a major data breach resulted from misconfigured cloud storage, exposing sensitive customer information. And here are other relevant attacks part of OWASP top 10. You have the broken access control. This is high frequency and impactful. Here the example is that unauthorized users can access the admin panels. You have cryptographic failures. This is like data exposure risks, storing passwords without encryption. You have vulnerable and outdated components. This is very common in modern development. For example, using an old library with known vulnerabilities. You have identification and authentication failures. This is allowing quick passwords or failing to enforce multi-factor authentication. We cover multi-factor authentication and how you can bypass that, or in another series about single sign-on, passwordless login. You can check them. I will put the links below. You have security logging and monitoring failures, missing logs for failed logging attempts, and you have server-side request forgery. This is a newer high-risk category in the top 10. This is when an attacker manipulates a server to fetch internal resources. I suggest and I encourage you to check the website of OWASP Top 10 and to read them very carefully. Also, keep in mind that this is out of the scope of this particular tutorial, but on this website you can find information about OWASP mobile application security. You have a very detailed guide about web security testing, and also there a similar guide about web API security testing. Now, introduction to OWASP 𝒏𝒕𝒐𝒏. Let's now cover what is OWASP 𝒏𝒕𝒐𝒏. You can find it on this website, 𝒏𝒕𝒐𝒏 𝒨𝒐𝒏. So OWASP 𝒏𝒕𝒐𝒏 or 𝒨𝒐𝒏, it's a powerful open source tool for finding security vulnerabilities in web applications. It's developed by OWASP and it's widely used by security professionals and developers for testing web application security. And here I listed some of the core features. So you have the proxy server. �𝒏 can act as a proxy between your browser and the web server, allowing you to intercept and inspect HTTP and HTTP traffic in real time. And this is useful for analyzing how your application communicates and identifying any data that shouldn't be exposed. You have automated scanners, which include both active and passive scanning tools. The passive scanning identifies vulnerabilities without altering data, while active scanning simulates attacks such as SQL injections or cross-site scripting to test for weaknesses. And �𝒏 offers a suite of manual testing tools like a spider for crawling and identifying content, a fuzzer to test input fields, and a port scanner to check for open ports. To get started, you can download the tool. Also, you can check the Getting Started guide about the GUI version, and in a minute we're going to discuss the different modes. One of the key strengths of �𝒏 is its ability to integrate with automation tooling like Selenium WebDriver. By integrating �𝒏 with Selenium, you can automate security testing as part of your functional test suites. With �𝒏 running in the background, every Selenium test can be used to identify security vulnerabilities automatically. Selenium allows you to mimic real user actions, while �𝒏 scans each interaction. And this combination helps identify vulnerabilities in real user flows, not just in isolated requests. And �𝒏 can be configured in CI/CD pipeline to automatically scan every deployment, providing immediate feedback if a security issue is introduced. We are going to see that at the end by integrating with GitHub Actions. And �𝒏 operates in two different modes depending on your testing needs. You have the standalone mode, the GUI version that we're going to see in a minute. This is the default mode with the full GUI. You launched �𝒏 on your local machine, and let's actually do that. I have it started here in daemon mode. This is the headless mode. And here is my pre-installed version that will start in a minute. So the default mode with the GUI here, it's starting. Your launch of �𝒏 on your local machine, it provides this interface where you can manually inspect the traffic, configure alerts, you're going to see a demo in a minute, configure scans, and interact with the application in real time. And the previous mode, the headless or the daemon mode that you saw before that, �𝒏 runs without the GUI version, making it ideal for automated testing. And this is the mode that we are going to use in the integration with Selenium and Lambda test. You can control the �𝒏 through its REST web API. In the next demo, we are going to create an SDK HTTP client to work with this web API, and we're going to trigger scans after we navigate to a particular page. So yeah, we can run the scans, we can get the different alerts. That's it. So let's go over some of the common use cases of �𝒏. We can perform automated scans or manually explore. As we said, we have the active scanning. This simulates attacks on your application. And you have the passive scanning. This mode analyzes traffic passively without modifying the data. So, to begin using the �𝒏, you need to install it from the website. After that, you have right here pre-configured usage of the browser. In this case, I'm going to use Firefox. This will configure 𝒏𝒕𝒐𝒏 as proxy automatically for you. Right here, it will also install the necessary certificates to decrypt HTTPS traffic. And we're going to use this application that comes from the project itself. It's like a website with particular security vulnerabilities, right? So that we can see some alerts. And I'm going to navigate to this website right here. Right now, 𝒏𝒕𝒐𝒏 is working in this passive scanning mode, where it already analyzed part of my traffic. So this is exactly what we are going to automate in our Selenium test later. I'm going to search here for this apple juice. So I'm going to type apple juice. After I dismiss this cookie banner, I'm going to press enter. I'm going to open this pop-up. This is enough. And now let's see what's going on here. As I said, right now this 𝒏𝒐𝒏 tool is working as a proxy and it's recording all of my requests. At the bottom we have this alerts tab right here. And when we click on it, you can view all of the different security problems that 𒒏💕 detected for me. When you click on a particular risk alert, you're going to see a full description, the source. We have a suggestion how for a solution, some references, all that. Besides that, when you click here, right-click on the website here, you can see all of the websites that were detected in this passive mode. We can here start an active scanning, and we can pick different policies. There are many configurations, they're out of the scope, but if you're curious, you can check their detailed documentation. And right now, when you click active scanning, as we discussed, this will trigger this active scanning. Again, this simulates attacks on your application to find vulnerabilities. For example, 𒒏💕 will try SQL injection, cross-site scripting to see whether your application, whether it's protected or not. And you can see the percentage here. I'm going to stop that now. I'm going to stop it. Yeah. So another thing that I want to show you is that we have here, when you go to tools, you can see that we can browse the API. When you browse the API, when we click that, this website will open. It's right here. As you can see here, right now it's running on localhost 8081. This is you can use the REST web API of 𒒏💕 with the GUI version. But again, later we are going to use the headless mode that I'm going to show you in a minute. When you click here, the local API, you will find like information about how to use all of the different endpoints here and automation capabilities. I already play with it. Like here, I have created a particular scans with. I'm going just to change the port again. When you run in headless mode, we are going to use this 8088 port, but right now we are going to use 8081 because we are going to use the web API through the GUI mode. So if you want to start the spider, we need to make a GET request against this localhost 8081 JSON spider action scan. Now, there are a few important points. First, you need to set here as a query parameter the website that we want to spider or to later scan, right? And we need to say recursive false. We're going to say that in our Selenium scripts as well. When you go to authorization, this is maybe the most important part, you need to set this API key. Of course, I'm going to regenerate that, but from where you can get this? Well, when you go to Tools, Options, inside Options, you will see here that you have API. When you click on API, you will see that you have auto-generated API key. I encourage you to copy this key or generate a new one and set it as environmental variable, or later you can put it in your 𝑨𝒏𝒕𝒐𝒏 security or key vault and use it like this. So I copied this key from here, and now we can use the API. So I can execute the command, and as you can see here, we have a response as JSON. In order to perform an active scan, you read in the documentation that first we need to crawl the website itself. So this is the first action. Then let's delete so that you're sure that I'm going to clear now the spider and the active scanning. I'm going to clear all of the alerts from here, and I'm going to, so let's trigger now an active scan from the web API. As you can see here, we have an ID. We have an ID of 1, and if we open the UI, and if we go to active scan, as you can see, the active scan started, and right now is 38% of completion. And we can check the actual current scan. You need to get the ID. This is the scan ID here. So we have another method like eScan view status, and we need to provide, instead of a URL, we need to provide the scan ID equal to 1 or the actual ID. And when you click send, this will return the percentage. Right now it's 38. Also, we can view all of the current alerts. There is another endpoint, JSON core view alerts, and we need to mention the URL. This is how we're going to get them in our Selenium test as well. As you can see, since the active scan is not ready yet, it's empty for now, but later this will be like a full ball array of JSON objects when this is complete. Right now, as you can see, it's 58, and later we will have alerts. I will leave it for now, or we can stop it. As you can see, we don't have alerts. This is why the API is returning 0. Anyway, later we are going to view that. And now, if we want to start, if I close now the 𝒏𝒕𝒐𝒏 UI, I'm going to stop it. I'm going to start now and run the headless mode, which means that 𝒏𝒕𝒐𝒏 will run without the GUI, making it perfect for automation, and this way we can fetch all of the results. Now, if we navigate here, we need to open the command line. You will notice that in this folder we have this bat file. This is what we are going to use to start it in a headless mode, and we need to use, this is the Lambda test here. 𝒏𝒕𝒐𝒏 bat daemon port. This is the port. As you can see, it's different, 8088, and we mentioned the host. So when I start that, it will take a few seconds to initialize everything, and it will start 𝒏𝒕𝒐𝒏 in this headless mode. We need just to wait until we see that it's listening on the port like that. 𝒏𝒕𝒐𝒏 now is listening on port 8088. And now if we open Postman again, we can just change the port here and send the request again. As you can see, it's returning 0 and now 1. And again, I'm going to change the port and start an active scan. And I can view now, when I change the port here, I can view the current status. As you can see, it's 38. And a little bit later, we'll be able, for example, we can view all the websites, as I said, that have been scanned until now. As you can see here, this should return just shop. And for the alerts, maybe we will, until the scan is ready, probably we won't have. Oh, we have them. As you can see here, it's a very big array of JSON objects, and we are going to deserialize that later to Java objects so that we can assert them, etc. Now let's switch to our Selenium integration, right? So let's switch to our integration with Selenium. You can download the full source code. Now, this is a regular Maven project in Java. I have installed, pre-installed like JUnit, Selenium. We use rest assured for the API calls. That's it. So, standard stuff. Right here in the before each, what we do? First, we need to start the headless mode of 𝒏𝒕𝒐𝒏. That's obvious. Again, I put this as a backward compatibility if you use older version of Selenium. If you use 4.11 and above, all new versions, you don't need WebDriver Manager, it's built in. After that, one very important, if you need to locally run this integration, you need to put this thing here. If we use Chrome or Edge, we need to mention add arguments proxy server, and we need to mention localhost 8088. If you use the GUI version, you need to use 8081. After that, we start Chrome, we maximize, we navigate to the Juice Shop. In order to hide the cookie banner, I apply this cookie. Again, the actual Selenium code here is not important. I'm just performing the search for the apple juice. Right here, I'm typing and I'm opening the pop-up. Again, this is not important. The important part is here in this 𝒏𝒕 service. What is this 𝒏𝒕 service? The 𝒏𝒕 service is a class. This is an SDK, like an HTTP client for our for working with our web API. Again, this is not a best practice to put and hardcode these links. If you watch my course about framework, creating an advanced test automation framework, we have a dedicated lecture about creating configurations and security best practices. We need to move that to the configurations. And still, I get the 𝒏𝒕 API key from environmental variable. So, how we work with the web API? Very easy. We use rest assured, this very popular library for working with web APIs in Java. So, in a hash map, I'm setting the same query parameters, the API key, the URL, and these recursive options to false. Then we are setting the parameters, making the GET request against the base URL, and this endpoint, which is again similar, JSON escan action scan, the same thing that we did with our Postman. So this is the first thing. Of course, first be sure as a homework you can create one more method for crawling using the spider request to spider the website, and then you will be able to scan the current page. I already did that, so this will work. Then for get alerts, we're doing the same thing. We're setting as a query parameter as the API key and the URL. Then we're making get requests to the alerts endpoint, and you will receive as a JSON this thing here, like this JSON array of alerts, and we're deserializing them to this 𝒏𝒕 alert response using the JSON library. What is this JSON alerts? 𝒏𝒕 alerts response. It just contains a list of 𝒏𝒕 alerts. 𝒏𝒕 alert is just a POJO, plain object Java class, containing just these variables that are part of the JSON, and we use this 𝒏𝒏𝒐𝒏 annotation that will create automatically for us getters, setters, and constructors for this. And basically this will convert, this JSON library will convert this JSON response to Java objects, and we can work with them. This is why we have here a getter to these alerts. Then we have one more method for generating HTML report. That's not something built in, but I'm doing it. As you can see here, we're just generating the HTML and we can save it somewhere. How this looks right here, this is a sample 𝒏𝒕 scan report. This is my custom implementation, but you can work with JSON versions as well. Of course, it depends. This is just great for visual representation. That's it. And at the end of my SDK, I added, or service, I added some assertion methods. For example, we can check that, assert that some alerts are present. We can check that there are no high risk alerts. We can check that all the alerts are below particular risk, or that all of the alerts have solutions. Again, we use here Stream API, and otherwise we are throwing some assertion exceptions. That's it. And as you can see, normally we are just navigating to the website, performing all of our actions. This is pretty useful when, especially when all of the logic is behind authentication, right? Because if you perform the active scan, it cannot bypass the login. But with this integration, you can do that, and you can scan any page on your website. And by the way, you can use the 𝒏𝒕 web API for security testing web APIs as well. So we are calling 𝒏𝒕 current to scan the current page. We can generate the report, and after that, we are performing all the asserts. That's it. And now, if we want to integrate all of that with Lambda test, it's very easy, relatively easy. You need to, I'm going to give you a link to this in the description below. You will find it. You need first to, in order to execute the same test in Lambda test, you need to install and configure the Lambda test tunnel, which will allow local application or environments to be securely tested using Lambda test cloud infrastructure. And when working with OWASP, you can route all the traffic through 𝒏𝒕 for security scanning. So the first step is again to run �𝒏𝒕 in daemon mode or headless mode. Then you need to configure the Lambda test tunnel. Let me show you how we can do that. I already work with the support to help me do that. So this is the command, Lambda test tunnel. You can download it from the documentation that I showed you. As environmental variables, I'm setting my Lambda test username and access key. I am setting a tunnel name that we're going to set in the Lambda test capabilities. We're saying that we're using a proxy host, which is in this case localhost, and a proxy port. And we need one more option, which is this option, ingress only. So again, proxy host specifies the proxy host address to route traffic through this host, then we need to say proxy port, which in our case is 8088. This is the port of our 𝒏𝒕𝒐𝒏 daemon. So you need to make sure that it matches. For example, if you use the GUI version, it will be different port. And this ingress only is very important. I didn't know this command, but I worked together with awesome Lambda test support, and these guys helped me to find this. Before that, this couldn't work. So this restricts the tunnel to only accept inbound connections. The ingress only mode, the tunnel allows Lambda test cloud browsers to access the local machine. For example, your test server, OWASP proxy, or a local environment, but does not allow the local machine to initiate outbound connections through the Lambda test. This is useful for securely testing internal environments or proxies like 𝒏𝒕𝒐𝒏. And if we start that, the tunnel will start. Again, you need to make sure in 𝒏𝒏 to export the root CI certificate and install it. And I can show you that actually this is part of this website. You can find this certificate here. You can download the certificate and install it. Also, one more thing about configuring properly the tunnel. Maybe depending on your firewalls and antivirus software, maybe you need to whitelist some of these IP addresses. I had to do that. Again, if something is not working for you, I suggest to work together with the awesome Lambda test support. These guys will definitely help you. I already executed this test, and let me show you how this works. So in this second file, just shop 𝒏𝒕𝒐𝒏 test cloud, you will find a working demo for the Lambda test cloud. You need to comment the proxy server Chrome options. You don't need them because we use the Lambda test tunnel. The things that you need to mention here is that you need to say tunnel to true, and you need to mention the tunnel name, which is something optional. And the rest of the test is absolutely the same. So we can execute the test. Sometimes, by the way, keep in mind that this website that comes with OWASP is not working properly because many people use it, and obviously they are running active scans. Sometimes some of the tests might fail because of this, because the website is not available. But again, the test is running here. Everything runs, and it's awesome. As you can see, everything has been executed. The test is green. We performed all of the 𝒏𝒕𝒐𝒏 assert alerts. And now, one last thing, as I promised, let's see GitHub Actions demo. There are a few resources that I'm going to give you in the description below. They're regarding the Lambda test tunnel action, and you will have a few URLs to the official GitHub Actions for this action full scan, which are basically options to integrate well with GitHub Actions pipelines. You will find here in this folder, which is workflows, two files. If you use the self-hosted version or non-self-hosted version. For the non-self-hosted version, as you can see, we have a few steps here. We need to check out the code. Also, you need to run here 𝒏𝒕𝒐𝒏 in daemon mode. Obviously, you need to do that somehow. You don't have it installed, and this is why we use Docker command to run it there. And you can pass the secret from GitHub Actions. Also, we use this special Lambda test official configuration for GitHub Actions to start the tunnel. And also, if you don't use this integration with Selenium, but just want to scan particular public URLs of your website, you can use these official actions that I showed you. You have a full scan, you have the report, you can publish the report here. And don't forget to stop the daemon and the tunnel. And also you can use the self-hosted version. This means that you run an agent on your private machine. Then we can start again the daemon mode in Docker, but again it will be a little bit tricky how you call the web API. You need to check the IP addresses, whitelist them, and work with your admin on Azure DevOps engineers. So again, you can, if you want to play it at home, you can directly start 𝒏💕 in daemon mode, like we used to do that in the demos. Then again, similarly, you can use the pre-configured action of Lambda test, or you can use the 𝑣𝒏𝒕𝒐𝒏 with all of the rest arguments that I showed you before. And yeah, after that, you just need to make sure to run and execute your tests and maybe publish the HTML report in your GitHub action pipeline, or maybe you can send it as an email. That's it. Many exciting things. So in this tutorial, we saw how and why it's important to do security testing and automated security testing in particular. We discussed what is OWASP, and we saw and discussed some of the top 10 OWASP vulnerabilities for web applications. Also, we saw how we can use the 𝒏 attacking proxy for active passive scanning. We saw and discussed how we can use the web API and how we can integrate that very well with our Selenium tests to bypass authentication and reuse our end-to-end tests together to do these automatic security checks as well. And at the end of the tutorial, I showed you how we can integrate this with GitHub Actions configurations.